Welcome, we're so happy you tuned in tonight. Before we get started, I'd love to know, where are you watching from? Drop it in the comments. Now, let's get comfortable and drift into deep, peaceful sleep together. The universe is made of atoms, and atoms are made of even smaller pieces, and tonight we're going to explore them all in the quietest way possible. An atom is one of the smallest building blocks that still keeps the identity of an element. When you touch a piece of copper, you're touching countless copper atoms. When you breathe in oxygen, you're drawing oxygen atoms into your lungs. The word atom comes from an ancient idea meaning uncuttable, a historical guess that matter had a smallest piece that couldn't be divided any further. For thousands of years, people wondered if you could keep cutting something in half forever, or if eventually you'd reach a final, indivisible fragment. The atom was imagined as that final piece, though we now know atoms themselves contain even smaller components. Still, the name stuck, and it's a useful one. Most everyday objects are made of atoms bonded into molecules and solids. The wood of a table, the fabric of a blanket, the glass of a window. All of these are atoms linked together in various arrangements. Atoms are so small that a single grain of sand contains an unimaginable number of them. If you tried to count the atoms in just one grain, you'd be counting for longer than the universe has existed. That's how tiny they are, and how many of them cluster together to make even the smallest visible speck. Every atom has a tiny center called a nucleus. This nucleus is the atom's heart, its anchor point, the place where most of its mass is concentrated. The nucleus contains protons and neutrons. These are the particles that give the nucleus its weight and its identity. Electrons occupy the region around the nucleus. They're much lighter than protons or neutrons, and they move through the space surrounding that central core. Protons carry a positive electric charge. This positive charge is fundamental to how atoms interact with each other and with the world. Electrons carry a negative electric charge, because opposite charges attract. The positive protons and negative electrons are drawn to one another, which is part of what holds an atom together. Neutrons have no net charge, which helps stabilize many nuclei. Without neutrons acting as a kind of cushion or glue, many atomic nuclei would fly apart due to the repulsion between positively charged protons. An element is defined by the number of protons in its nucleus. That number is the only thing that determines what element you're dealing with. Hydrogen has one proton, so it's the simplest element. Every hydrogen atom in the universe, whether it's in your body, in a distant star, or drifting through the void of space, has exactly one proton in its nucleus. Carbon has 6 protons, and that 6 is its atomic number. If you see the number 6 on the periodic table next to carbon, that's telling you every carbon atom has 6 protons. Change that number, and you no longer have carbon. You have something else entirely. If an atom gains or loses electrons, it becomes an ion. Atoms don't always keep a perfect balance of protons and electrons. Sometimes an atom will give up an electron, leaving it with more protons than electrons, which makes it positively charged. Sometimes an atom will gain an extra electron, giving it more electrons than protons, which makes it negatively charged. These charged atoms, ions, play crucial roles in chemistry, in electricity, in biology. Your nerves work because ions move in and out of cells. Batteries function because ions flow from one place to another. Atoms in your body are the same kinds of atoms found throughout the Earth and stars. The carbon in your skin is the same carbon found in a diamond, in a tree, in the atmosphere of a distant planet. The oxygen you breathe is the same oxygen that once bubbled out of ancient oceans. There's something quietly profound about that. Atoms don't belong to you or to any one place. They're universal travelers, endlessly recycled, endlessly repurposed. Just one more small fact, and then we drift a little deeper. Atoms are mostly empty space compared to their overall size. When you picture an atom, you might imagine something solid and compact, but the truth is quite different. The nucleus is extremely tiny compared to the atom's full footprint. If you could zoom in and measure the distances involved, you'd find that the nucleus occupies only a minuscule fraction of the atom's total volume. If the nucleus were the size of a pea, the atom could be the size of a stadium. That's a common scale analogy, and while it varies depending on the atom, it gives you a sense of the proportions. The nucleus is a tiny speck, and the electrons are somewhere out in the vast surrounding space. You don't fall through the floor because electrons repel each other. Even though atoms are mostly empty, They don't just collapse into one another or pass through each other like ghosts. When you sit in a chair, the atoms in your body and the atoms in the chair don't merge. Instead, the electrons in your atoms and the electrons in the chair's atoms push against each other. Touch is mostly the feeling of electromagnetic forces, not atoms physically interlocking like hooks. When you press your hand against a wall, you're not actually making contact in the way it feels. You're experiencing the repulsion between electron clouds. It's an electromagnetic sensation, a force field pushing back. The space around the nucleus is described as an electron cloud, a probability region. Electrons are not little planets on neat circular tracks in the modern picture. That old image of an atom, with electrons orbiting like tiny marbles around a central sun, was an early model and a useful one for its time, but it's not quite right. Instead, electrons occupy orbitals, which are shapes where they're likely to be found. An orbital is a region of space where an electron spends most of its time, but it's not a fixed path. The electron doesn't trace a neat circle or ellipse. It exists in a kind of fuzzy probability cloud, appearing here and there in a way that follows the rules of quantum mechanics. Atoms can be excited when electrons gain energy. If you shine light on an atom, or heat it up, or hit it with another particle, an electron might absorb some of that energy and jump to a higher orbital, farther from the nucleus. When electrons drop back down, atoms can release light, photons. The electron can't stay in that higher excited state forever. Eventually it falls back down to a lower orbital, releasing the extra energy as a particle of light. That released light can give each element a distinctive spectral fingerprint. Every element emits light at specific wavelengths when its electrons jump between orbitals, and those wavelengths are unique to that element. Scientists can look at the light from a distant star, see which wavelengths are present, and determine what elements the star contains, even from billions of light years away. The colours in neon signs come from atoms emitting specific wavelengths of light. When electricity flows through the gas inside a neon sign, it excites the electrons in the neon atoms. Those electrons jump to higher orbitals, then fall back down, releasing light. Neon gas glows a characteristic reddish-orange. Other gases glow different colours. Argon produces a soft blue, helium gives a pale yellow, and so on. Much of chemistry is the story of how atoms share or trade electrons. Chemical bonds form when atoms interact through their electrons. Sometimes atoms share electrons, creating a covalent bond. Sometimes one atom gives up an electron to another, creating an ionic bond. The details vary, but the principle is the same. Chemistry happens in the outer regions of atoms where electrons meet. The solidness of matter is a stable balance of attraction and repulsion. Objects feel solid because their atoms are held together by forces that keep them from collapsing inward or flying apart. The electrons repel other electrons, the nuclei attract the electrons, and all these forces balance out to create structures that hold their shape. Even while you rest, atoms are vibrating gently with thermal motion. Nothing is perfectly still. At the atomic level, there's always movement, a constant jiggling, a faint hum of energy. The warmer something is, the more vigorously its atoms vibrate. Just one more small fact, and then we drift further. A molecule forms when atoms bond together. Atoms rarely exist in isolation for long. They tend to link up, forming stable partnerships. Water is H2O, 2 hydrogen atoms bonded to 1 oxygen atom. It's one of the simplest and most important molecules, and it's everywhere. In your cells, in the oceans, in the air as vapor frozen in glaciers. Oxygen likes to form 2 bonds in many common molecules. The oxygen atom has a particular electron configuration that makes it stable when it shares electrons with 2 other atoms. In water, oxygen bonds with 2 hydrogen atoms. In carbon dioxide, oxygen bonds with a carbon atom that's also bonded to another oxygen. Carbon can form 4 bonds, which is one reason it supports complex life chemistry. Carbon's ability to bond with 4 other atoms at once allows it to create long chains, branching structures, rings, and intricate 3-dimensional shapes. This versatility is why organic chemistry, the chemistry of carbon-containing compounds, is so rich and varied. Your DNA, your proteins, your fats, your sugars, all of them are built on carbon backbones. Salt or sodium chloride isn't made of individual molecules in a crystal. It forms a repeating ionic lattice. When sodium and chlorine atoms come together, the sodium gives up an electron, and the chlorine accepts it. The resulting charged ions, positive sodium and negative chlorine, attract each other strongly, and they arrange themselves in a regular repeating three-dimensional grid. Table salt crystals often look cube-like because their atoms arrange in a regular cubic pattern. If you examine a grain of salt under a microscope, you'll often see tiny geometric cubes, each one a reflection of the underlying atomic arrangement. Metals conduct electricity well because some electrons can move more freely through the structure. In a metal, atoms are packed together in a way that allows some of their electrons to drift from atom to atom, creating a kind of electron sea. When you apply a voltage across a metal wire, these free electrons flow, carrying electric current. Diamonds are carbon atoms bonded in a very rigid network, making diamond extremely hard. Every carbon atom in a diamond is bonded to 4 other carbon atoms in a tight three-dimensional lattice. This structure is incredibly strong, which is why diamond is one of the hardest natural materials. Graphite, which is also carbon, is soft because its atoms form layers that slide. In graphite, carbon atoms bond in flat sheets, and those sheets stack on top of each other like pages in a book. The bonds within each sheet are strong, but the sheets themselves can slip past one another easily. That's why graphite is used in pencils. When you write, layers of graphite peel off and stick to the paper. The same element can create different materials depending on bonding and structure. These are allotropes. Carbon can be diamond, graphite, or even buckyballs and nanotubes, depending on how its atoms are arranged. Glass is often an amorphous solid, meaning atoms are solidly packed but not in a neat repeating crystal. Unlike a salt crystal or a diamond, glass doesn't have a regular, orderly atomic structure. The atoms are locked in place, making it solid, but they're arranged somewhat randomly, like a frozen liquid. Ice is less dense than liquid water because its hydrogen bond structure creates extra open space. When water freezes, the water molecules arrange themselves in a crystal lattice that's more spread out than the loose jumble of molecules in liquid water. That's why ice floats. It's slightly less dense than the water beneath it. Your breath is a moving mix of molecules, mostly nitrogen and oxygen, each built from atoms. The air you inhale is about 78% nitrogen molecules, 21% oxygen molecules, and small amounts of other gases. Each breath is a quiet transaction. You bring in oxygen to fuel your cells, and you release carbon dioxide, a waste product of metabolism. Smells happen when airborne molecules bind to receptors, tiny molecular fits. When you smell fresh bread or cut grass or coffee, molecules from those sources drift through the air, enter your nose and lock onto receptor proteins. Each receptor is shaped to recognize certain molecular structures, and when a match occurs, your brain registers a scent. Taste is chemistry too. Atoms arranged into molecules that your body can recognize. Sweetness, bitterness, saltiness, sourness, umami, each of these. Sensations comes from molecules interacting with taste receptors on your tongue. A sugar molecule binds to a sweet receptor. A hydrogen ion binds to a sour receptor. The sensation of flavor is a kind of molecular conversation between the food and your sensory cells. Just one more small fact, and then we drift even further. Atoms of the same element can have different numbers of neutrons. These are isotopes. Remember, an element is defined by its number of protons, but the number of neutrons can vary. Carbon-12 and carbon-13 are both carbon, because both have 6 protons. Carbon-12 has 6 neutrons, and carbon-13 has 7. They behave almost identically in chemical reactions, but they have slightly different masses. Carbon-14 is a radioactive isotope used in radiocarbon dating. It has 6 protons and 8 neutrons, and it's unstable. Over time, it decays, changing into a different element. Radioactivity happens when an unstable nucleus changes to become more stable. Some combinations of protons and neutrons don't hold together well. The nucleus is a bit too heavy, or the balance isn't quite right, and it rearranges itself. This change can release particles or energy, like alpha particles, beta particles, or gamma rays. An alpha particle is a cluster of 2 protons and 2 neutrons. A beta particle is an electron or positron. A gamma ray is a high-energy photon. The time it takes for half of a radioactive sample to decay is called its half-life. Some half-lives are fractions of a second, others are billions of years. Carbon-14 has a half-life of about 5,130 years, which makes it useful for dating organic material that's thousands of years old. Potassium-40 is a naturally occurring isotope inside Earth that contributes to internal heat. Deep within the planet, radioactive isotopes like potassium-40, uranium-238, and thorium-232 decay slowly, releasing heat. That heat has kept Earth's interior molten and drives the movement of tectonic plates. Many smoke detectors use a tiny amount of americium-241 to help detect smoke particles. The americium emits alpha particles, which ionize the air in a small chamber. When smoke enters the chamber, it disrupts the ionization, and the detector sounds an alarm. The amount of radioactive material is very small and safely contained. Medical imaging and treatments sometimes use controlled radioactive isotopes under professional care. Technetium-99 Mg is used in diagnostic scans. Iodine-131 can treat certain thyroid conditions. These isotopes are chosen because they emit the right kind of radiation at the right rate, and because the body handles them in predictable ways. A stable nucleus is like a quiet balance between forces holding it together and forces pushing it apart. Protons repel each other because they're all positively charged, but they're also held together by the strong nuclear force, which acts over very short distances. Neutrons act like nuclear glue in many atoms, helping the nucleus stay stable. They add mass and contribute to the strong force without adding more positive charge, which helps offset the repulsion between protons. Most atoms you encounter daily are stable and do not decay. The oxygen you breathe, the carbon in your body, the iron in a nail, all of these are stable isotopes. Even when atoms do decay, it's a natural process that happens throughout the universe. Radioactivity isn't something alien or unnatural. It's been part of the cosmos since the earliest moments of creation. Radioactive clocks help scientists estimate the ages of rocks, Earth, and even meteorites. By measuring the ratio of parent isotopes to daughter products, scientists can calculate how long the decay has been happening, and that tells them how old the rock is. Just one more small fact, and then we drift into a different kind of understanding. The periodic table organizes elements by increasing proton number. Start with hydrogen, which has one proton, and move across and down the table, adding one proton at a time. Helium has 2, lithium has 3, beryllium has 4, and so on. Elements in the same column often behave similarly because they have similar outer electrons. The elements in the far right column, helium, neon, argon, krypton, xenon, radon, are all noble gases. They all have full outer electron shells, which makes them stable and mostly unreactive. The outermost electrons largely determine how an atom bonds. These are valence electrons. When chemists talk about how an atom will behave, they're usually talking about its valence electrons. The inner electrons are tightly held and don't participate much in chemical reactions. Noble gases, like helium and neon, are often unreactive because their outer electron shells are comfortable. They don't need to gain or lose electrons to achieve stability. They're already stable. Sodium is reactive because it tends to give up one outer electron easily. Sodium has one electron in its outermost shell, and it's energetically favourable for sodium to lose that electron and reveal a stable, full shell underneath. Chlorine tends to gain one electron, so sodium and chlorine fit together strongly as salt. Chlorine is one electron short of a full outer shell, and sodium has one electron it's eager to give up. When they meet, sodium donates its electron to chlorine, and both atoms achieve stable, full outer shells. The resulting charged ions attract each other and form sodium chloride, table salt. Helium is very light, which is one reason it can rise in balloons. Helium has only 2 protons and 2 neutrons, making it the second lightest element. It's lighter than the nitrogen and oxygen in air, so helium-filled balloons float upward. Hydrogen is the most abundant element in the universe. It's the simplest element, and it was the first to form after the Big Bang. The vast majority of atoms in the universe are hydrogen atoms. Stars are mostly hydrogen. The space between stars contains thin hydrogen, gas. Oxygen is abundant on Earth, especially because it bonds readily with many elements. Oxygen makes up a significant portion of Earth's crust. Combined with silicon in rocks, combined with hydrogen in water, combined with metals in ores. Iron is common because stellar processes make it a kind of energy endpoint in many stars. When a massive star fuses lighter elements into heavier ones, the process releases energy until it reaches iron. Fusing iron requires energy rather than releasing it, so iron tends to accumulate in the cores of massive stars. Gold appears gold-coloured because of how its electrons respond to light, including subtle relativistic effects. Gold's electrons move so fast and orbit so close to the nucleus that relativistic effects predicted by Einstein's theory of relativity, shift how the electrons absorb and reflect light. This shifts gold's colour toward the yellow end of the spectrum. Without these relativistic effects, gold would likely appear silvery, like most other metals. Copper's orange tone also comes from how its electrons absorb and reflect certain light. Copper absorbs blue and violet wavelengths and reflects red, orange and yellow, giving it that warm reddish hue. Many gemstones are the same base mineral with tiny atomic differences. Trace elements change colour. Corundum is aluminum oxide, and in its pure form it's colourless. Add a small amount of chromium and you get ruby with its deep red colour. Add titanium and iron and you get sapphire with its blue colour. The base structure is the same, but the trace elements alter how the crystal absorbs light. Small changes in atomic structure can produce huge differences in material properties. Move one element over on the periodic table, or rearrange how atoms bond, and you can go from a soft metal to a hard ceramic, from a conductor to an insulator, from transparent to opaque. Chemistry is the quiet art of electrons finding stable arrangements. All the complexity of the chemical world, all the reactions, all the colours, all the smells and tastes and textures, comes down to atoms seeking stability through the sharing or trading of electrons. It's a gentle dance, guided by the rules of quantum mechanics and electromagnetism playing out in every substance around you. Just one more small fact, and then we drift into deep time, into the stars. The earliest universe made mostly hydrogen and helium. In the first few minutes after the Big Bang, the universe was hot and dense enough for nuclear fusion to occur freely. Protons fused into helium nuclei, and small amounts of lithium formed as well. But the universe expanded and cooled quickly, and fusion stopped. For hundreds of millions of years, the universe was mostly hydrogen and helium gas, drifting in darkness. Stars are powered by nuclear fusion, light nuclei combining into heavier ones. Eventually, gravity pulled the hydrogen gas into clumps, and those clumps grew denser and hotter until fusion ignited in their cores. Hydrogen nuclei fused into helium, releasing energy in the process. That energy created pressure, which balanced the inward pull of gravity, and a star was born. Fusion in stars builds elements like carbon, oxygen, and neon over a star's life. When a star has fused much of its hydrogen into helium, it can begin fusing helium into carbon. Later, it might fuse carbon into oxygen, neon, and magnesium. The exact sequence depends on the star's mass. Massive stars can fuse elements in layers, like a slow onion of reactions. In the core, the heaviest fusion reactions are happening. In a shell around the core, lighter elements are fusing. In another shell, farther out, even lighter fusion occurs. The result is a star with a layered structure, each layer producing different elements. The heaviest elements, like gold, are associated with extreme cosmic events, such as certain supernova processes and neutron star mergers. When a massive star exhausts its fuel, it can collapse and explode in a supernova, releasing tremendous energy and creating conditions where very heavy elements can form. When two neutron stars spiral into each other and collide, the intense pressures and neutron-rich environment forge gold, platinum, uranium, and other heavy elements. When stars die, they can release elements into space. This is cosmic recycling. A supernova blasts the star's outer layers into space, seeding the surrounding region with newly forged elements. A less massive star might shed its outer layers more gently, creating a planetary nebula, and that material too enriches the interstellar medium. Nebulae are vast clouds of gas and dust where new stars and planets can form. These clouds contain the hydrogen and helium from the early universe, mixed with heavier elements created in earlier generations of stars. When a region of a nebula becomes dense enough, it can collapse under its own gravity and form a new star, and the process begins again. Planetary systems form from leftover material around young stars, shaped by gravity and time. As a star forms, it's surrounded by a disk of gas and dust. Over millions of years, that material clumps together. Dust grains stick, pebbles merge, rocks collide, and eventually planets form. The atoms in your body were once part of ancient stars, star stuff in the most literal sense. The carbon in your cells, the calcium in your bones, the iron in your blood, All of these elements were forged in stars that died before the sun was born. Earth's elements were assembled from earlier stellar material before the solar system formed. About 4.6 billion years ago, a cloud of gas and dust collapsed to form the sun and its planets. That cloud contained atoms from previous generations of stars, atoms that had been cycling through the galaxy for billions of years. Meteorites can carry very old minerals, atoms preserved from the solar system's early days. Some meteorites contain grains that predate the solar system itself, fragments of ancient stars embedded in the rock. Even in deep space, atoms can exist as thin gas, drifting for ages between stars. The space between stars isn't a perfect vacuum. It contains a few atoms per cubic centimetre, mostly hydrogen. These atoms drift slowly, pulled by gravity, pushed by starlight, waiting for the next time they'll be swept up into a star or planet. Some atoms travel inside cosmic dust grains, like tiny time capsules. Interstellar dust grains are microscopic particles, often silicates or carbon compounds, and they carry atoms from one part of the galaxy to another. Every breath you take mixes atoms that have been part of oceans, forests, and countless living things before. The nitrogen molecules you inhale may have once been in the soil, absorbed by plants, eaten by animals, returned to the soil, cycled through the atmosphere. The oxygen you breathe was likely produced by plants through photosynthesis, but before that, it may have been part of water, part of rock, part of the ancient atmosphere. In that sense, atoms are patient travellers, always changing partners, never truly leaving the universe. They move from star to nebula to planet to organism to atmosphere and back again, endlessly repurposed, endlessly recycled. Just one more small fact and then we drift back to the room, back to the present, back to the quiet. Right now, atoms in your body are constantly being rearranged through metabolism and repair. Your cells break down food molecules, releasing energy and building blocks. They use those building blocks to repair damage, to build new proteins, to replace worn-out structures. The atoms that make up you aren't fixed. They're in constant flux. Your skin slowly sheds atoms, and the environment gives you new ones through food, water, and air. Over time, the atoms in your body are gradually replaced. The you of today contains different atoms than the you of a year ago, yet you remain you. The water you drink contains hydrogen atoms that may be as old as the early universe. Those hydrogen atoms formed in the first few minutes after the Big Bang, and they've been cycling through the cosmos ever since. They've been in stars, in comets, in oceans, in clouds, in plants, in animals, and now they're in you. The air in your room is a moving sea of molecules bouncing gently in all directions. Nitrogen, oxygen, carbon dioxide, water vapour, all of them in constant random motion, colliding with each other and with the walls, the floor, your skin, creating the pressure we call air. The pillow beneath you is a structured weave of atoms holding its shape through countless bonds. The fabric is made of long polymer molecules woven together. The filling is a mass of fibres or foam, each fibre a tangle of atoms bonded in long chains. Even still objects are not perfectly still. Atoms vibrate and share energy quietly. The pillow isn't frozen in place at the atomic level, its atoms are jiggling, shifting slightly, vibrating with thermal energy. The warmer the room, the more vigorous the motion. Temperature is in part a measure of how energetically atoms and molecules are moving. When you feel warmth, you're sensing the kinetic energy of atoms. When something feels cold, its atoms are moving more slowly, and they draw energy from your skin, slowing your atoms down. Heat flows from warmer to cooler, from faster moving atoms to slower moving ones, always seeking equilibrium. Your breath is a steady rhythm of atoms trading places, oxygen in, carbon dioxide out. With each breath, oxygen molecules enter your lungs, cross into your bloodstream, and travel to your cells, where they're used to break down glucose and release energy. The waste product, carbon dioxide, travels back to your lungs and is exhaled. It's a quiet, constant exchange, happening without your conscious effort. Over billions of years, atoms have arranged and rearranged into stars, oceans, mountains, and mines. The atoms around you have been part of the early universe, part of dying stars, part of the forming solar system, part of Earth's mantle, part of ancient oceans, part of early life, part of forests and animals and people. And now they're part of this moment, this room, this quiet night. And tonight, you don't have to manage any of it. Atoms will keep their calm work going while you simply rest. Just one more small fact, and then we drift, and you let the universe's smallest building blocks carry your thoughts away. The atoms in your body know what to do. They bond, they vibrate, they exchange energy. They follow the laws of physics and chemistry without hesitation, without error. They've been doing this work for billions of years, and they'll continue long after this night has passed. You can trust them. You can let your mind relax knowing that at the smallest scale, everything is proceeding as it should. The electrons are in their orbitals, the nuclei are stable, the bonds are holding, the molecules are doing their work, there's nothing you need to control, nothing you need to fix. The atoms are taking care of it all quietly, reliably, endlessly. And as you drift, you can imagine those tiny building blocks, those patient travellers, those ancient pieces of stardust, all working together to create this moment, this breath, this stillness. Just one more small fact, and then we drift, and you let the universe's smallest building blocks carry your thoughts away into the gentle dark, into the quiet, into rest. The atoms in your body know what to do. They bond, they vibrate, they exchange energy, they follow the laws of physics and chemistry without hesitation, without error. They've been doing this work for billions of years, and they'll continue long after this night has passed. You can trust them. You can let your mind relax, knowing that at the smallest scale, everything is proceeding as it should. The electrons are in their orbitals, the nuclei are stable, the bonds are holding, the molecules are doing their work, there's nothing you need to control, nothing you need to fix. The atoms are taking care of it all quietly, reliably, endlessly. And as you drift, you can imagine those tiny building blocks, those patient travellers, those ancient pieces of stardust all working together to create this moment, this breath, this stillness. Just one more small fact, and then we drift, and you let the universe's smallest building blocks carry your thoughts away into the gentle dark, into the quiet, into rest. But before we settle completely, let's linger a little longer in this atomic world, because there's something deeply calming about understanding how reliably matter behaves, how predictable the rules are, how atoms have been following the same pattern since the beginning of time. Every atom in existence follows the same fundamental laws. A hydrogen atom in your body behaves exactly like a hydrogen atom in a distant galaxy. A carbon atom in your fingernail follows the same rules as a carbon atom in a meteorite. The universe has no exceptions, no special cases at this level. Everything is consistent, everything is orderly, and that orderliness extends across all of space and all of time. When atoms bond together, they do so according to very specific preferences. These preferences arise from the arrangement of electrons, from the shapes of orbitals, from the balance of attractive and repulsive forces. An oxygen atom bonds most comfortably with two hydrogen atoms because that arrangement allows all three atoms to achieve stable electron configurations. The angle between the two hydrogen atoms in a water molecule is about 104.5 degrees, and that angle is determined by the shape of oxygen's electron orbitals and the repulsion between the electron pairs. It's not random, it's not approximate. It's a consequence of quantum mechanics playing out in three-dimensional space, and every water molecule in every ocean, every raindrop, every ice crystal follows the same geometry. When water freezes, the molecules arrange themselves in a hexagonal pattern. Each oxygen atom is surrounded by four other water molecules in a roughly tetrahedral arrangement, and this creates a structure with more open space than liquid water. That's why ice is less dense than water, why it floats, why lakes freeze from the top down rather than the bottom up. This small fact, this consequence of hydrogen bonding and molecular geometry, has profound implications for life on Earth. If ice were denser than water, it would sink, and lakes and oceans would freeze solid from the bottom up during winter, likely killing most aquatic life. But ice floats, forming an insulating layer on the surface, and life continues beneath. The hydrogen bonds that hold water molecules together are weaker than the covalent bonds within each molecule, but they're strong enough to give water remarkable properties. Water has a high surface tension, allowing insects to walk on its surface. Water has a high specific heat, meaning it takes a lot of energy to change its temperature, which helps regulate Earth's climate. Water is an excellent solvent, dissolving salts and sugars and many other substances, which is essential for the chemistry of life. All of these properties emerge from the way water molecules interact with each other, from the distribution of charge across each molecule, from the hydrogen bonds forming and breaking and reforming in constant motion. In liquid water, each molecule is surrounded by others, all jostling and sliding past each other. The molecules are attracted to each other through hydrogen bonding, but they have enough thermal energy to move freely. They don't stay locked in one position. They drift, rotate, vibrate. At any given moment, a water molecule might be bonded to 3 or 4 neighbours, but those bonds break and form again with different neighbours billions of times per second. It's a dynamic equilibrium, a constant dance of attraction and release. When you heat water, you're adding energy to this system. The molecules move faster, vibrate more vigorously, and more hydrogen bonds break. Eventually, at 100 degrees Celsius under standard pressure, the molecules have enough energy to escape into the air as vapour. Boiling is simply the point where the thermal motion overcomes the hydrogen bonding, allowing molecules to break free from the liquid and enter the gas phase. When you cool water, you're removing energy. The molecules slow down, and more hydrogen bonds persist for longer periods. At 0 degrees Celsius, the molecules lock into the hexagonal ice structure, and the liquid becomes solid. Every phase transition, solid to liquid, liquid to gas, and vice versa, is a manifestation of atoms and molecules finding a new equilibrium between their attractive forces and their thermal motion. These transitions happen at specific temperatures and pressures because the underlying physics is precise and repeatable. Water always freezes at 0 Celsius at sea level. It always boils at 100 Celsius. These aren't approximations. They're consequences of the fundamental properties of water molecules and the conditions they're experiencing. The same principles apply to every substance. Metals melt when their atoms gain enough thermal energy to break free from their rigid crystal lattice. Ice sublimates, turns directly from solid to gas when the conditions are right, which is why snow can disappear on a cold, dry day even when the temperature stays below freezing. Carbon dioxide doesn't have a liquid phase at normal atmospheric pressure. It goes directly from solid dry ice to carbon dioxide gas, which is why dry ice smokes when you leave it out. Each substance has its own set of phase transitions, determined by the strength of the bonds between its atoms or molecules and the energy available to break those bonds. Inside your body right now, phase transitions are happening continuously, though you don't notice them. Water evaporates from your skin, carrying away heat and cooling you down. Water condenses in your lungs when you exhale warm, moist air into cooler surroundings. You can see your breath on a cold day because the water vapour is condensing into tiny droplets. Lipids in your cell membranes exist in a carefully controlled semi-fluid state, neither completely solid nor completely liquid, allowing them to form barriers while still permitting movement and flexibility. Your body maintains all of these states through careful regulation of temperature and chemical environment. At the molecular level, your cells are busy managing thousands of chemical reactions simultaneously. Enzymes, protein molecules with precisely shaped active sites, bring reactants together and lower the energy needed for reactions to occur. A substrate molecule fits into an enzyme's active site like a key into a lock, though the fit is dynamic rather than rigid. The enzyme holds the substrate in place, puts stress on certain bonds, and facilitates the breaking or forming of those bonds. When the reaction is complete, the product is released and the enzyme is ready to work again. A single enzyme molecule can catalyze thousands of reactions per second, and your cells contain thousands of different enzymes, each specialized for a particular reaction. The DNA in your cells is a long, twisted ladder of atoms, a double helix held together by hydrogen bonds between complementary base pairs. Adenine always pairs with thymine, and guanine always pairs with cytosine, because those are the combinations where the shapes fit and the hydrogen bonds align correctly. This pairing is so reliable that it allows DNA to be copied with extraordinary accuracy. When a cell divides, enzymes unzip the double helix, and other enzymes build new complementary strands, creating 2 identical DNA molecules from one. Mistakes happen, mutations occur, but they're rare, thanks to the precision of molecular interactions and the proofreading mechanisms cells have evolved. The information in DNA is written in sequences of bases, and those sequences are translated into proteins through an intricate process involving RNA and ribosomes. 3 bases in a row code for one amino acid, and a string of amino acids folds into a protein. The protein's shape is determined by the sequence of amino acids and by how those amino acids interact with each other and with the surrounding water. Hydrogen bonds, ionic interactions, hydrophobic effects, all of these forces guide the protein into its final three-dimensional structure, and that structure determines what the protein does. A protein that's folded correctly can function as an enzyme, a structural component, a signal receptor, a molecular motor. A protein that's folded incorrectly might do nothing, or it might cause problems, which is why cells have quality control systems to refold or destroy misfolded proteins. Every biological process, from muscle contraction to nerve signaling to photosynthesis, comes down to atoms and molecules interacting in specific ways. When you move your hand, you're using proteins called actin and myosin, which slide past each other in a ratcheting motion powered by ATP, adenosine triphosphate, a molecule that stores energy in its chemical bonds. When a nerve signal travels down a neuron, it's because ions, sodium and potassium, are flowing across the cell membrane through protein channels, creating an electrical pulse. When a plant captures sunlight, chlorophyll molecules absorb photons, exciting electrons that then move through a chain of proteins, ultimately driving the synthesis of sugar from carbon dioxide and water. All of this complexity, all of this function, emerges from atoms obeying simple rules. Electrons seek stable configurations. Positive and negative charges attract. Like charges repel, energy flows from high concentration to low, entropy tends to increase. These principles, applied consistently across trillions of atoms, generate the rich tapestry of chemistry and biology that makes life possible. And it's all happening right now, in your body, as you rest. Your heart is beating because calcium ions are flooding into muscle cells, triggering contraction. Your lungs are exchanging gases because oxygen and carbon dioxide diffuse across thin membranes, following concentration gradients. Your neurons are maintaining their resting potential, ready to fire if needed, by actively pumping sodium out and potassium in. Your digestive system is breaking down food molecules, cleaving bonds and rearranging atoms to extract energy and building blocks. Your cells are synthesizing new proteins, repairing DNA, processing waste, communicating with each other through chemical signals. None of this requires your conscious attention. The atoms know what to do, the molecules know where to go. The reactions proceed at the rates, determined by temperature, concentration, and the presence of catalysts. It's all automatic, all reliable, all governed by the same laws that have governed matter since the universe began. Outside your body and the room around you, atoms are behaving just as predictably. The air molecules are bouncing off each other and off every surface in a chaotic but statistically orderly way. The average speed of a nitrogen molecule at room temperature is about 500 meters per second, though any individual molecule is constantly speeding up and slowing down as it collides with others. The pressure you feel from the air is the cumulative result of countless molecular collisions, molecules striking your skin, the walls, the furniture, transferring tiny amounts of momentum with each impact. The air is mostly nitrogen, about 78% by volume, because nitrogen is relatively unreactive and stable as a diatomic molecule. Two nitrogen atoms triple bonded to each other. That triple bond is very strong, which is why nitrogen doesn't readily participate in reactions at normal temperatures and pressures. It takes significant energy to break that bond, which is why industrial nitrogen fixation, the process of converting nitrogen gas into ammonia for fertilizer, requires high temperatures and pressures and a catalyst. Yet certain bacteria can fix nitrogen at room temperature using specialized enzymes, a reminder that biological systems can achieve remarkable feats of chemistry through precise molecular machinery. Oxygen makes up about 21% of the air. Like nitrogen, oxygen exists mostly as diatomic molecules, though oxygen's double bond is weaker than nitrogen's triple bond, making oxygen more reactive. Oxygen is essential for aerobic life because it's an excellent electron acceptor. When your cells break down glucose, they strip electrons from the glucose molecule and pass them through a series of proteins, ultimately transferring them to oxygen, which combines with hydrogen ions to form water. This process releases energy that your cells capture and use to make ATP. Without oxygen, most complex multicellular life as we know it couldn't exist, because the energy yield from anaerobic metabolism is much lower. The remaining 1% of the air is a mix of argon, carbon dioxide, neon, helium, methane, and trace amounts of other gases. Argon is a noble gas, chemically inert, and it accumulates in the atmosphere because it's produced by the radioactive decay of potassium-40 in Earth's crust. Carbon dioxide, though only about 0.04% of the atmosphere, plays a crucial role in Earth's climate and in the global carbon cycle. Plants absorb carbon dioxide during photosynthesis, animals and decomposers release it during respiration, oceans dissolve it, volcanoes emit it, and the concentration has been rising due to human activities, particularly the burning of fossil fuels. Carbon dioxide is a simple molecule, one carbon atom double bonded to two oxygen atoms, arranged in a straight line. But it has significant effects on how Earth absorbs and emits radiation. Carbon dioxide is transparent to visible light, so sunlight passes through the atmosphere and warms the surface. But carbon dioxide absorbs infrared radiation, heat, that Earth emits back towards space. The molecules' bonds can vibrate in ways that resonate with infrared wavelengths, absorbing that energy and re-emitting it in random directions, including back toward the surface. This is the greenhouse effect, and it's a natural and necessary process that keeps Earth warm enough for liquid water and life. Without any greenhouse gases, Earth's average temperature would be well below freezing. The concern with rising carbon dioxide levels isn't the greenhouse effect itself, it's the rapid increase in that effect, which is shifting Earth's climate faster than many ecosystems can adapt. Water vapour is also a greenhouse gas, and it plays an even larger role in Earth's heat balance than carbon dioxide, though its concentration varies greatly depending on location and weather. Warm air can hold more water vapour than cold air, which is why tropical regions are humid and polar regions are dry. When water vapour condenses into clouds, it releases latent heat, the energy that was used to evaporate the water in the first place, and that heat affects weather patterns and atmospheric circulation. Clouds themselves have complex effects on climate. They reflect sunlight, cooling the surface, but they also trap heat, warming it. The net effect depends on the type, altitude, and coverage of the clouds. The atmosphere is a dynamic system, constantly mixing and moving, driven by differences in temperature and pressure. Warm air rises because it's less dense than cooler air, creating convection currents. The Earth's rotation deflects these currents, creating wind patterns and weather systems. The molecules in the air are all moving individually, yet collectively they create the wind you feel, the weather you experience, the climate that shapes the planet. On a calm night, the air in your room is relatively still on a macroscopic scale, but at the molecular level, it's as active as ever. The molecules are zipping around, colliding, transferring energy, maintaining equilibrium. The temperature in the room is the same everywhere, or nearly so, because the air molecules have distributed thermal energy evenly. If you open a window on a cold night, cool air flows in, not because cold is a substance that spreads, but because the faster moving molecules in the warm room lose energy to the slower moving molecules from outside, and the average energy, the temperature, equalizes. The walls of the room are solid and their atoms are vibrating in place, held by chemical bonds. The materials, drywall, wood, concrete, whatever they are, each have their own atomic structure. Drywall is mostly calcium sulfate, a compound where calcium ions and sulfate ions are held together by ionic bonds. Wood is a complex mixture of cellulose, hemicellulose, and lignin, all organic polymers made from carbon, hydrogen, and oxygen. Concrete is a mixture of cement, water, sand, and gravel, and the cement itself is a calcium silicate compound that undergoes a chemical reaction with water, hardening into a solid matrix. Every material has a thermal conductivity, a measure of how easily heat flows through it. Metals have high thermal conductivity because their free electrons can carry energy quickly from one part of the material to another. Wood and plastic have lower thermal conductivity because they lack free electrons, and heat must travel through vibrations of the atomic lattice, which is slower. Air has very low thermal conductivity, which is why insulation works. Materials like fiberglass or foam trap pockets of air, preventing heat from flowing freely. The floor beneath you, whether carpet or wood or tile, is a surface made of countless atoms bonded together. Carpet is made of synthetic or natural fibers, each fiber a polymer, a long-chain molecule. The fibers are woven or tufted into a backing, creating a soft surface. Wool, a natural fiber, is made of keratin, the same protein found in hair and fingernails. Synthetic fibers like nylon and polyester are petroleum-based polymers created through chemical reactions that link small molecules into long chains. Tile might be ceramic, made from clay that's been shaped and fired at high temperatures, causing the atoms to lock into a hard, durable structure. The objects around you, furniture, books, electronics, are all assemblages of atoms arranged in specific ways. A book is paper, ink, and glue. Paper is cellulose fibres pressed together, derived from wood pulp. Ink is a suspension of pigment particles in a liquid or binder. The pigments are molecules that absorb certain wavelengths of light and reflect others, giving the ink its colour. Black ink absorbs nearly all wavelengths, reflecting very little, which is why it appears black. Coloured inks contain pigments with more selective absorption. Blue ink absorbs red and green wavelengths and reflects blue. A smartphone or laptop is a marvel of atomic engineering. The screen is glass made from silicon dioxide and other oxides, heated until molten and then cooled into a transparent amorphous solid. The display itself might be an LCD or OLED, both of which manipulate light at the molecular level. In an LCD, liquid crystals, molecules that flow like a liquid but have an ordered structure like a crystal, are sandwiched between polarizing filters. When an electric field is applied, the liquid crystals rotate, changing how much light passes through. In an OLED, organic molecules emit light when electrons and holes recombine within them, a process similar to what happens in LEDs, but using carbon-based compounds instead of inorganic semiconductors. The processor inside the device is made from silicon, doped with tiny amounts of other elements to control how electrons flow. Silicon is a semiconductor. It's not a good conductor like copper, but it's not an insulator like glass either. By carefully controlling the arrangement of atoms and introducing impurities, engineers can create transistors, diodes, and other components that control electric current. A modern processor contains billions of transistors, each one a tiny switch made from precisely arranged atoms, all working together to perform calculations. The battery is a chemical system where atoms exchange electrons through oxidation and reduction reactions. In a lithium-ion battery, lithium ions move from one electrode to the other through an electrolyte, and electrons flow through an external circuit providing power. When you charge the battery, you reverse the process, using electrical energy to drive the ions back to their original positions. The battery works because lithium atoms have a strong tendency to lose an electron, and the other electrode material has a strong tendency to gain electrons, creating a voltage difference. All of this technology, all of this function, comes from understanding how atoms behave and arranging them in useful ways. It's applied chemistry, applied physics, applied materials science, and it all rests on the same fundamental principles. Electrons seek stability, atoms bond in specific geometries, energy flows from high to low, and reactions proceed toward equilibrium. The light from a lamp or screen comes from atoms emitting photons. In an incandescent bulb, a tungsten filament is heated until it glows. The atoms vibrate so vigorously that they emit light across a broad spectrum. In an LED, electrons recombine in a semiconductor, and the energy is released as photons of a specific wavelength determined by the materials used. In a fluorescent tube, electricity excites mercury atoms, which emit ultraviolet light, and that ultraviolet light strikes a phosphor coating, causing it to fluoresce, emit visible light. Each method is a different way of persuading atoms to release energy as light, and each relies on understanding atomic and molecular behaviour. When light hits your eye, it's absorbed by molecules in your retina called opsins. These molecules contain a chromophore, a light-sensitive part, that changes shape when it absorbs a photon. That shape change triggers a cascade of chemical reactions, ultimately producing an electrical signal that travels to your brain. Vision is chemistry and physics working together. Photons, molecules, ions, and electrical impulses, all coordinated to give you the experience of sight. Sound, too, is atoms in motion. When something vibrates, a guitar string, a speaker cone, your vocal cords, it pushes and pulls on the air molecules around it, creating regions of higher and lower pressure that travel outward as a wave. Your eardrum vibrates in response to these pressure changes, and tiny bones in your middle ear amplify the vibration and transmit it to the fluid-filled cochlea. There, hair cells detect the motion and convert it into electrical signals. Hearing is the perception of molecules in motion, translated into neural activity. Smell, as mentioned earlier, is molecules binding to receptors. Taste is molecules binding to different receptors on your tongue. Touch is mostly the deformation of cells in your skin, which opens ion channels and generates electrical signals. Every sense you have is, at its root, a molecular event, atoms and molecules interacting in specific ways, triggering responses that your brain interprets as sensations. Your brain itself is an incredibly complex network of neurons, each one a cell filled with molecules carrying out reactions. Thoughts, memories, emotions, all of these emerge from patterns of electrical and chemical activity in the brain. When you remember something, it's because certain synapses, connections between neurons, have been strengthened through repeated use, making it easier for signals to travel along those pathways. When you learn something new, your brain is literally rewiring itself, forming new synaptic connections and reinforcing others. The molecules involved include neurotransmitters like dopamine, serotonin and glutamate, which carry signals across synapses and receptors that bind those neurotransmitters and trigger responses in the receiving neuron. The fact that consciousness emerges from atoms following physical laws is one of the great mysteries, but it's not in doubt that it does. The atoms in your brain are the same atoms found everywhere else: carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, and traces of others. There's nothing special about them individually. What's special is how they're arranged, how they interact, the patterns they form. Complexity builds on complexity, from atoms to molecules to cells to tissues to organs to systems, until you have a brain that can think about atoms. And tonight, as you rest, your brain is still active, even if you're not consciously thinking. It's consolidating memories, processing the day's experiences, maintaining basic functions like breathing and heart rate. It's doing all of this through chemistry, through ions flowing, neurotransmitters binding, proteins changing shape, genes being expressed or suppressed. It's all atoms, all the way down, following the rules, doing the work. The carbon in your body, the carbon that forms the backbone of every organic molecule in your cells, came from ancient stars. Carbon is created in stars through a process called the triple alpha process. 3 helium nuclei, each containing 2 protons and 2 neutrons, collide and fuse to form a carbon nucleus with 6 protons and 6 neutrons. This process requires very specific conditions, a certain temperature, a certain density, and it was only discovered after astronomers realized there was a puzzle. Carbon is abundant in the universe, but the conditions for making it seemed too narrow. The solution came when physicist Fred Hoyle predicted that carbon must have an energy level that makes the reaction much more likely, and experiments confirmed he was right. Without that particular energy level, carbon would be rare, and life as we know it probably wouldn't exist. Oxygen, the second most important element for life on Earth, is created when carbon fuses with another helium nucleus. Neon comes from oxygen fusing with helium. The process continues, building heavier and heavier elements as long as the star is massive enough and hot enough. Each fusion reaction releases energy, and that energy creates the pressure that keeps the star from collapsing under its own gravity. But fusion only releases energy up to iron. When you fuse lighter elements into iron, you get energy out. When you try to fuse iron into heavier elements, you have to put energy in. That's because iron has the most stable nucleus. It has the lowest energy per nucleon of any element. This means that a massive star, once it builds up an iron core, is in trouble. The core can no longer produce energy through fusion, so it can no longer support itself against gravity. The core collapses in a fraction of a second, and the outer layers crash down onto it. The result is a supernova, a catastrophic explosion that outshines entire galaxies for a brief time. In the intense heat and pressure of a supernova, elements heavier than iron can be created. Neutrons flood the collapsing core and they can be captured by nuclei, building up heavier and heavier elements. This is called the R process, the rapid neutron capture process, and it's responsible for about half of the elements heavier than iron. The other half are created through the S process, the slow neutron capture process, which happens in certain types of stars over long periods of time. Recently, astronomers detected gravitational waves from the collision of 2 neutron stars, and they also observed the electromagnetic radiation from the event. Analysis of that radiation revealed the signatures of heavy elements being created: gold, platinum, uranium. It was the first direct observation of heavy element formation in a neutron star merger, confirming what had been theorized for decades. Those collisions are rare, but over the billions of years of cosmic history, they've seeded the universe with enough heavy elements to make planets and people. The gold in a ring, the uranium in a nuclear reactor, the lead in a car battery, all of these atoms were created in the death throes of stars or in the violent collisions of stellar remnants. They've travelled through space, mixed with gas clouds, been incorporated into new stars and planets, and eventually ended up here, on Earth, in your environment, sometimes even in your body. Earth itself is a ball of atoms sorted by density. The densest materials, mostly iron and nickel, sank to the centre early in Earth's history when the planet was molten from the heat of formation and radioactive decay. The lighter materials, silicates, mostly compounds of silicon and oxygen, floated to the top, forming the mantle and crust. This differentiation happened over millions of years, driven by gravity and heat, and it gave Earth its layered structure: a solid inner core, a liquid outer core, a solid mantle, and a thin crust. The inner core is under such immense pressure that iron, which would normally melt at the core's temperature, is forced to remain solid. The outer core is liquid, and its motion generates Earth's magnetic field through a process called the geodynamo. Charged particles, ions of iron and other elements, flow through the liquid core, and because Earth is rotating, these flows create electric currents, and electric currents generate magnetic fields. The details are complex, but the result is a magnetic field that extends far into space, protecting Earth from the solar wind, the stream of charged particles, flowing from the sun. The mantle is solid but not rigid. Over long timescales, it flows like a very thick fluid, driven by heat from the core and from radioactive decay within the mantle itself. This flow causes tectonic plates to move, which leads to earthquakes, volcanic eruptions, and the slow drift of continents. The atoms in the mantle are mostly silicon, oxygen, magnesium, and iron, arranged in crystal structures that can deform and flow under the right conditions of temperature and pressure. The crust is the thin outermost layer, the solid skin of the planet, and it's where we live. Continental crust is mostly granite and similar rocks, rich in silicon and aluminum. Oceanic crust is mostly basalt, denser and richer in iron and magnesium. The rocks of the crust are made of minerals, and minerals are crystalline solids with specific chemical compositions. Quartz is silicon dioxide. Feldspar is a group of aluminum silicates. Mica is a layered silicate. Each mineral has each characteristic crystal structure determined by the arrangement of its atoms. When molten rock cools, atoms arrange themselves into crystals, and the size of those crystals depends on how quickly the rock cools. Slow cooling allows large crystals to form. Granite, which cools deep underground, has visible crystals of quartz, feldspar, and mica. Rapid cooling produces small crystals or even glass. Obsidian, which forms when lava cools very quickly, is volcanic glass, an amorphous solid with no crystal structure at all. Erosion breaks rocks down into smaller particles: sand, silt, clay. These particles are carried by water and wind and deposited in layers. Over time, the layers compact and cement together, forming sedimentary rocks like sandstone, shale, and limestone. Limestone is mostly calcium carbonate, often formed from the shells and skeletons of marine organisms. When those organisms die, their calcium carbonate structures accumulate on the seafloor, and over millions of years they lithify into rock. If sedimentary or igneous rocks are subjected to high temperature and pressure through burial or tectonic forces, they can transform into metamorphic rocks. The atoms rearrange into new mineral structures without melting. Shale becomes slate, then schist, then gneiss, as the temperature and pressure increase. Limestone becomes marble, sandstone becomes quartzite. The rock cycle, igneous to sedimentary to metamorphic and back to igneous, is a slow churning of atoms, driven by Earth's internal heat and the movement of tectonic plates. The soil beneath your feet is a mixture of mineral particles, organic matter, water, air, and countless living organisms. The mineral particles come from weathered rock. The organic matter comes from decaying plants and animals. Bacteria, fungi, insects, and other organisms break down organic matter, recycling nutrients and making them available to plants. Plant roots absorb water and dissolved nutrients, nitrogen, phosphorus, potassium, and many others, and use them to build tissues. When the plant dies, the atoms return to the soil, ready to be used again. This cycling of atoms through ecosystems is continuous. Carbon cycles through photosynthesis and respiration. Nitrogen cycles through fixation, assimilation, and denitrification. Water cycles through evaporation, precipitation, and runoff. Every atom in your body has been cycled through ecosystems countless times. The nitrogen in your proteins may have been in the air, then in the soil, then in a plant, then in an animal, then back to the soil, many times over. The water in your cells has been in oceans, clouds, rivers, plants, animals, and back again, endlessly. Life is not separate from the environment. It's part of the same cycling of matter, the same flow of energy. The atoms that make up your body are borrowed from the environment, and they'll return to it. You're a temporary arrangement, a pattern that matter has taken for a while. The atoms themselves are ancient and will persist long after the pattern that is you has dissolved. But that's not a sad thought. It's a connecting thought. You're part of a continuity that stretches back to the beginning of the universe and forward into the indefinite future. The atoms in your body have been part of stars, part of interstellar clouds, part of the early Earth, part of ancient oceans, part of the first life, part of dinosaurs and forests and countless other organisms. And after you, they'll be part of other things: soil, air, water, new organisms, perhaps even new stars if Earth's atoms are ever scattered back into space. For now, though, those atoms are you. They're arranged in a specific, intricate pattern that thinks and feels and experiences the world. They're maintaining that pattern through constant work, metabolism, repair, signalling, movement. And they'll keep doing that work as long as you're alive, following the same rules they've always followed. The same rules that govern all matter everywhere. As you lie here tonight, you can trust those atoms to continue their work. You don't need to direct them. You don't need to worry about them. They've been doing this for billions of years, and they're very good at it. The electrons will keep orbiting. The bonds will keep holding. The reactions will keep proceeding. The energy will keep flowing. And you can simply rest, carried by the reliable, quiet work of the universe's smallest building blocks. The darkness around you is not truly dark. If you could see infrared light, you'd see the glow of thermal radiation from every object in the room: the walls, the furniture, your own body. Everything above absolute zero emits electromagnetic radiation, and the wavelength of that radiation depends on the temperature. At room temperature, objects emit mostly in the infrared. Hotter objects, like the filament in an incandescent bulb, emit visible light. Even hotter objects, like the sun, emit across a wide spectrum, including ultraviolet. The atoms in any object are always vibrating, always moving, and charged particles in motion emit electromagnetic radiation. The silence around you is not truly silent. There are always sounds: the hum of electronics, the settling of the building, the distant sound of traffic or wind, the rhythm of your own breathing and heartbeat. Sound is vibration, and vibration is atoms in motion, pushing on neighbouring atoms, creating waves of compression and rarefaction that travel through matter. Sound can't travel through a vacuum because there are no atoms to vibrate, which is why space is silent. But here, surrounded by air and solid objects, sound is always present at some level. Even your thoughts right now are atoms in motion. Neurons firing, neurotransmitters binding, ions flowing, all physical processes, all governed by the same laws that govern everything else. There's no separate realm for thoughts. They're part of the physical world, patterns of activity in a physical brain made of atoms. That doesn't diminish them. If anything, it makes them more remarkable. The fact that atoms can arrange themselves into a structure capable of thinking about atoms, capable of understanding the universe, capable of experiencing wonder and curiosity and love, that's astonishing. You're made of star stuff, arranged in a way that can contemplate star stuff. You are the universe experiencing itself, a local concentration of complexity in an otherwise simple cosmos. And tonight, you can let that universe continue its work while you rest. The atoms will keep their vigil, the molecules will keep their functions, the cells will keep their metabolism, the organs will keep their rhythms, all of it automatic, all of it reliable, all of it grounded in physical law. Just one more small fact, and then we drift completely. The hydrogen atoms in your body, the most common atoms in your cells, present in water, in proteins, in every organic molecule. Those hydrogen atoms are the oldest matter in your body. They were created in the Big Bang, in the first few minutes of the universe's existence. They've been cycling through the cosmos for nearly 14 billion years. They've been in stars, in planets, in living things, in oceans and atmospheres and ice. And now they're in you, part of your structure, part of your function, part of this moment. And in this moment you can rest. You can let go of the need to understand everything, to control everything, to manage everything. The atoms know what to do. They've always known. They've been following the same rules since time began, and they'll continue following those rules without any effort from you. You can trust the process. You can trust the physics. You can trust the chemistry. You can trust the quiet, patient work of matter, doing what matter does, bonding, vibrating, reacting, flowing, maintaining the patterns that allow you to exist. Just one more small fact, and then we drift. And you let the universe's smallest building blocks carry your thoughts away into the gentle dark, into the quiet, into the deep rest that comes from knowing that everything, at the smallest scale, is exactly as it should be and will continue to be, long after this night has passed into memory, and then into the endless recycling of atoms through time and space. The next story is about to begin. Please relax and enjoy. Tonight is a calm walk through Greek mythology and 100 gentle facts. Frame it like a dim, lantern-lit library. Names, symbols, and stories drifting by like quiet constellations. Tonight we settle into something ancient and quiet. Something that has waited for thousands of years and will wait 1,000 more. There is no urgency here. Just gentle voices from long ago carried on the night air like leaves drifting down from old trees. Each fact is a small step on a path that winds through starlit groves and marble halls that exist only in memory now. We're not here to memorize or test ourselves. We're here to let these stories wash over us like waves on a distant shore, rhythmic and slow. Breathe in, breathe out. Let each fact arrive and then release it. There's nothing to hold on to tonight. Just one more small myth, and then we drift. Greek myths often begin with chaos, not as disorder, but as an open, empty gap. Before anything existed, before light or dark or the concept of time itself, there was this vast emptiness. Not nothing, exactly, but a kind of yawning space, a mouth opened wide with no voice yet to fill it. The ancient Greeks didn't imagine chaos as confusion or violence. They saw it as potential, as the canvas before any paint, as silence before the first note of music. It was the gap between what wasn't and what would be, a threshold, a doorway standing in the middle of nowhere, waiting. And from that waiting, from that patient emptiness, something stirred. Not suddenly, not with drama, but with the slow certainty of dawn arriving. Just one more small myth, and then we drift. From chaos comes Gaia, the earth, imagined as a living foundation. She emerges not as a goddess standing on the ground, but as the ground itself, alive and aware. The ancient storytellers pictured her as breathing hills, as the warmth rising from soil in summer, as the deep stillness beneath mountains. Gaia is presence. She is the first solid thing, the first place where anything could stand or grow or rest. She doesn't arrive with fanfare. She simply is, suddenly and completely, as if she had always been waiting just beneath the surface of possibility. Her existence makes existence possible. She is the mother not just in the sense of giving birth, but in the sense of providing a home, a lap, a place to return to. Every valley is her cupped hand. Every mountain is her shoulder. And in her vast, patient body, all the stories to come will find their stage. The earth beneath your bed right now, solid and cool and holding you up while you rest, is part of that same ancient dream. Just one more small myth, and then we drift. Gaia gives rise to Uranus, the sky, a vast dome over everything. She creates him from herself, or perhaps calls him forth from the same emptiness that birthed her. Uranus is the ceiling of the world, the great arch that contains all weather and light, and the passage of celestial bodies. He is distant and beautiful, scattered with stars, like salt spilled on dark cloth. If Gaia is the warm embrace of the earth beneath your feet, Uranus is the cool mystery overhead, the place your eyes go when you wonder about infinity. Together they form the first relationship, the first partnership in all of creation, earth and sky. Below and above, the solid and the infinite, They meet at the horizon, that thin line where they seem to touch, though they remain forever separate. In this way, the myths teach us about connection and distance all at once, about how two beings can create together while remaining essentially themselves. The sky you saw today, whether clouded or clear, is the same sky these ancient people gazed at, painting stories across it with their imagination. Just one more small myth, and then we drift. Gaia and Uranus become the parents of powerful early beings called Titans. These are the first children of Earth and Sky, and they inherit something of both. They are vast in scale, embodying natural forces that seem bigger than human comprehension. There is Oceanus, the great river circling the world. There is Hyperion, associated with the light that comes before dawn. There is Theia, linked to the shimmer of precious things, the way gold catches sunlight, or how the moon glows silver. There is Chaos, connected to the northern axis of heaven, and Phoebe, tied to prophetic radiance. Each Titan is like a different weather, a different aspect of how the universe operates. They are not quite gods in the way the Olympians will be, not quite concerned with human affairs. They are older, stranger, more elemental. They represent the first attempt of the cosmos to organize itself, to take raw power and give it shape and name. And like all first attempts, they are magnificent and also destined to be surpassed. The world will move on from them, but their presence echoes through everything that comes after. Just one more small myth, and then we drift. Mythic family trees in Greece often explain how order replaces older powers over time. This is a pattern you'll notice as these stories unfold. The universe doesn't start perfect. It starts wild and unrefined, and slowly, through conflict and change, it becomes more structured, more balanced, more like the world humans can recognize and live in. The Titans rule before the Olympians overthrow the Titans. Each generation believes themselves more enlightened, more deserving of authority. But the myths are wise enough to remember what came before, to honor the foundations even as they're built upon. This is how children grow beyond their parents while still carrying their parents' blood. This is how civilizations rise from what preceded them. The Greeks understood that progress is not a straight line but a spiral, circling back to touch the past even as it reaches toward the future. These aren't just stories about supernatural beings fighting for cosmic real estate. They're stories about how change works, how time works, how everything that is new contains something old within it. Just one more small myth, and then we drift. The Titans represent an older generation of cosmic forces before the Olympians. Think of them as the rough draft of divinity. They are powerful, yes, immensely so, but they lack the refinement, the human-like qualities that the Olympians will eventually embody. The Titans are more like geological epochs, given consciousness. They move slowly. Their concerns are vast and abstract. When they love or hate, it's with the patience of erosion, with the unstoppable quality of tectonic plates shifting beneath the ocean. They don't meddle in human affairs because humans don't exist yet, and even when humans do arrive, the Titans are too distant, too cosmic to care much. They are the generation of raw power without the complexity of personality, and perhaps that's why they must eventually fall. The world needs more than raw force. It needs nuance, story, character. It needs gods who can feel jealousy over a slight, who can fall in love with mortals, who can make mistakes. The Titans are magnificent, but they are not quite enough. And so the wheel turns, as it always does. Just one more small myth, and then we drift. Cronus is one of the most famous Titans, associated with time and rule. His name in Greek sounds like the word for time, Chronos, though they are technically different figures. But the association stuck, and so Cronus carries the weight of temporality, of minutes ticking by, of ages passing. He is often depicted with a sickle or scythe, an agricultural tool that also became a symbol of harvest, of cutting down what has grown tall. Cronus will become the father of the Olympians, but he will also become their enemy, because he fears being overthrown just as he overthrew his own father. This is the great irony of his story. He is time itself, always moving forward, always consuming what came before. Time devours everything, even its own children, and Cronus will literally attempt to do just that. He rules the Titans during their golden age, when things are simpler, more abundant, more innocent. But golden ages never last. They can't. Time won't allow it. and Cronus, being time, cannot escape his own nature. Just one more small myth, and then we drift. The myths frequently describe generations of gods replacing each other, like seasons turning. Spring follows winter. Children grow into adults while their parents age. New ideas replace old ones. The Greeks saw this pattern everywhere in nature and built it into their understanding of the divine. Uranus is overthrown by Cronus. Cronus will be overthrown by Zeus. Each time, the younger generation swears they'll do better, be wiser, rule more justly. Each time they inherit some of the flaws of their predecessors. This isn't cynicism exactly, it's realism. It's the acknowledgement that change is constant, but not always progressive in a simple way. Each new regime brings benefits and costs. The first Olympians will be more involved with humanity, more accessible, more understandable. But they'll also be more petty, more jealous, more prone to interfering in mortal lives for trivial reasons. The Titans were distant but stable. The Olympians are closer but more chaotic. There's no perfect answer, the myths seem to say. There's only the endless turning of the seasons, the endless replacement of old with new. Just one more small myth, and then we drift. Rhea is a Titan linked to motherhood and the continuation of divine lines. She's Cronus's wife and sister, as is common in these early cosmic genealogies, where the family tree looks more like a family circle. Rhea represents fertility, the flow of generations, the preservation of life even in the face of destruction. When Cronus begins to swallow their children whole, fearing the prophecy that one will overthrow him, it is Rhea who devises the trick to save the youngest, Zeus. She wraps a stone in swaddling clothes and presents it to her husband, who swallows it without noticing. Meanwhile, Zeus is hidden away, raised in secret, protected until he's strong enough to fulfill his destiny. Rhea is patient. She is clever. She understands that you cannot fight time directly, but you can sometimes outwit it, delay it, sneak around its edges. She is every mother who has protected a child from a dangerous father, every woman who has preserved hope in a hopeless situation, every quiet act of resistance that changes the course of history. Just one more small myth, and then we drift. Early myths use family conflict as a symbolic way to describe change in the universe. When we hear that Cronus castrated his father Uranus with a sickle, we might wince at the violence. But the ancient listeners understood this as symbolic language. Sky and earth were too close, locked in constant embrace, leaving no room for anything new to grow between them. By separating them, by creating space, Cronus allows the world to breathe, to develop. The violence is really about necessary separation, about children establishing independence from parents, about the new requiring distance from the old to flourish. These aren't meant to be realistic family dramas, though they do capture real emotional dynamics. They're cosmic allegories, ways of explaining massive transformations in terms humans can relate to. We all know what it feels like to grow beyond our origins, to have to push away from what made us in order to become ourselves. The Greeks took that universal human experience and projected it onto the scale of the universe itself. Just one more small myth, and then we drift. Some versions include primordial forces like night, Nyx, as ancient quiet powers. Nyx emerges from chaos alongside or even before Gaia in certain tellings. She is the darkness itself, not evil, but simply the absence of light, the time of rest and dreams and stars. Even Zeus is said to respect Nyx, to be wary of crossing her. There's something profound in this, the idea that darkness is not subordinate to light but equal to it, necessary, worthy of reverence. Night is where we restore ourselves. Night is where the day goes to rest. Night is the black cloth on which the stars are embroidered. Nyx is often depicted as a figure of incredible beauty, winged and crowned with stars pulling a dark cloak across the sky. Her children include sleep and death, dreams and strife, and all the necessary balances that make existence bearable. Without night, day would be meaningless. Without rest, activity would be impossible. The ancient Greeks knew this, honoured this, built it into their understanding of the cosmos. Just one more small myth, and then we drift. The Greeks imagined the world as layered, sky above, sea around, and deep realms below. It was a vertical cosmos. At the top, Olympus, where the gods dwell in eternal golden light. In the middle, the surface of the earth, where humans struggle and build and love and die. Below that, the sea, Poseidon's domain, mysterious and dangerous and life-giving all at once. And deeper still, the underworld. Not hell exactly, but the land of the dead, where shades go after their bodies fail. Each layer has its own rules, its own character, its own deities and inhabitants. The myths travel up and down this vertical axis, gods descending to meddle with mortals, heroes descending to the underworld on impossible quests, mortals looking up at the stars and wondering. This layered structure gave the ancient world a sense of order, a mental map. You knew where you stood in relation to the divine and the dead. You knew your place in the grand architecture of existence. Just one more small myth, and then we drift. Myth time isn't measured like human time. It's dreamlike and symbolic. Events that should take years happen in a day. Journeys that should be impossible are completed. Heroes are born, grow to adulthood, accomplish impossible feats, and die all within the span of a story that takes less than an hour to tell. This isn't carelessness on the part of the storytellers, it's intentional. Mythic time operates on emotional logic, on the logic of dreams, where what matters is not how long something takes, but what it means. A journey to the underworld might represent a single night of grief or a lifetime of depression. A battle with a monster might symbolize any moment of facing fear. The flexibility of mythic time allows these stories to fit into any era, any life. They stretch and compress to accommodate whoever is listening. You don't need to imagine them as historical events that happened once. You can imagine them as psychological events that happen always, constantly, in the inner world where we all live. Just one more small myth, and then we drift. The first myths weren't written down at first. They were spoken and remembered. They were sung by bards at feasts, recited by parents to children, performed at festivals. They lived in human breath and human memory, changing slightly with each telling, adapting to new audiences, new times. This is why we have multiple versions of almost every story. There's no single authoritative text for most of Greek mythology. Instead, there's a living tradition, a river of stories that flows and branches and sometimes circles back on itself. Some details change, some stay constant. The core remains recognizable while the surface shifts. This is the nature of oral tradition, and it's beautiful in its way. It means these stories were never fixed, never dead on the page. They were alive in the same way language is alive, growing and evolving with the people who carry them. Even now, each person who hears these myths adds something to them. Their own understanding, their own needs, their own dreams. Just one more small myth, and then we drift. Many creation stories hint at a theme. The universe becomes more structured with each era, from the formless chaos to the solid presence of Gaia, from Gaia's solitary existence to her union with Uranus, from the Titan's cosmic simplicity to the Olympian's complex personalities. Each stage adds layers of organization, differentiation, specificity. The world starts as a blank canvas and slowly fills with detail and color and distinction. This mirrors human development too. We start as undifferentiated infants, and slowly we develop personality, preferences, individuality. We start with simple needs and gradually build complex desires and fears and hopes. The cosmos in Greek myth is doing the same thing on a grander scale. It's learning to be itself. It's discovering its own nature through trial and error, through conflict and resolution, through the endless dance of creation and destruction. And we, as humans, are part of that process, tiny but essential threads in the great tapestry being woven. Just one more small myth, and then we drift. The Olympian gods are named for Mount Olympus. Their mythic home in the clouds is the highest peak in Greece, snow-capped and majestic, often wreathed in clouds that hide its summit. The ancient Greeks looked up at this mountain and imagined it as the threshold between earth and heaven, the place where the gods have built their palaces. Olympus in myth is not quite physical, not quite spiritual. It exists in that liminal space where geography becomes theology. The gods feast there on ambrosia and nectar. They debate and scheme and celebrate, and sometimes they descend to the mortal world below to satisfy their curiosity or their desires. Olympus is stability in the midst of change, a fixed point in the divine realm while everything below shifts and alters. It's where power resides, where decisions are made that ripple out across the world, and yet it remains distant, unreachable by mortal feet, a reminder that there are heights we can imagine but never quite attain. Just one more small myth, and then we drift. Zeus is linked to sky, thunder, and the idea of divine leadership. He is the youngest son of Cronus and Rhea, the one who escaped being swallowed, who grew up hidden on Crete, who returned to wage war against his father and the Titans. Zeus embodies authority, but also the complications of authority. He is powerful, capable of hurling thunderbolts that can shatter mountains. He is wise when he chooses to be, settling disputes among gods and humans. But he is also impulsive, prone to infidelity, quick to anger. He is the king of the gods, but he's not an all-powerful monotheistic deity. He has limits. He has flaws. The other gods sometimes defy him or trick him. Fate itself is beyond his control. This makes him more interesting as a character, more human despite his divinity. He represents the exercise of power in all its complexity, both its necessity and its dangers, both its glory and its frequent abuse. Just one more small myth, and then we drift. Zeus is often symbolized by the eagle and the lightning bolt. The eagle because it soars higher than all other birds, closest to the sun, with vision so sharp it can spot a rabbit from impossible distances. The eagle is majesty and perspective, the ability to see the whole landscape at once. The lightning bolt because it's sudden, powerful, impossible to defend against. It comes from the clear sky without warning, illuminating everything for a split second before striking its target. These symbols tell us what Zeus represents: high vision, swift judgment, unstoppable force. But they also tell us about the costs of his kind of power. Eagles are solitary hunters, lightning destroys what it touches. There's a loneliness to absolute authority, a danger in wielding such force. The symbols don't just celebrate Zeus, they complicate him. They give us ways to think about what it means to rule, to judge, to punish. Just one more small myth, and then we drift. Hera is connected to marriage, family, and royal authority. She is Zeus's wife and sister, the queen of the gods, the protector of married women and the sanctity of the marriage bond. This makes her position tragically ironic, because Zeus is constantly unfaithful, constantly producing children with other goddesses and mortal women. Hera's myths are often about her rage at these infidelities, her persecution of Zeus's lovers and illegitimate children. Modern readers sometimes struggle with Hera, seeing her as jealous and vindictive, but her anger makes sense in context. She is the goddess of marriage, and her own marriage is a public mockery. She represents the pain of betrayal, the fury of broken promises, the complexity of trying to maintain dignity when you've been humiliated. She is powerful in her own right, commanding respect and fear, but she's trapped in a relationship that constantly undermines her. Her story asks difficult questions about commitment, about the cost of staying, about whether sanctity can survive hypocrisy. Just one more small myth, and then we drift. Hera is often associated with the peacock, a symbol of watchful presence. The peacock's tail feathers are covered in eyes, creating the appearance of constant vigilance, of seeing everything from every angle. This suits Hera, who is always watching for her husband's next betrayal, always alert to threats against her position and dignity. But the peacock is also beautiful, regal, proud in its display. When a peacock spreads its tail, it's impossible to look away. This is Hera too. Majestic, commanding attention, refusing to be ignored or diminished despite the pain she endures. The eyes on the peacock's feathers are said to come from Argus, a 100-eyed giant whom Hera employed to watch one of Zeus's lovers. When Argus was killed, Hera preserved his eyes in her sacred bird's plumage. It's a story about memory, about how we carry our losses with us, transformed into something beautiful even as they remind us of sorrow. Just one more small myth, and then we drift. Poseidon rules seas, storms, and earthquakes in Greek belief. He is Zeus's brother, one of the 3 sons of Cronus who divided the cosmos among themselves after defeating the Titans. Where Zeus took the sky and Hades took the underworld, Poseidon claimed the vast oceans that surround and permeate the earth. He is temperamental like the sea itself. He can be calm and generous, granting safe passage to sailors and abundant fish to coastal communities. But he can also be wrathful, stirring up storms that smash ships against rocks, sending earthquakes that topple cities. He represents the untamable aspects of nature, the forces that humans can never fully control or predict. You can honor Poseidon, make sacrifices to him, pray for his favor, but you can never command him, never know for certain how he'll respond. The sea keeps its own counsel, it gives and takes according to its own rhythms. Just one more small myth, and then we drift. Poseidon's symbol is the trident, like a C-shaped scepter. It's a three-pronged spear, practical for fishing, but in myth, transformed into an instrument of divine power. With his trident, Poseidon can split rocks to create springs of fresh water. He can strike the sea floor and cause earthquakes. He can calm waves or raise them into mountains. The three prongs have been interpreted in many ways over the centuries. Some say they represent the three aspects of water: liquid, ice, vapor. Others suggest they symbolize the sea's three main qualities: its depth, its power, its mystery. The trident also links Poseidon to human activity, to fishing and seafaring, reminding us that the gods are not entirely separate from our lives, but woven into our daily work, our survival, our relationship with the natural world. Every fisherman casting a net is, in a sense, in dialogue with Poseidon, hoping for his blessing, or at least his indifference. Just one more small myth, and then we drift. Demeter represents agriculture and grain, the calm rhythm of harvest seasons. She is the goddess who taught humanity how to cultivate the earth, how to plant and tend and reap. Without her, there would be no bread, no beer, no stored food to survive the winter. She is the difference between nomadic hunting and gathering and settled civilization. Her presence means abundance, golden fields of wheat swaying in the summer breeze, granaries full to bursting, the simple joy of enough. But her story is not simple or always joyful. She is also the mother of Persephone, and when her daughter is taken to the underworld, Demeter's grief causes the earth to become barren. Nothing grows, nothing blooms. The world enters a terrible winter from which it seems there will be no escape. This is the duality of agriculture itself. It requires both growth and dormancy, both plenty and scarcity, both the joy of harvest and the patience of waiting for spring. Just one more small myth, and then we drift. Demeter's myths reflect how vital food and farming were to Greek life. The ancient Greeks were an agricultural people. Their survival depended on successful harvests, on understanding the seasons, on working with the land rather than against it. When they told stories about Demeter, they were telling stories about their own lives, about the anxiety of planting and wondering if the rains would come, about the relief of a successful harvest, about the constant negotiation between human effort and natural forces beyond human control. Demeter was not a distant, abstract deity. She was as close as the nearest field, as immediate as hunger, as essential as the next meal. Her temples were centres of community, where people gathered to give thanks for abundance or to pray for relief from drought. Her festivals marked the turning of the agricultural year, giving structure and meaning to the passage of time. Just one more small myth, and then we drift. Athena is linked to wisdom, strategy, and skilled crafts. She sprang fully grown from Zeus's forehead, already armoured, already wise, already herself. This unusual birth gives her a unique position among the gods. She has no mother in most versions, or rather, her mother Metis was swallowed by Zeus while pregnant, so Athena emerged from her father alone. She represents intellect, the kind of thinking that plans ahead, that sees consequences, that wins battles before they're fought. But she's also the patron of weavers, potters, carpenters, all those who make beautiful and useful things with their hands and minds working together. She understands that wisdom is not just abstract philosophy but practical knowledge, the skill to create, to build, to improve the world through careful work. She is the goddess who values both the life of the mind and the life of making. Just one more small myth, and then we drift. Athena's symbol is the owl, representing thoughtful awareness. Owls see in the dark. They hunt silently, precisely. They watch from high perches, patient and still, missing nothing. This is Athena, the clear vision that perceives truth even in obscurity, the patient wisdom that waits for the right moment to act, the silent approach that achieves its goal without unnecessary noise or violence. The owl also connects Athena to night, to the hours when most people sleep but thinkers stay awake, wrestling with problems, seeking solutions, letting ideas crystallize in the quiet dark. She's the lamplit late, the scholar hunched over scrolls, the sudden insight that comes at 3 a.m. Her wisdom is not loud or boastful, it's calm, observant, deeply rooted in understanding how things work. Just one more small myth, and then we drift. Apollo is associated with music, healing, prophecy, and sunlight. He is one of the most complex and multifaceted gods, embodying seemingly contradictory qualities. He is the god of reason and order, but also of ecstatic prophecy. He is the healer who can also send plagues. He is beautiful and terrible at once, radiant and dangerous. His music can calm savage beasts or inspire armies to battle. His prophecies tell the truth, but often in ways that mislead or cause the very disasters they predict. He represents the ancient Greek ideal of balance, of the golden mean, the idea that excellence comes from harmony rather than extremes. But his myths often show how difficult that balance is to achieve, how easily order can tip into rigidity, how beauty can become cruelty, how healing and harm sometimes come from the same source. Just one more small myth, and then we drift. Apollo is tied to the lyre, a symbol of harmony and song. The lyre is a stringed instrument, elegant and portable, capable of producing melodies that seem to carry the structure of the cosmos itself. Apollo won the lyre from Hermes, who invented it, and it became his primary attribute, the tool through which he brings order to chaos. Music in the ancient world wasn't just entertainment, it was mathematics made audible, philosophy expressed in sound, a way of understanding the proportions and patterns that underlie reality. When Apollo plays his lyre, he's not just making pretty sounds, he's revealing the hidden harmonies of existence, the ratios and relationships that make the universe comprehensible. The lyre appears in countless myths and artworks, always identifying Apollo, always reminding us that wisdom and beauty are fundamentally connected, that truth has an aesthetic dimension, that understanding requires both mind and ear. Just one more small myth, and then we drift. Artemis is linked to wilderness, the moon, and protection of animals. She is Apollo's twin sister, but where he represents civilization's highest achievements, she represents what remains forever wild, forever free, forever beyond human control. She roams the forests with a band of nymphs, hunting with her silver bow, defending the animals she loves from excessive human predation. She is virgin in the ancient sense, meaning she belongs to no one, needs no one, is complete in herself. Her connection to the moon links her to cycles, to tides, to the rhythms of women's bodies, to the mysterious forces that pull and release in patterns we feel but cannot fully explain. She is fierce in her protection of young things, of children and newborn animals, but also merciless toward those who threaten what she guards. She represents the untamed feminine, the aspect of nature that nurtures and destroys with equal indifference to human wishes. Just one more small myth, and then we drift. Artemis is often symbolized by the deer and the bow. The deer is swift, alert, graceful, able to vanish into the forest at the first sign of danger. It represents the wildness that cannot be fully domesticated, the beauty that exists apart from human need or use. The bow is her tool, the weapon of the hunter who kills from distance, who need not engage in close combat, who strikes before the prey even knows it's been targeted. Together, these symbols speak to Artemis's nature. She's both hunter and protector, both. Deadly and nurturing, both distant and intensely present in the wild places of the world. To encounter Artemis in myth is often to be transformed, to learn humility before the natural world, to understand that humans are not the measure of all things, but merely one species among many, subject to laws older and deeper than civilization. Just one more small myth, and then we drift. Ares represents war's intensity, while Athena represents war's strategy. This distinction is crucial to understanding how the Greeks thought about conflict. Ares is the chaos of battle, the bloodlust, the rage, the physical violence of bodies colliding. He is what happens when order breaks down, when reason fails, when the only language left is the language of weapons. The Greeks generally didn't like Ares very much. He was necessary perhaps, but not admirable. His worship was limited, his myths often unflattering. He represents the part of war that everyone wishes would go away, the senseless destruction, The young lives wasted. The cities burned for no good reason. Athena, by contrast, represents the tactical mind, the general's art, victory achieved through planning rather than mere fury. She is war as a problem to be solved, as a challenge to intelligence. The Greeks preferred her version, the idea that even in conflict wisdom could prevail, that violence could be channeled toward meaningful ends rather than simply released. Just one more small myth, and then we drift. Aphrodite is associated with love, beauty, and attraction. She has two origin stories. In one, she's the daughter of Zeus and a titan named Dione, making her just another Olympian. But in the older, stranger version, she is born from the sea foam that formed when Cronus cast his father Uranus's severed genitals into the ocean. This second birth makes her older than the Olympians, primordial, a force that existed before the current order of things, and this suits her nature. Love and desire are older than... and desire. Civilization, older than law, older than reason. They operate according to their own logic, ungovernable and often destructive. Aphrodite can bless or curse, can grant happiness or inflict obsession. She's worshipped because everyone needs love, wants beauty, seeks connection. But she's also feared because everyone knows how dangerous desire can be, how it can make fools of the wise, how it can destroy everything carefully built. Just one more small myth, and then we drift. Aphrodite is often connected with doves and sea imagery. Doves are gentle birds, associated with peace and tenderness, their cooing a soft sound that suggests intimacy and comfort. They also mate for life in popular belief, making them symbols of fidelity and devoted love. The sea imagery comes from her birth, the goddess rising from the waves on a shell, depicted in countless artworks as the embodiment of beauty itself. Water is cleansing, transformative, necessary for life. The sea is mysterious and deep, hiding secrets, representing the unconscious, the emotional depths we can never fully sound. Aphrodite emerging from the sea suggests that love comes from someplace profound and ancient, that attraction is not superficial, but rooted in the deepest parts of our being, perhaps deeper than we can consciously access. She's what rises to the surface, beautiful and irresistible, from depths we barely understand. Just one more small myth, and then we drift. Hephaestus is the god of fire and forging, craftsmanship and invention. He is the blacksmith of the gods, creating their weapons and tools, their palaces and thrones. He is ugly in a pantheon of beautiful beings, often depicted as lame, walking with a limp, or supported by mechanical servants of his own creation. His story is sad in ways. He was thrown from Olympus as an infant, either by Zeus for being deformed, or by Hera in disgust at his appearance. He was raised by sea nymphs, learned his craft in hidden workshops, and eventually returned to Olympus, where he was accepted for his skills even if never quite for himself. Hephaestus represents the dignity of work, the value of making useful things, the intelligence of hands that can shape metal and stone. He shows us that beauty is not the only worthy quality, that creativity and utility matter, that the things we make can grant us place and purpose, even if our bodies or faces don't fit conventional standards. Just one more small myth, and then we drift. Hermes is the messenger, tied to travel, language, and clever exchange. He is the god of boundaries and of crossing boundaries, of roads and doorways, of the moment when you step from one place into another. He guides souls to the underworld, guides travellers safely home, guides words from speaker to listener. He is quick, witty, charming, amoral in the way that communication itself is immoral. A lie travels on the same roads as the truth. A theft requires the same skills as a trade. Hermes invented the lyre from a tortoise. Shell gave it to Apollo as compensation for stealing his cattle. He moves between worlds, between gods and mortals, between the living and the dead, comfortable everywhere, committed to nowhere. He wears winged sandals that let him fly, carries a caduceus, a staff entwined with serpents. He represents the free flow of goods and ideas, the networks that connect us, the exchanges that make society possible. Just one more small myth, and then we drift. Greek heroes often represent human effort meeting a world shaped by gods. They are not divine themselves, or only partly so, and that's what makes their stories compelling. Heroes struggle with limitations. They age, they bleed, they die. But they also achieve things beyond normal human capacity, things that require intervention from the gods or extraordinary courage or both. They navigate a world where the divine and mortal realms overlap, where you might accidentally offend a goddess, might find yourself bound by a prophecy, might be helped or hindered by forces you can neither see nor fully understand. The hero's task is to act well despite these constraints, to find agency and honour even in a cosmos that often seems arbitrary or cruel. They show us what humans can accomplish at their best, but also the costs of accomplishment, the scars and losses that come with glory. Just one more small myth, and then we drift. Heracles, or Hercules in Roman tradition, is known for completing famous labours as a symbol of endurance. He is the son of Zeus and a mortal woman, which makes Hera his enemy before he's even born. His life is marked by tremendous strength and terrible suffering. As a young man driven mad by Hera, he kills his own wife and children. In atonement, he must serve a lesser king and complete 12 impossible tasks: slay the invulnerable Nemean lion, kill the many-headed Hydra, capture the hind of Serenea, catch the Erymanthian boar, clean the Augean stables, drive away the Stymphalian birds, capture the Cretan bull, steal the mares of Diomedes, obtain the belt of Hippolyta, capture the cattle of Geryon, steal the apples of the Hesperides, and finally bring Cerberus from the underworld. Each labour is a story unto itself, filled with cleverness, strength, divine aid, and perseverance. Just one more small myth, and then we drift. Heracles' stories reflect the theme that strength can be guided by service. Raw power alone is not enough. In fact, raw power can be dangerous, destructive, tragic. Heracles' greatest strength is also the source of his worst moments. He kills monsters, but also kills innocents in his madness. His labours channel his power toward productive ends, toward protecting people, toward accomplishing things that benefit others. It's a kind of rehabilitation, a process of transforming dangerous strength into heroic achievement. This resonates beyond the myth. Any powerful capacity, whether physical strength or intelligence or charisma or wealth, needs direction, needs purpose, needs to be placed in service of something beyond itself. Otherwise it becomes its own kind of monster, consuming the person who holds it and everyone around them. Heracles learns to use his strength wisely, and in doing so, he becomes worthy of eventual immortality. Just one more small myth, and then we drift. Perseus is remembered for a quest that becomes a test of courage and luck. He is another son of Zeus, born to the mortal Danae, whom Zeus visited in the form of golden rain. Perseus's grandfather, fearing a prophecy that his grandson would kill him, locked Danae and infant Perseus in a chest and threw them into the sea, but they survived, washed ashore on a distant island, and Perseus grew to manhood there. When a king desired his mother and sought to get rid of Perseus, the young hero boasted that he could bring back the head of Medusa, the Gorgon whose gaze turned viewers to stone. This seemed impossible, a death sentence disguised as a quest, but Perseus receives help from the gods, winged sandals from Hermes, a mirrored shield from Athena, a sword and other tools. Using cleverness and divine gifts, he approaches Medusa while she sleeps, watches her reflection in his shield and cuts off her head. Just one more small myth, and then we drift. Perseus's myths often include helpful gifts from gods, tools for a difficult path. He doesn't succeed alone or purely through his own merit. He succeeds through a combination of courage, cleverness, and divine intervention. This is typical of Greek heroism. The hero who tries to go it alone, who rejects help, who trusts only in their own abilities, usually comes to a bad end. Perseus accepts the winged sandals, the mirrored shield, the helmet of invisibility. He listens when told how to find the Gorgons, how to approach them safely. He understands that wisdom includes knowing when to accept aid, when to follow advice, when to use tools that others have provided. His story suggests that humility and resourcefulness are as important as bravery, that success often comes from building on what others have made possible, that we all stand on foundations laid by those who came before. Just one more small myth, and then we drift. Theseus is tied to Athens and myths about leadership and responsibility. He is the great Athenian hero, the one who volunteers to enter the labyrinth on Crete to face the Minotaur and end the terrible tribute of Athenian youths being sacrificed to the beast. Theseus represents the courage to confront seemingly impossible odds, the willingness to risk yourself for your people, the cleverness to navigate complexity. He receives a ball of thread from Ariadne, the daughter of the Cretan king, which he unwinds as he walks into the labyrinth so he can find his way back out after killing the Minotaur. This thread becomes one of the most enduring images in myth, a symbol of any method or guide that helps us navigate confusion, any system that helps us remember our way through complexity. Theseus kills the Minotaur and leads the other Athenian youths to safety, cementing his reputation as a hero. Just one more small myth, and then we drift. Theseus's stories often show how heroes are praised for bringing order to chaos. He doesn't just kill the Minotaur. He ends a cycle of violence and fear. He transforms Athens' relationship with Crete from subjugation to something more equal. Later in his life, he unites the scattered communities of Attica into a single political unit centered on Athens, creating the foundation for what would become one of history's most influential city-states. He cleanses the roads of bandits and monsters, making travel safer. He establishes laws and institutions, but his later life is also marked by questionable decisions, by arrogance and mistakes that lead to tragedy. He abandons Ariadne, who helped him. He abducts young women. His son dies because of his rash judgment. The Greeks didn't shy away from these complexities. A hero could build a civilization and still be deeply flawed. Order and chaos, achievement and failure coexist in every life. Just one more small myth, and then we drift. Odysseus is famous for cleverness and long journeys home. He is the protagonist of Homer's Odyssey, the poem that describes his 10-year struggle to return to Ithaca after the Trojan War. Odysseus is not the strongest hero or the most beautiful or the most pious. He is the cleverest, the most adaptable, the most willing to use his mind when others reach for swords. He wins the Trojan War with the idea of the wooden horse, a deception so famous it gave us a phrase that still circulates today. His journey home is filled with obstacles, storms, monsters, angry gods, tempting goddesses, treacherous sailors. At every turn he must think his way through, must figure out how to survive when survival seems impossible. His journey is both literal and symbolic, both a tale of Mediterranean navigation and a map of the human condition, with all its trials and detours and unexpected delays. Just one more small myth, and then we drift. Odysseus symbolizes the idea that thinking can be a kind of strength. In a culture that valued physical prowess and courage in battle, Odysseus offered a different model of heroism. He is cunning, patient, willing to endure humiliation if it serves his long-term goals. When he finally reaches Ithaca, he doesn't immediately reveal himself. He disguises himself as a beggar, assesses the situation, plans his approach. He defeats the suitors who have invaded his home not through straightforward combat, but through a contest of his own design, using a bow that only he can string. His intelligence is his greatest weapon, more valuable than armor or sword. This elevation of cleverness reflects a certain Greek sensibility, a culture that valued wit and rhetoric, that debated in assemblies and law courts, that understood the power of words and strategy. Odysseus shows that brains can overcome brawn, that patience can defeat force, that sometimes the long way home is the only way. Just one more small myth, and then we drift. Heroes often face trials that are partly external and partly internal. Fear, pride, impatience. The monsters and obstacles are real within the logic of the myth, but they also represent psychological challenges. The Minotaur isn't just a creature in a maze, it's the confusion and fear we feel when lost. Medusa isn't just a woman with snake hair. She's the paralyzing power of shame or trauma that turns us rigid if we confront it directly. The sirens aren't just dangerous singers. They're any distraction or temptation that can lead us away from our goals. Heroes must fight these external battles, yes, but they must also overcome their own limitations. They must face fear without being controlled by it. They must feel pride in their achievements without letting hubris destroy them. They must want to reach their goal without impatience causing them to take shortcuts that lead to disaster. The hero's journey is always both outer and inner, both the path through the world and the path through the self. Just one more small myth, and then we drift. Greek myths rarely depict heroes as perfect. They are admired and flawed. Achilles is the greatest warrior of the Trojan War, but his pride nearly cost the Greeks everything. Heracles has unmatched strength, but is driven mad and commits terrible acts. Jason leads the quest for the Golden Fleece, but later betrays Medea, who helped him succeed. Theseus builds Athens, but abandons Ariadne and causes his own son's death. The Greeks understood that greatness and flaw could coexist, that the same qualities that make someone remarkable can also lead them into trouble. Achilles' fierce pride makes him unstoppable in battle, but also makes him sulk in his tent while his companions die. Heracles' strength lets him complete impossible labours, but also makes him dangerous when he loses control. This is deeply realistic, this acknowledgement that heroism doesn't require moral perfection, that admirable people are still fully human, capable of pettiness and mistakes and regret. Just one more small myth, and then we drift. The hero's journey often includes leaving home, learning, and returning changed. This is a pattern so common in myth that scholars have identified it across cultures and called it the monomyth, the one story told many ways. The hero starts in the ordinary world, is called to adventure, initially refuses, crosses a threshold into the extraordinary world, faces trials, receives aid, confronts death or transformation, seizes a prize or insight, and returns home with this new knowledge or power to benefit their community. Odysseus leaves Ithaca for war, spends 20 years away learning about himself and the world, and returns a different man, wiser and more patient. Jason leaves his home to seek the Golden Fleece, faces incredible dangers, and returns with both the fleece and hard-won wisdom. Perseus leaves his island, slays Medusa, and comes back able to protect his mother. The pattern repeats because it maps onto real human development, the way we all must leave childhood, face challenges that test us, and find our way back to contribute to the world we came from. Just one more small myth, and then we drift. Many heroes are linked to specific cities, giving places mythic identity. Athens has Theseus, Thebes has Oedipus and Cadmus, Ithaca has Odysseus, Sparta claims the Dioscuri. These associations weren't just stories, they were foundational to civic identity. Cities claimed heroes the way families claim ancestors, as a source of pride and legitimacy. Festivals and rituals kept these heroes present in daily life. Temples and shrines marked the supposed sites of their deeds. If you were an Athenian, you didn't just know about Theseus. You were a spiritual descendant of Theseus, inheriting his courage and cleverness. This gave citizens a sense of connection to something larger than themselves, a narrative that explained who they were and where they came from. It also created friendly rivalries between cities, each claiming their hero was the greatest, their myths the most impressive. Just one more small myth, and then we drift. Some heroes are remembered through constellations, stories written into the sky. Perseus and Andromeda, the princess he rescued from a sea monster, both have constellations. Orion the hunter shines in the winter sky. Hercules has his own constellation, as does the Hydra he fought. The ancient Greeks looked up and saw not just random stars but a cosmic storybook, the greatest myths projected onto the dome of heaven. These constellations served as calendars, telling farmers when to plant and sailors when to set out. They served as navigation aids, helping travellers find their way in darkness. But they also served as reminders, keeping the old stories alive, ensuring that each generation would look up and remember the heroes who came before. The night sky became a kind of immortality, a place where human achievement, however mythologized, could live forever. Just one more small myth, and then we drift. Greek myths treat fame as fragile. It can grow, fade, or transform into cautionary tale. Heroes seek glory, kleos, the kind of fame that will survive them, that will be sung by bards and remembered by future generations. But fame is not straightforward. It depends on storytellers choosing to tell your story, on your deeds being impressive enough to remember, on luck and context and the whims of memory. Some heroes who seem destined for greatness are forgotten. Others who seemed minor achieve unexpected immortality through a single memorable moment. And sometimes fame turns dark. You're remembered not for your achievements but for your failures, not as an inspiration but as a warning. Icarus is famous for flying too close to the sun, for failing to heed his father's advice, for falling. That's his whole story in popular memory. The myths acknowledge this instability, this recognition that reputation is something you can't entirely control, that it will be shaped by others long after you're gone. Just one more small myth, and then we drift. Jason is tied to the quest for the Golden Fleece, a symbol of risky ambition. The fleece is the skin of a magical ram, hanging in a sacred grove in Colchis, guarded by a dragon and an army. Jason assembles the greatest heroes of his generation, the Argonauts, to sail across dangerous seas and claim this prize. The quest is partly about proving Jason's right to rule, partly about adventure for its own sake, partly about the glory that comes from accomplishing the impossible. The Golden Fleece itself is beautiful and valuable, but its true worth is symbolic. It represents the goal that seems just out of reach, the achievement that will finally prove you're as great as you believe yourself to be. But the myth doesn't end with Jason's triumph. He gets the fleece with Medea's help, betrays her later, and loses everything. The quest that was supposed to establish his greatness becomes the beginning of his downfall. Ambition achieved can be as dangerous as ambition thwarted. Just one more small myth, and then we drift. Myths often use quests to teach patience and respect for boundaries. The hero who rushes forward without thinking tends to fail, or to succeed only at great cost. The hero who ignores warnings, who violates sacred spaces, who treats helping figures with disrespect, usually regrets it. Perseus succeeds partly because he listens to the gods' instructions. Orpheus fails to bring Eurydice back from the underworld because he looks back too soon, can't trust, can't wait. Psyche loses Cupid because she breaks her promise not to look at him. These aren't arbitrary rules. They represent the necessity of patience, of trusting the process, of respecting that some things require time and cannot be rushed. They represent boundaries that exist for good reasons, that protect us even when they seem restrictive. The myths value the hero who can restrain themselves, who can follow difficult instructions even when they don't understand the reason, who can respect limits even while pushing against them. Just one more small myth, and then we drift. Atalanta is remembered as a swift, skilled figure in myths about choice and challenge. She's a rare female hero in Greek myth, a huntress who participates in the Caledonian boar hunt and is so fast that she defeats most men in foot races. Her father wanted a son and abandoned her as an infant, but she survived, raised by a bear according to some versions. She grows up independent, skilled, dedicated to Artemis. When men seek to marry her, she devises a challenge. Any suitor must beat her in a race. If he loses, he dies. Many try, all fail. Finally, Hippomenes wins by dropping golden apples during the race, distracting Atalanta just enough to slow her down. The myth can be read many ways. It's about a woman trying to maintain her independence in a society that expects her to marry. It's about how even the swiftest can be caught if you find the right strategy. It's about the tension between desire for freedom and desire for connection. Just one more small myth, and then we drift. Bellerophon is linked to Pegasus, reflecting myths about soaring success and humility. Bellerophon is a hero who, with the help of Athena, tames the winged horse Pegasus and rides him to accomplish great feats, including slaying the Chimera, a fire-breathing monster. For a while, Bellerophon seems unstoppable, blessed by the gods, successful in every venture. But success breeds arrogance. He begins to think he deserves to live among the gods on Olympus. He tries to ride Pegasus up to the divine realm, but Zeus sends a gadfly to sting the horse. Pegasus bucks, and Bellerophon falls back to earth, crippled and humbled. He spends the rest of his days wandering, alone, a cautionary tale about hubris. The myth teaches that there are limits we must accept, that even our greatest achievements don't entitle us to overstep our place in the order of things, that pride truly does go before a fall. Just one more small myth, and then we drift. Heroes often meet guides, wise figures who offer rules, riddles, or quiet warnings. These mentors and helpers are crucial to the hero's success. Chiron the Centaur teaches many heroes the arts of war and healing. Athena appears to Perseus with advice and tools. Circe tells Odysseus how to navigate the dangers ahead, which paths to take, what sacrifices to make. These guides don't do the work for the hero, but they make it possible for the hero to succeed. They represent accumulated wisdom, the knowledge passed down through generations, the idea that no one accomplishes anything entirely alone. They also often provide moral instruction, reminding heroes of their responsibilities, warning them against excessive violence or pride. The guide figure is someone who has been where you're going, who knows the territory, who can offer the map even if you must walk the path yourself. Listening to guides is a sign of wisdom. Ignoring them is usually a sign of approaching disaster. Just one more small myth, and then we drift. Greek monsters often symbolize natural fears, storms, darkness, the unknown. Before science explained the world, people needed ways to make sense of the terrifying forces around them. Storms that destroyed ships became the wrath of Poseidon or sea monsters sent to punish hubris. Plagues became the arrows of Apollo. Earthquakes were attributed to subterranean giants or to Poseidon striking the earth with his trident. By giving these forces faces and names and stories, the Greeks made them less overwhelming. A monster can be fought, or outwitted, or appeased. Random meaningless disaster is harder to face. So the myths populate the world with beings that embody our fears, making them specific and in some sense manageable. The monster in the cave is terrifying, but at least it's located, identifiable, potentially defeatable. This is one of mythology's core functions, to give shape to the shapeless, to make the incomprehensible at least narratively coherent. Just one more small myth, and then we drift. Medusa has multiple versions. Some portray her as a monster, others as a tragic figure. In the oldest versions, she is simply a monster, one of 3 Gorgon sisters, born terrible with snakes for hair and a gaze that turns living things to stone. But later versions add complexity. They say Medusa was once beautiful, a priestess in Athena's temple, until Poseidon raped her in the sacred space. Athena, unable or unwilling to punish Poseidon, transformed Medusa instead, turning her beauty into monstrosity, her gaze into a weapon. This version reframes Medusa as a victim, punished for being victimized, her entire existence a cruel injustice. When Perseus kills her and takes her head as a trophy, it becomes a more complicated act. Is he a hero defeating evil, or is he the final violence against someone who has already suffered enough? The dual nature of the myth lets it speak to different concerns, different fears. Medusa is both the danger of female power and the tragedy of female vulnerability, both monster and martyr. Just one more small myth, and then we drift. Medusa's story became one of the most enduring symbols of power and protection. Even severed, her head retains its power to petrify. Perseus uses it as a weapon, turning enemies to stone. Athena eventually places it on her shield, the Aegis, making it a divine emblem. The image of Medusa's face, the Gorgoneion, appeared on shields, buildings, amulets, coins. It was apotropaic, meaning it warded off evil. The idea was that something so terrible could only be fought with something equally terrible, that the evil eye could be repelled by the Gorgon's gaze. This is a kind of sympathetic magic, using fear against fear. But it also suggests a deeper truth, that what we find monstrous or terrifying often contains power we can harness, that our own capacity for rage or vengeance or self-protection, though frightening, can also keep us safe. Medusa on a shield says, "I am not defenseless. I carry my own monstrosity, beware." Just one more small myth, and then we drift. The Minotaur is linked to the idea of a maze, confusion, complexity, getting lost. Half man, half bull, the Minotaur is the offspring of Pasiphae, the queen of Crete and a sacred bull. King Minos, ashamed of this monstrous child, has the master craftsman Daedalus construct an elaborate labyrinth to contain it. The labyrinth is so complex that anyone who enters becomes hopelessly lost, wandering forever or until the Minotaur finds and devours them. The structure itself becomes as much a character as the monster it contains. The labyrinth represents any problem that seems impossible to solve, any situation where every turn leads to more confusion, any time we feel trapped in our own thoughts, unable to find a way out. The Minotaur is the thing we fear at the centre of that confusion, the final confrontation we're avoiding, the truth we don't want to face. Theseus entering the labyrinth is anyone gathering the courage to face their deepest fear. Just one more small myth, and then we drift. The labyrinth in myth represents problems that require calm navigation. You can't panic in a maze. Panic makes you run in circles, makes you forget which paths you've tried, makes you exhaust yourself uselessly. Theseus succeeds because he has a method, the thread from Ariadne, and because he stays focused on his goal. He doesn't try to map the whole labyrinth or understand its complete structure. He just marks his path so he can retrace it. This is practical wisdom about problem solving. Sometimes you can't see the whole picture. Sometimes the complexity is genuinely overwhelming, but you can mark your progress. You can remember where you've been. You can move forward step by step, trusting that the method will work even when you can't see the outcome. The labyrinth teaches patience, teaches the value of simple, reliable techniques, teaches that confusion can be navigated if you don't lose your head. Just one more small myth, and then we drift. Sirens are remembered for songs that lure sailors, symbolizing distraction and desire. They're usually depicted as women, sometimes with bird bodies, who sit on rocks near dangerous shores and sing so beautifully that passing sailors can't resist steering toward them. The ships crash on the rocks and the sailors drown. The sirens represent temptation, the allure of something that promises fulfillment but delivers destruction. They are the distraction that makes you forget your goal, the desire that overrides your better judgment, the beautiful surface that conceals deadly danger. Odysseus, warned by Circe, wants to hear their song but knows he mustn't be able to act on that desire, so he has his crew plug their ears with wax and tie him to the mast. He hears the sirens' incredible music, begs to be released, but his crew, unable to hear either the song or his pleas, keeps rowing. It's a myth about self-control, about setting up systems that protect us from our own weakness, about knowing our vulnerabilities and planning for them. Just one more small myth, and then we drift. Centaurs are half human, half horse. Beings often used to explore wildness versus wisdom. Most centaurs in myth are savage, drunken, violent. They represent the bestial side of human nature, the appetites and aggression that civilization tries to restrain. When invited to a wedding, they get drunk and attempt to kidnap the bride, sparking a battle with the Lapiths. This becomes a common artistic motif, the clash between civilized humans and wild centaurs, order versus chaos. The centaur's dual nature makes them perfect symbols for the conflict within all of us, the part that wants to follow rules and the part that wants to trample them, the rational mind and the uncontrolled body. The Greeks saw this tension as fundamental to human experience. We are not purely rational beings, not purely animal. We're both, awkwardly combined, and the struggle to balance these aspects is never-ending. Just one more small myth, and then we drift. Some centaurs are unruly, but Chiron is portrayed as wise and healing. Chiron is the great exception, a centaur who embodies wisdom, kindness, skill in medicine and music and prophecy. He is the tutor of heroes, teaching Achilles and Jason and Asclepius. Unlike his savage kin, Chiron represents the best of both human and animal nature, the strength and vitality of the horse combined with the intelligence and compassion of humanity. His existence suggests that the wild and civilized need not always be in conflict, that there's a possibility of integration, of wholeness. Chiron is eventually wounded by a poisoned arrow, and because he's immortal, he cannot die but must endure endless pain. He chooses to give up his immortality to escape suffering, a decision that highlights his wisdom and his understanding that some conditions are worse than death. His myth celebrates the teacher, the healer, the one who helps others become their best selves. Just one more small myth, and then we drift. Satyrs appear as playful woodland beings, tied to music and mischief. They have the legs and horns of goats, the torsos of men, and they spend their time drinking, dancing, playing flutes, and chasing nymphs through the forest. They are followers of Dionysus, the god of wine and ecstasy, and they embody a similar spirit of revelry and abandon. Satyrs represent playfulness, sensuality, the freedom to enjoy pleasure without guilt or restraint. They remind us that not everything must be serious, that life needs music and laughter, that sometimes the best thing to do is to dance in the woods. But they also represent excess, the danger of indulgence without limits. They're often drunk, often crude, often crossing boundaries they shouldn't. They're tricksters, not entirely trustworthy, more interested in their own pleasure than in responsibility or consequences. Like many figures in Greek myth, they contain both positive and negative potential, both the joy of freedom and the chaos of license. Just one more small myth, and then we drift. Nymphs are nature spirits connected to trees, springs, and quiet places. They are minor goddesses, beautiful and long-lived, but not immortal. Each type of nymph is associated with a specific natural feature. Naiads live in freshwater springs and rivers. Dryads live in trees, their lives bound to the life of their tree. Oryds dwell in mountains. Nereids are sea nymphs. daughters of the sea god Nereus. Nymphs represent the sacredness of nature, the idea that the natural world is alive and aware, that every spring and grove has its own spirit. They are often helpers to heroes, offering guidance or aid. They are sometimes lovers of gods or mortals, bearing children who become heroes or founders of cities. But they can also be dangerous if offended or pursued too aggressively. They ask for respect, for recognition that nature has its own dignity and should not be thoughtlessly exploited or violated. To honour the nymph is to honour the place itself. Just one more small myth, and then we drift. The Greeks imagined the world as alive with beings representing landscapes. Every river had its god, every mountain its nymph, every forest its spirits. This wasn't mere superstition or primitive thinking. It was a way of encoding an ethic of respect and attention. If you believe a spirit dwells in the spring, you're less likely to pollute it. If you think a dryad lives in the oak, you're more careful about which trees you cut. This worldview makes the natural environment sacred, not in an abstract way, but concretely, locally, specifically. It creates a relationship between humans and places, a sense that we live among other conscious beings who deserve consideration. It also makes the world more enchanted, more full of potential meaning and encounter. You're never truly alone in such a world. You're always in the presence of the divine, in the smallest stream, the quietest grove. Just one more small myth, and then we drift. The underworld includes many figures, not just one ruler, like a whole hidden society. Hades rules, but he's supported by a complex bureaucracy of death. Thanatos is the personification of death itself, the gentle or sometimes violent end. Hypnos is sleep, Thanatos' twin brother, both sons of Nyx. The three fates, Clotho, Lachesis, and Atropos, spin, measure, and cut the thread of each life. The judges of the dead, Minos, Rhadamanthus, and Aeacus, determine where souls will go based on their lives. Cerberus guards the gates. Charon ferries souls across the river. The underworld is not chaos or mere punishment. It's ordered, structured, governed. It has its rules and roles and rhythms. This structure provides comfort, the idea that even death is not meaningless void, but a place with its own systems, where you will be judged fairly, where there is continuation of some kind. Just one more small myth, and then we drift. Hades rules the underworld, but he is not the same as a devil figure. This is an important distinction that gets lost sometimes in modern understanding. Hades is not evil. He's not torturing souls for pleasure or tempting people to sin. He's the administrator of the dead, the king of a necessary realm. Someone has to manage death. Someone has to ensure that the dead stay dead, that the natural order is maintained. Hades does this job, not with malice, but with a kind of grim duty. He's stern, unyielding, but not cruel. In most myths, he's actually one of the more reliable and less problematic of the major gods. He doesn't chase mortal women like Zeus. He doesn't hold petty grudges like Hera. He just does his job, ruling his dark kingdom, ensuring that death remains stable and final. The Greeks feared death, of course, but they didn't morally condemn its ruler. Just one more small myth, and then we drift. Charon is the ferryman, symbolising a calm crossing between worlds. He poles his boat across the Styx or the Acheron, depending on the version, carrying the souls of the dead from the land of the living to the land of the dead. He charges a fee, an obol, a small coin, which is why Greeks placed coins on the eyes or in the mouths of the deceased. If you couldn't pay Charon, you'd be stuck on the near shore for 100 years, unable to enter the underworld proper, unable to find rest. Charon is often depicted as old, grumpy, indifferent to the pleading of souls. He doesn't care who you were in life, what you accomplished, what you left undone. He cares only whether you can pay. He represents the inexorable, impersonal nature of death. It comes for everyone. It doesn't care about your excuses or your unfinished business. But he also represents a transition that can be navigated, a crossing that, once paid for, is actually quite simple. Death as a journey, not an ending. Just one more small myth, and then we drift. Cerberus is the underworld's guardian, more like a boundary marker than a villain. He is a massive dog with 3 heads, sometimes depicted with a serpent for a tail, with snakes writhing from his neck. He guards the gates of Hades, and his job is specific. He lets the dead enter but prevents them from leaving, and he prevents the living from entering at all. He's very good at his job. When Heracles must bring Cerberus to the surface as his final labour, he doesn't kill the beast but wrestles it into submission, and then returns it, unharmed, afterward. When Orpheus must pass Cerberus to retrieve Eurydice, he charms it with music so beautiful the three-headed dog falls asleep. Cerberus represents boundaries that must be respected, thresholds between states of being. You cannot return from death. The living and dead must remain separate. These aren't arbitrary rules, but necessary ones. Cerberus enforces them, not out of cruelty, but out of cosmic necessity. Just one more small myth, and then we drift. Mount Olympus isn't just a mountain. It's a symbol of unreachable calm authority. You can see it from much of northern Greece, snow-capped and magnificent, rising above the ordinary landscape. The ancient Greeks looked at it and imagined it as the home of the gods, a place of eternal summer and peace, far above human suffering and confusion. The gods feast there, debate there, scheme there, but they're always fundamentally removed from the mortal world. Olympus represents aspiration, the height we might dream of reaching but never quite can. It's the perfection we imagine but cannot achieve. It's stability and order in a world of change. And it's also, perhaps, a kind of loneliness, the isolation that comes with being at the top, with being too far removed from ordinary life to fully understand it. The gods on Olympus are powerful and glorious, but they're also, in some ways, trapped there, separated from the vitality and meaning of mortal existence. Just one more small myth, and then we drift. Delphi was a famous sanctuary where people sought guidance from the oracle. It sits on the slopes of Mount Parnassus, a dramatic location overlooking a valley. The oracle, the Pythia, was a priestess who would enter a trance, perhaps from volcanic fumes rising through a fissure in the earth, and deliver prophecies from Apollo. People came from all over the Greek world to ask questions. Should we go to war? Where should we found a new colony? What should we do about this plague? The oracle's answers were famously ambiguous, often phrased in ways that could be interpreted multiple ways. This wasn't a failure of the oracle, but part of its function. It made people think, made them consider possibilities, made them active participants in shaping their own fate, rather than passive recipients of certainty. Delphi became incredibly wealthy and powerful from the offerings of petitioners, a centre of religious, political and cultural life for centuries. Just one more small myth, and then we drift. The oracle's voice represented mystery, answers that arrive like dreams. Her prophecies were not straightforward commands, but cryptic poetry, images and metaphors that required interpretation. When King Croesus of Lydia asked if he should attack Persia, the oracle said that if he crossed the river, a great empire would fall. Croesus took this as encouragement and attacked. He was defeated, and it was his own empire that fell. The prophecy was true, but not in the way he understood. This is the nature of Delphic wisdom. It tells the truth, but the truth is complex, multifaceted, open to misunderstanding. It requires humility to receive such answers, a willingness to sit with uncertainty, to recognize that knowledge doesn't always mean clarity. The oracle teaches that the future is not a fixed path, but a landscape of possibilities, that our interpretations and actions shape what comes to pass. Just one more small myth, and then we drift. Temples were not only religious, they were community centres, treasuries, landmarks. A Greek temple wasn't like a modern church where congregants gather for services. Most religious rituals happened outside, at altars in front of the temple. The temple itself housed the cult statue of the god and stored valuable offerings, but it served many other functions too. It was a place where treaties were signed, where treasure was safeguarded, where important civic decisions were made. It was a physical anchor for the community, a beautiful building that represented collective achievement and devotion. The construction of a temple required enormous resources and collaboration, and its completion was a source of pride. To visit a temple was to connect with the divine, yes, but also to connect with your fellow citizens, with your city's identity, with the continuity of tradition across generations. The temple stood as a reminder of what could be achieved when people worked together towards something greater than themselves. Just one more small myth, and then we drift. The labyrinth is a place of legend tied to hidden pathways and careful thinking. Beyond its association with the Minotaur, the labyrinth became a symbol in its own right, representing any complex problem, any situation where the path forward is unclear, any time we feel trapped in our own thoughts. Later thinkers used the labyrinth as a metaphor for the mind, for philosophical inquiry, for the spiritual journey. Walking a labyrinth became a meditative practice in some traditions, a way of literally following a winding path as a form of prayer or reflection. The labyrinth teaches us that complexity is not necessarily a trap, that winding paths can still have centres, that patience and method can guide us through even the most confusing terrain. It also teaches us that sometimes the way in is the way out, that retracing our steps is not failure but wisdom, that the solution to being lost is often to remember how we got there. Just one more small myth, and then we drift. The river Styx is a boundary river in the underworld, tied to sacred promises. It circles the realm of the dead 7 or 9 times, depending on the version, separating the living world from the realm of Hades. Its waters are black and cold, and they're said to have unique properties. Swearing on the Styx creates an unbreakable oath, binding even to the gods themselves. If a god swears by the Styx and breaks that oath, they must drink from the river and then lie comatose for a year, unable to speak or move, followed by 9 years of exile from the company of the other gods. This makes the Styx the ultimate guarantor of truth, the standard by which all promises are measured. The river represents the absolute, the inviolable, the boundary that even divine power cannot cross with impunity. It's a myth about the importance of keeping your word, about integrity being more fundamental than power. Just one more small myth, and then we drift. Swearing on the Styx in myth represents an oath that must be honoured. When Demeter seeks help in searching for Persephone, the gods swear by the Styx to aid her. When Achilles' mother tries to make him invulnerable, she dips him in the Styx, though she holds him by the heel, which remains mortal. The river appears again and again as the ultimate sanction, the final court of appeal. This reflects how seriously the ancient Greeks took oaths, how central they were to social and political life. Without a system of trust, without the ability to make binding agreements, complex societies fall apart. The Styx makes sacred what might otherwise be fragile, makes permanent what might otherwise shift. It's a way of saying some things are non-negotiable, some promises must be absolute. The river is black and deadly, yes, but it's also what makes truth possible, what allows gods and mortals to trust each other even in the face of conflicting interests. Just one more small myth, and then we drift. Ambrosia is the food of the gods, a symbol of divine otherness. Exactly what it is varies by account. Sometimes it's a solid, sometimes a drink, sometimes indistinguishable from nectar. What matters is that mortals cannot eat it safely. It confers immortality on the gods, sustains their divine nature, but for mortals it's deadly or transformative in dangerous ways. This creates a clear boundary between human and divine. We eat bread and meat, they eat ambrosia. We drink wine and water, they drink nectar. The different diet symbolizes a fundamental difference in nature. We are mortal, bound to earth, subject to decay. They are eternal, inhabitants of Olympus beyond death. Ambrosia appears in myths as a temptation sometimes, the promise of immortality, but mortals who seek it usually meet bad ends. The myth teaches acceptance of our nature, suggests that trying to become what we are not leads to tragedy, that there is dignity in being fully and only human. Just one more small myth, and then we drift. Nectar is the drink of the gods, often paired with ambrosia in calm descriptions. While ambrosia is food, nectar is drink, and together they sustain immortal life. The word nectar has passed into our language to mean any delicious drink, but in myth it's specific, supernatural. It appears in golden goblets at divine feasts poured by Hebe or Ganymede, youths who serve as cupbearers to the gods. Nectar represents the sweet pleasures of eternal existence, the idea that divine life is not just long but also pleasant, full of beauty and joy. But like ambrosia, it marks a division. The gods drink nectar while mortals drink wine, and that difference matters. It reminds us that some experiences, some states of being are not accessible to us. We can imagine them, we can tell stories about them, but we cannot actually cross that threshold. The presence of nectar in myth creates a sense of longing, of wanting what we cannot have, which is one of the most human feelings there is. Just one more small myth, and then we drift. The golden fleece symbolizes a prize that seems simple until you try to reach it. It's the skin of a golden ram, hanging in a sacred grove, guarded by a dragon and the soldiers of Colchis. Jason must bring it back to reclaim his throne, and the quest seems straightforward. Sail to Colchis, take the fleece, return. But nothing is simple. The journey involves navigating the clashing rocks, which crush ships between them. It involves enlisting Medea's help, which leads to betrayal and tragedy. It involves defeating impossible challenges, sowing dragon's teeth that sprout into armed warriors. The fleece represents any goal that looks achievable until you start trying, any ambition that reveals unexpected complications. It's the job that seems perfect until you start working there. It's the relationship that seems ideal until you're actually in it. The myth teaches that there are no shortcuts, no easy prizes. Everything worth having requires facing difficulties, making compromises, changing in ways you didn't anticipate. Just one more small myth, and then we drift. The Aegis, Athena's shield, symbolizes protection and authority. In some versions, it's a goat skin. In others, a shield decorated with the head of Medusa. Zeus wields it sometimes, as does Athena. When the Aegis is shaken, it creates thunder and strikes terror into enemies. It represents ultimate defensive power, the ability to protect yourself and those under your care. But it's also an offensive weapon, used to intimidate and demoralize. This dual nature fits Athena, who is both protector and warrior, both defender of cities and strategic destroyer of enemies. The Aegis appears in the Iliad, in accounts of battles where gods intervene to protect their favourite mortals. It's not just a physical object, but a symbol of divine backing, of being under the protection of powers greater than yourself. To stand behind the Aegis is to be safe. To face it is to know you're defeated before the fight begins. Just one more small myth, and then we drift. Hermes' winged sandals symbolize speed, travel, and the lightness of passing through. They allow him to fly, to move between realms, to cover vast distances instantly. They represent the freedom of movement, the ability to go anywhere, to cross any boundary. Hermes is the only god who moves freely between Olympus, the mortal world, and the underworld. He guides souls to the afterlife, carries messages between gods, helps travelers find their way. His winged sandals make this possible, literally and symbolically. They represent communication, the flow of information, the connections that bind distant places and people together. In a world without instant communication, without easy travel, Hermes' sandals were the fantasy of overcoming distance, of being able to be in multiple places, of never being stuck or isolated. They're the ancient version of the internet, in a sense, the dream of frictionless connection across space. Just one more small myth, and then we drift. Poseidon's trident symbolizes the sea's shifting mood, calm, storm, depth. With his three-pronged spear, Poseidon can stir the ocean into towering waves or smooth it into glass. He can split rocks to release fresh water or cause earthquakes that reshape the land. The trident is power over fluidity, over the elements that shift and change, over forces that cannot be permanently controlled or predicted. The sea is never fully known. You can sail it for decades and still encounter storms that surprise you, currents you didn't expect, depths you hadn't imagined. Poseidon's trident embodies that mystery and power. It's a reminder that nature operates on scales and according to rules that dwarf human capacity to manage or understand. We can learn to work with the sea, to read its signs, to respect its moods, but we can never master it. The trident ensures we remember that. Just one more small myth, and then we drift. Apollo's lyre symbolizes balance, music, and measured breath. The lyre's strings must be tuned just right, not too tight, or they break, not too loose, or they produce no clear sound. Playing it requires precision, timing, an ear for harmony. Apollo's music brings order to chaos, calms wild beasts, makes even the muses stop to listen. The lyre represents the idea that beauty emerges from proper proportion, that excellence requires discipline and restraint, that the goal is not to dominate or overwhelm, but to find the perfect balance. This is central to Greek aesthetic and ethical philosophy. The ideal is the golden mean, the middle path between extremes. Too much courage is recklessness. Too Little is cowardice, too much pleasure is decadence, too little is joylessness. Apollo's lyre, perfectly tuned and perfectly played, embodies this ideal of measured excellence. Just one more small myth, and then we drift. Mythic objects often represent a single idea: protection, temptation, truth, or time. Athena's shield is protection, Aphrodite's girdle is desire, Hermes' caduceus is mediation and commerce, Cronus' scythe is time's harvest. These objects are not just props but concentrated symbols, ways of making abstract concepts tangible and memorable. When a hero wields Athena's shield, they carry the idea of protection into battle. When someone falls under the spell of Aphrodite's girdle, we understand it as desire making them irrational. The objects work as storytelling shorthand, as visual markers that carry meaning. They also work as talismans in a sense, reminders of what's important, what to strive for, what to avoid. They're teaching tools, ways of transmitting values, and wisdom across generations. A child who hears about Apollo's lyre learns about the importance of harmony. A listener who remembers Pandora's box learns about curiosity and consequence. Just one more small myth, and then we drift. Greek myths helped explain natural cycles before modern science. Why does winter come? Because Persephone must spend part of each year in the underworld with Hades, and Demeter grieves, causing the earth to become barren. Why do we have seasons? Because of the negotiated settlement between Demeter and Hades, with Persephone dividing her time. Why do storms arise at sea? Because Poseidon is angry, or because a sailor has offended him? Why do plagues strike? Because Apollo is punishing the people for some transgression. These explanations may not match our scientific understanding, but they served important psychological and social functions. They made the world feel less random, more comprehensible. They provided ways to think about and respond to natural disasters. They created a framework for ritual action, for trying to influence outcomes through prayer and sacrifice. Just one more small myth, and then we drift. The story of Persephone is tied to seasons, growth, rest, and return. Persephone is gathering flowers in a meadow when Hades, lord of the underworld, emerges from a chasm in the earth and abducts her, taking her to his dark realm to be his queen. Demeter searches frantically for her daughter, and in her grief and rage causes all vegetation to wither. Zeus must intervene, sending Hermes to negotiate Persephone's release. But because Persephone has eaten pomegranate seeds while in the underworld, she's bound to return there for part of each year. The compromise: she spends spring and summer with her mother, and the earth blooms in Demeter's joy. She spends fall and winter in the underworld, and the earth goes dormant in Demeter's sorrow. The myth maps emotional states onto agricultural cycles, making the turn of seasons a cosmic drama of loss and reunion. Just one more small myth, and then we drift. Myths often frame winter as a time of quiet waiting, not punishment. Winter in the Persephone myth is not presented as evil or wrong, even though it involves Demeter's grief. It's a necessary part of the cycle, a time when the earth rests, when seeds lie dormant underground, when energy is conserved for the burst of growth that will come in spring. This reflects an agricultural understanding that you cannot harvest continuously, that the land needs time to recover, that there are seasons for work and seasons for rest. It also reflects a psychological wisdom about the rhythms of life. There are times of energy and activity and times of withdrawal and reflection. There are times of joy and times of sorrow. Both are necessary. Winter is not failure or punishment. It's just winter. It will pass. Spring will return. The myth promises this, encodes this hope into the very structure of the cosmos. Just one more small myth, and then we drift. The Greeks valued xenia, hospitality to strangers, as a sacred social rule. Many myths reinforce this value. Zeus and Hermes sometimes travel in disguise as beggars to test people's hospitality. Those who welcome them, offer food and shelter even from their own poverty, are rewarded. Those who refuse or mistreat them are punished, often destroyed. Xenia was not just politeness or generosity. It was a religious obligation, a social necessity in a world without hotels or social services. Travellers depended on the kindness of strangers. Communities depended on the exchange of hospitality to maintain trade networks and alliances. To refuse a stranger was to break the social contract, to risk becoming a stranger yourself someday and finding no welcome. The myths made this concrete. The stranger at your door might be a god in disguise. Better to err on the side of generosity. Better to share what you have. Just one more small myth and then we drift. Many. Myths warn about hubris, meaning destructive pride or overconfidence. Hubris is one of the central concepts in Greek thought. The kind of arrogance that offends the gods and brings about downfall. It's thinking you're as good as a god, or better. It's boasting that you can't be defeated. It's refusing to acknowledge limits or to show proper respect. The myths are full of examples. Arachne boasts she's a better weaver than Athena and is transformed into a spider. Niobe boasts about her children and sees them all killed. Icarus ignores his father's warning and flies too close to the sun, melting his wax wings and plunging to his death. The pattern is consistent. Pride leads to a fall. This isn't arbitrary divine cruelty. It's a warning against losing perspective, against thinking you've transcended the conditions that govern everyone else, against forgetting you're human and mortal and limited. Just one more small myth, and then we drift. Myths suggest balance, power with restraint, courage with humility. The Greek ideal was not to be the strongest or the bravest or the cleverest, though those qualities were admired. The ideal was to possess excellence without letting it corrupt you, to be great while remaining aware of your limitations. The tragic heroes are often those who excel in one quality but lack balance. Achilles is the greatest warrior, but his pride makes him rigid and self-destructive. Oedipus is incredibly intelligent, solving the riddle of the Sphinx, but his confidence blinds him to the truth about himself. The myth suggests that virtue lies in moderation, in the middle path between excess and deficiency. Be brave, but not reckless. Be proud of your achievements, but not arrogant. Be confident, but not blind to your flaws. This is hard wisdom, requiring constant vigilance and self-awareness, but it's the path the myths recommend. Just one more small myth, and then we drift. Constellations preserve myths as memory, stories pinned to the night sky. When the Greeks looked up, they saw the belt and sword of Orion the Hunter. They saw Ursa Major, the great bear that was once the nymph Callisto. They saw Cassiopeia, the vain queen punished for her boasting. They saw Perseus holding Medusa's head, saw Andromeda chained to rocks, saw the winged horse Pegasus flying across the heavens. These constellations served as a kind of library, a repository of stories that everyone could access simply by looking up. The stars don't change, or change so slowly that they seem eternal. So the myths attached to them take on that same quality of permanence. Generation after generation could look up and see the same patterns, hear the same stories, feel connected to everyone who had ever gazed at those stars before them. It's a beautiful continuity, a way of preserving culture in something as enduring as the cosmos itself. Just one more small myth, and then we drift. Many modern words come from Greek myth names like Titanic or Herculean. When we describe something as Titanic, we're invoking the Titans, those primordial giants of enormous power. When we call a task Herculean, we're comparing it to the labours of Heracles. A narcissist takes their name from Narcissus, who fell in love with his own reflection. Something erotic relates to Eros, the god of love. A panic is named for Pan, the god of wild places whose sudden appearances frighten travellers. An echo comes from Echo, the nymph condemned to repeat others' words. The language is filled with these references, ghosts of myths that most people no longer know in detail, but that still shape how we talk, how we think, how we understand the world. The myths have sunk deep into the linguistic and conceptual foundations of Western culture, so deep that we use them without realizing we're doing so. Just one more small myth, and then we drift. Greek myths influenced later Roman myths, European art, literature and theatre. The Romans adopted and adapted Greek mythology wholesale, changing the names but keeping most of the stories. Zeus became Jupiter, Aphrodite became Venus, Ares became Mars. Renaissance artists returned to classical sources, painting scenes from myth on chapel ceilings and palace walls. Shakespeare filled his plays with mythological references. Milton used Greek and Roman mythology to structure Paradise Lost. The myths provided a common cultural language for educated Europeans for centuries, a shared set of stories and symbols that everyone could reference and build upon. Even as Christianity became dominant, the old myths never quite disappeared. They persisted in education, in art, in literature, constantly being reinterpreted for new contexts, new concerns. Just one more small myth, and then we drift. Myth names still appear in astronomy: moons, planets, and spacecraft. The planets are named for Roman gods: Mercury, Venus, Mars, Jupiter, Saturn. The moons of Jupiter are named for Zeus's lovers and children: Io, Europa, Ganymede, Callisto. The Apollo program that took humans to the moon invoked the god of light and prophecy. The Cassini spacecraft that explored Saturn was named for an astronomer, but it studied the planet named for the god of time. The asteroids include Ceres, Juno, Vesta, Pallas, a whole pantheon floating in the space between Mars and Jupiter. This naming convention connects our modern exploration of space to ancient wonder at the heavens. It acknowledges that the impulse to understand the cosmos, to map it and name it and tell stories about it, is as old as civilization itself. We're still doing what the Greeks did, looking up and trying to make sense of what we see. Just one more small myth, and then we drift. The underworld myths often reflect a simple human comfort. Even endings have structure. Death is terrifying, partly because it seems like chaos, like the end of everything orderly and known. But the myths about the underworld present it as organised, governed, comprehensible. There are rivers you cross. There are judges who evaluate your life. There are regions for different kinds of souls. There's a ruler, officials, laws. You don't just cease to exist or dissolve into chaos. You go somewhere, you continue in some form, you're subject to rules and processes that make sense. This is profoundly comforting. It suggests that death, while still frightening, is not annihilation. It's a transition to a different state, one that has its own order, its own meaning. Whether the ancient Greeks literally believed in this geography of death or whether they understood it as metaphor, the structure provided solace, a way of thinking about mortality that made it less overwhelming. Just one more small myth, and then we drift. Greek mythology isn't one fixed book. There are many versions shaped by region and time. The myths existed in oral tradition long before they were written down, and even after Homer and Hesiod and the tragedians created literary versions, the stories kept changing. A myth told in Athens might differ from the same myth told in Thebes or Corinth. A version from the Archaic period might emphasize different elements than a version from the Classical or Hellenistic period. This fluidity can be frustrating if you want definitive answers, if you want to know exactly what happened in the story, but it's also liberating. It means the myths are alive, adaptable, responsive to different needs and contexts. It means there's no single orthodox version you must accept. You can find the version that speaks to you, that makes sense for your questions and concerns. The myths are a tradition, not a scripture, and traditions are meant to be passed on and reinterpreted, not frozen in place. Just one more small myth, and then we drift. Myths endured because they're flexible. They can be caution, comfort, or wonder. A single myth can function in multiple ways depending on what you need from it. The story of Pandora's box can be a cautionary tale about curiosity, comfort about hope remaining even after disaster, or a wonder about how suffering entered the world. The story of Orpheus can warn about looking back, can comfort those who have lost loved ones with the image of love that endures beyond death, or can inspire wonder at the power of music and art. This multivalence is one reason the myths have survived for thousands of years. They're not single-purpose tools, but rich, complex narratives that contain multiple meanings, multiple truths. Different people find different things in them. The same person finds different things at different times in their life. The myths give us what we need when we need it, if we're willing to listen. Just one more small myth, and then we drift. A gentle takeaway. Myths are patterns, ways humans learn to name the unknown. Before we had scientific explanations for why thunder happened or where the sun went at night or why people die, we had stories. These stories weren't wrong exactly, they were attempts to pattern the chaos, to find meaning in experience, to create frameworks for understanding. They encoded wisdom about how to live. Be hospitable, don't be arrogant, honour your parents, keep your promises, accept your mortality. They provided emotional catharsis, ways to process fear and grief and joy through narrative. They created community, shared stories that bound people together across time and space. The content of the myths may be fantastic, gods and monsters and impossible feats, but the function is deeply human and deeply practical. We still do this, still tell stories to make sense of our lives, still use narrative to find meaning. The myths are just an earlier, more explicit version of what we all do naturally. Just one more small myth, and then we drift. Final comfort, you are part of the same storytelling species, and tonight you can let the stories fade. The ancient Greeks who told these myths, who painted them on pottery, who carved them into temple pediments, who taught them to their children, they were fundamentally like us. They wondered about the same things we wonder about. They feared the same things we fear. They hoped for the same things we hope for. They created these elaborate, beautiful stories as a way of grappling with existence, and those stories have come down to us across thousands of years, still resonant, still meaningful, still capable of teaching and comforting and inspiring. You've walked through that ancient library tonight, brushed against those quiet constellations of meaning. You've let the names and symbols and stories drift past you like leaves on water. You don't need to hold on to them. You don't need to test yourself or prove you remember. The myths will be there whenever you want to return to them. For now, it's enough to have listened, to have let them wash over you, to have rested in the presence of these old, patient stories. Just one more small myth, and then we drift. Return to the room, to slow breathing. Feel the bed beneath you, solid and real. Feel the weight of the blankets, the soft pillow supporting your head. The myths are still there, but they're fading now, receding back into the realm of story, back into the quiet dark where such things live. You've touched them, and they've touched you, and that's enough. There's nothing more you need to do tonight, nothing to solve, nothing to understand completely, nothing to chase or grasp or hold. The stories have been told. The lantern is dimming. The library is closing its doors. You are here, in this moment, in this place, breathing in and breathing out, safe and whole and ready to rest. Just one more small myth, stretched out with silence, and then we drift. And then we drift. And then we drift into sleep, into dreams, into the quiet dark that holds us all, as it has always held us, as it will always hold us, patient and gentle and endless. Just one more small myth, and then we drift. The next story is about to begin. Please relax and enjoy. You're lying still now, breathing quietly, and the room around you has begun to soften into that particular kind of darkness that feels less like absence and more like presence. A gentle weight of shadow that doesn't press but simply rests. If you were to open your eyes, you might see the faint edge of a window frame, or the suggestion of a ceiling, or perhaps just the interior of your own eyelids catching the last traces of distant light. But you don't need to open your eyes. You don't need to do anything at all except breathe and listen, and let your attention drift like a leaf on the surface of a very still pond. Tonight, there are no journeys to take, no distances to cross, no landscapes rushing past. You're not travelling anywhere. You're simply here, settled in place, while something vast and patient unfolds in your mind like a map drawn in whispers. And what unfolds is this: an idea about endings that aren't really endings at all, about lights that don't go out but only change shape, about transformations so slow and so enormous that they look, from a distance, like stillness itself. Imagine for a moment that your room is not just a room, but a kind of observatory. Not the cold, mechanical kind with telescopes and computers, but something older and quieter, a place where you can simply lie still and feel the fact of distance, the fact of light crossing unimaginable stretches of space to reach you. In the universe beyond your ceiling, beyond the atmosphere, beyond the tug of Earth's gravity, there are lights burning. We call them stars, and tonight you're going to learn what happens when those lights begin to change, when they reach the end of their fuel, when they stop being what they were and become something else entirely. But here is the first thing, the anchor you can return to whenever the idea feels too large or too strange. Nothing disappears. Nothing is ever truly gone. When a star completes its life, it doesn't vanish into nothingness. It transforms. Its light becomes heat. Its heat becomes motion. Its atoms, the fundamental pieces of matter that made up its enormous body, rearrange themselves, drift outward, cool and mix, and eventually gather again into new structures, new stars, new worlds, new possibilities. The universe is not in the business of endings. It is in the business of reorganizing itself, over and over, with a patience that has no deadline and no anxiety. You don't need to hold on to this idea tightly. You don't need to memorize it. Just let it rest somewhere in the back of your mind, the way a nightlight rests in the corner of a room, casting its small glow without demanding attention. Nothing disappears. Everything only changes. And change, when it happens slowly enough, when it happens across millions or billions of years, is not frightening. It is simply the way things are. Now let your breathing settle into a rhythm, slow, steady, predictable. In and out, in and out. There is no hurry. There is all the time in the world, and more than that, all the time in the universe. And as you breathe, as your body relaxes degree by degree into the surface beneath you, let me tell you what a star really is. A star is not magic, though it looks like it from here. A star is not a decoration in the sky, though we have used it that way for as long as humans have had eyes to see. A star is a kind of compromise, a living balance, a negotiation between two fundamental forces that have been arguing with each other since the beginning of time. On one side, there is gravity, pulling, always pulling, drawing matter inward, trying to collapse everything into the smallest, densest point it can. On the other side, there is pressure, the pressure that comes from heat, from motion, from particles moving so fast and colliding so often that they push outward against the inward pull. And for a very long time, millions of years, billions of years, these two forces meet in the middle. They balance, they hold still. That stillness is what we call a star's life. It is not dramatic. It is not loud. It is not even particularly eventful if you are somehow able to watch it from up close. A star in the prime of its life is just sitting there, massive beyond comprehension, burning hydrogen in its core, releasing energy, holding its shape. It does this the way your heart beats, the way your lungs expand and contract, automatically, reliably, without needing to think about it. The star doesn't know it's a star. It doesn't know it's beautiful. It simply is, and it continues to be, because the forces inside it have found their equilibrium. Deep in the center of a star, where the pressure is highest and the temperature is almost unimaginable, hydrogen atoms are squeezed together so tightly, moving so fast, colliding with such energy, that they overcome the natural repulsion between them and fuse. They join. 4 hydrogen nuclei become 1 helium nucleus, and in that transformation, a tiny amount of mass is converted into energy, into light, into heat, into the radiation that pushes outward and keeps the star from collapsing under its own weight. This is fusion. This is the engine. This is what makes a star, and not just a cold lump of gas drifting through the void. And here is the thing that might surprise you. This process is gentle. It happens one atom at a time, one fusion event among countless trillions, in a course so vast that even light takes hours to travel from the center to the surface. The energy produced in the core of a star doesn't rush out all at once. It diffuses, it bounces, it is absorbed and re-emitted, working its way outward through layers of dense gas over thousands, sometimes hundreds of thousands of years, until finally it reaches the surface and escapes into space as the starlight you see. So when you look up at a star, when you see that tiny point of light against the darkness, you are seeing the end of a very long journey. You are seeing energy that was born in the unimaginable furnace of a stellar core that struggled outward through an ocean of matter that finally broke free and travelled across light years of empty space to reach your eye. And that light is old. It is patient. It has been travelling for a long time, and it will continue to travel, spreading outward in all directions until it is absorbed by something else, a planet, a speck of dust, your retina, and becomes, once again, something new. Now, as you lie here in your quiet room, bring your attention back to your breathing. Notice how steady it is. Notice how it doesn't require effort. Your body knows how to do this. It has found its own balance, its own compromise between the need for oxygen and the need to release carbon dioxide, and it maintains that balance automatically, the way a star maintains its balance between gravity and pressure. You are, in your own small way, a system in equilibrium, and that equilibrium is not static. It is alive. It adjusts. It responds. It continues. Let me tell you now about colour, because colour is a clue, a gentle signal that tells us something about the nature of a star without needing to visit it, without needing to touch it or measure it directly. When you heat something up, a piece of metal, a filament in a light bulb, the coil of an electric stove, it begins to glow. And the colour of that glow depends on the temperature. Cooler things glow red or orange, hotter things glow yellow or white, even hotter things glow blue or blue-white, fierce and bright. This is not arbitrary. This is a law of nature, as reliable as gravity, as predictable as the turning of the Earth. A star's colour is its temperature made visible. When you see a star that looks bluish or blue-white, you are seeing something with a surface temperature of tens of thousands of degrees. When you see a star that looks yellowish or white like our own sun, you are seeing a surface temperature of a few thousand degrees, still unimaginably hot by human standards, but cooler than the blue giants. And when you see a star that looks orange or red, you're seeing something cooler still, a surface that might be only a few thousand degrees, though only is a strange word to use for temperatures that would vaporize anything we know in an instant. Colour is mood, colour is temperature, colour is a thermostat you can read from trillions of miles away. And here is the important part, the part that ties into what comes next. A star's colour can change. Not quickly. Nothing about stars happens quickly, except at the very end for the largest ones. But over time, over the long arc of its life, a star's surface temperature can shift, and when it does, the colour shifts too. A star that was once white might become red. A star that was once small and dim might swell and brighten, not because it's burning more fiercely, but because it's rearranging itself, spreading out, changing the architecture of its interior. This change is not a sign of danger, it is not a warning. It is simply the universe adjusting its balance, finding a new equilibrium, exploring a new configuration. And you can let that idea settle into your mind the way you let your body settle into the bed beneath you. Change is not the enemy of stillness. Change is just the universe breathing, in and out, across timescales so immense that they look, from our brief perspective, like eternity itself. Now we come to the stars that are most like our sun, the medium-sized ones, the ones that are neither giants nor dwarfs, the ones that burn their hydrogen steadily and patiently for billions of years before anything begins to shift. These stars, and there are countless billions of them scattered through the galaxies, have endings that are slow, gradual, almost unhurried. Their deaths, if you want to call them deaths, are more like long, gentle exhalations than sudden collapses. They do not explode. They do not shatter. They simply run low on fuel, rearrange themselves and settle into a new, quieter state. Here is how it happens. For most of a star's life, the core is fusing hydrogen into helium, and that fusion releases energy, and that energy pushes outward, holding the star up against gravity's inward pull. But hydrogen, even in the vast reservoir of a stellar core, is not infinite. Eventually, after 5 billion years, after 10 billion years, after however long the star's particular size and composition allow, the hydrogen in the core begins to run low. The fusion slows, the energy output drops, and when that happens, the balance shifts. Gravity, which has been waiting patiently all this time, begins to win. The core contracts, it shrinks, and as it shrinks, it heats up. This is a fundamental principle of physics, that compressing a gas makes it hotter, and that heat begins to do something new. It starts fusing hydrogen in a shell around the now depleted core, a layer where hydrogen still exists in abundance. And this shell fusion, strangely enough, produces more energy than the core fusion did. The star's luminosity increases, it brightens. But the outer layers of the star don't know what's happening in the deep interior. They don't feel the new shell burning away. All they know is that suddenly there is more energy pushing outward, more pressure expanding them, and so they do what any gas would do under those circumstances. They expand, they swell, the star grows larger, its radius increases, not by a little, but by a lot. It might grow to 10 times its original size, or 50 times, or even more, depending on its mass and composition. And here is the crucial detail. As the outer layers expand, they cool. They spread out, and in spreading out, the heat that was concentrated in a smaller volume is now distributed across a much larger surface area. The temperature of the star's surface drops, and when the temperature drops, the colour changes. The star, which might have been yellow or white, becomes orange, then red. It becomes what we call a red giant. A red giant is not a dying star in the sense of something that is suffering or fading away. It is a star in transition, a star that has moved from one phase of life to another. It is still producing energy. It is still shining, often more brightly than before, but its light is now spread across a much larger surface, so the surface itself is cooler and thus redder. If you could stand at a safe distance and watch a star become a red giant, you would see it grow and dim in surface brightness per unit area, but grow so much in total size that its overall luminosity might actually increase. It would be a strange, slow-motion transformation, like watching a balloon inflate over the course of 1,000,000 years and the balloon is made of fire. During this red giant phase, something else is happening in the core. The helium that was produced during the long hydrogen-burning phase has been accumulating, settling, becoming denser and hotter as the core contracts, and eventually, if the star is massive enough, and stars like the Sun are just massive enough, the core reaches a temperature where helium itself can fuse. Helium nuclei begin to slam together with enough energy to overcome their repulsion, and they fuse into carbon and sometimes oxygen, releasing energy in the process. This is called helium burning, and it provides a new source of pressure, a new way to resist gravity's pull. But helium burning doesn't last as long as hydrogen burning. Helium is a less efficient fuel, and there's less of it to begin with. The star might spend only a few 100,000,000 years in this phase, compared to the billions it spent fusing hydrogen. And when the helium runs out, the same thing happens again. The core contracts, heats up, and begins fusing in a shell, while the outer layers expand even further. The star might pulsate, might vary in brightness, might shed material in gentle waves, like a slow-motion tide going out, and then comes the shedding. Not all at once, not in an explosion, but in a gradual release that takes thousands of years. The outer layers of the star, now only loosely bound by gravity, begin to drift away. They are pushed outward by radiation pressure, by the momentum of light itself, by the subtle forces of stellar winds, streams of particles that flow out from the star's surface like a breeze. These layers spread into space, forming a shell, a cloud, a nebula of gas and dust that glows faintly in the light of the star's remaining core. And what remains at the centre, after the outer layers have drifted away, is something small and dense and incredibly hot. It is the core of the star, no longer fusing anything, no longer producing energy through nuclear reactions, but still glowing intensely from the heat it has accumulated over billions of years. We call this a white dwarf. It is roughly the size of Earth, but it contains as much mass as the Sun. It is so dense that a teaspoon of its material would weigh tons, and it is hot, tens of thousands of degrees at the surface, but it has no way to replenish that heat. It is not burning, it is not fusing, it is simply radiating away the stored thermal energy, slowly, over billions and billions of years. A white dwarf is the universe's version of a warm ember. It glows, but it is not on fire. It fades, but it is in no hurry. It will take longer than the current age of the universe for a white dwarf to cool completely, to become what we might call a black dwarf, a cold, dark cinder floating through space. And because the universe is not yet old enough, because not enough time has passed since the first stars were born, there are no black dwarfs yet. Every white dwarf that has ever formed is still glowing, still radiating, still gently dimming, but not yet gone. Let your mind rest on that for a moment. A white dwarf is not dead, it is not absent, it is still there, still present, still contributing a tiny amount of light to the cosmos. It has completed one phase of existence and entered another. And in entering that new phase, it has released material, the outer layers it shed, back into space, back into the great reservoir from which new stars and planets will eventually form. Nothing disappears, nothing is lost. Everything only changes hands, changes form, changes location. Now we turn our attention to the material that was released, the gas and dust that drifted outward from the red giant and now surrounds the white dwarf like a faint glowing halo. We call this a nebula, though that word is used for many different kinds of clouds in space. In this case, it is a planetary nebula, not because it has anything to do with planets, but because when astronomers first saw these objects through early telescopes, they looked round and disc-like, similar to how planets appeared. The name stuck even though we now know they are something entirely different. A planetary nebula is the universe's way of recycling. It is not waste, it is not refuse. It is raw material, rich with the elements that were forged in the star's interior over billions of years. Hydrogen, yes, but also helium and carbon and nitrogen and oxygen, elements that did not exist in great abundance when the universe was young, but that have been steadily accumulating in stars and then released back into space when those stars reach the end of their hydrogen-burning lives. This cloud of gas and dust spreads outward, cooling as it goes, mixing with the interstellar medium, the thin gas that fills the space between stars. It might drift for thousands or millions of years, becoming more diffuse, more spread out, until eventually it becomes indistinguishable from the general background. But it is not gone. It is still there, still present, now part of a larger whole. And given enough time, given the pull of gravity acting over vast distances, some of that material will gather together again. It will clump, it will collapse under its own weight, it will heat up and spin and flatten into a disk, and in the centre of that disk a new star will begin to form. And around that new star, in the cooler regions of the disk, some of the gas and dust will condense into solid particles, and those particles will stick together, and over time, over millions of years, they will grow into planets, and moons, and asteroids, and all the other objects that populate a solar system. And those planets, those worlds, will be made of the material that came from earlier stars. They will be constructed from recycled carbon and oxygen, and silicon and iron, from atoms that once burned in the core of a star, that once floated in the atmosphere of a red giant, that once drifted through space as part of a nebula. You're lying still, breathing quietly, and your body, the body that is holding you, that is keeping you warm, that is processing oxygen and circulating blood and maintaining the countless balances that constitute life. That body is made of this material. The carbon in your cells, the oxygen you breathe, the calcium in your bones, the iron in your blood, all of it came from stars. Not from the star that lights our days, not from the sun directly, but from earlier generations of stars that lived and changed and released their contents back into the universe so that new things could form. This is not poetry. This is not metaphor. This is literal truth, confirmed by decades of careful observation and measurement and theoretical work. You are made of stardust, yes, but more than that. You're made of stellar ash, of the transformed remnants of fusion reactions that took place billions of years ago in the cores of stars that no longer exist in their original form. Those stars completed their cycles. They became red giants. They shed their outer layers. They left behind white dwarfs and nebulae. And from those nebulae, over vast stretches of time, new stars and planets formed, and eventually on at least one of those planets, life emerged and evolved and became complex enough to lie in a dark room and think about where it came from. Let that idea rest gently in your mind, not as something you need to grasp or hold on to, but as something you can simply let be there, like a presence in the room. You are connected to the stars not metaphorically, but materially. You are part of the same process, the same cycle of transformation and rearrangement that has been going on for as long as the universe has had matter and energy and time. Now, before we move on, let me gently address a question that might be forming in your mind. What happens to planets when a star becomes a red giant? What happens to worlds that might be orbiting that star, worlds that might be bathed in its light, that might depend on its heat for their climates and their seasons and their very existence? The answer is not simple, because every star system is different, and every planet's orbit is unique, but we can sketch the general outlines. When a star expands into a red giant, it grows enormously. Our Sun, for example, is expected to swell to perhaps 100 times its current radius when it enters this phase, billions of years from now. That expansion would engulf the inner planets, Mercury, Venus, possibly Earth. Those worlds, if they are still there, if they haven't already been destroyed by other processes, would find themselves inside the outer atmosphere of the star itself. They would be subjected to intense heat, to friction with the surrounding gas, and they would likely spiral inward and be destroyed, vaporized, their material added to the star's outer layers. But the outer planets, the gas giants, the ice worlds, might survive. They would be too far away to be engulfed. They would experience a change in the light they receive, a change in the temperature, a change in the appearance of the star that dominates their sky, but they would not be destroyed. They might even become more hospitable in a strange way, as the increased luminosity of the red giant warms them, melts their frozen surfaces, stirs their atmospheres. Of course, this warmth would not last. Once the star sheds its outer layers and becomes a white dwarf, the luminosity would drop dramatically, and those outer worlds would freeze again, returning to the cold and dark they knew before. The point here is not to catalogue every possible outcome, but to emphasise that the universe does not follow a single script. Every system is different. Every star has its own mass, its own composition, its own history, and every planet's fate depends on its orbit, its size, its composition, and 1,000 other variables that we could never list completely. There is uncertainty here, and that uncertainty is not something to fear. It is simply the nature of a universe that is vast and complex and full of possibilities. Even when environments change, even when stars transform and planets are threatened or altered, gravity continues to shape things. Orbits persist, or they change, or they decay, but they follow laws, patterns, cycles. There is a kind of order in the chaos, a kind of predictability in the transformation. The universe is not random. It is not capricious. It is governed by principles that we can study and understand, even if the specific outcomes are sometimes beyond our ability to predict with perfect accuracy. And now let your breathing slow a little further. Let your body sink a little deeper into the surface beneath you. You're still here, still present, still listening, but your attention is beginning to soften, to drift, to become less focused and more diffuse, like the outer layers of a star beginning to spread into space. We have been talking about stars like the sun, stars that end their lives gently, that become red giants and white dwarfs, that release their material gradually and settle into a long, slow fade. But not all stars are like this. There are stars that are much larger, much more massive, and their endings are different. They are faster, they are brighter, they are more intense, and yet, even in that intensity, there is a kind of order, a kind of logic, that makes them not frightening but simply powerful. Events that happen because physics demands them, because the laws of nature lead inevitably from one state to another. A massive star, one with many times the mass of the sun, perhaps 10 times, 20 times, 50 times or more, burns through its fuel much faster than a smaller star. This might seem counterintuitive at first. You might think that a star with more fuel would last longer, but the opposite is true. A massive star has more fuel, yes, but it also has more gravity, and that gravity compresses the core more intensely, heats it to higher temperatures, and drives fusion reactions at a much faster rate. A massive star burns bright and hot and fast, consuming its hydrogen in just a few million years rather than the billions of years a sun-like star might enjoy. And when the hydrogen runs out in the core of a massive star, the same thing happens as in a smaller star. The core contracts, heats up, and begins fusing helium. But in a massive star, the process doesn't stop there. The core gets hot enough, dense enough, to fuse helium into carbon and oxygen, and then, when the helium runs out, the core contracts again, heats up again, and begins fusing carbon, and then oxygen, and then neon, and magnesium, and silicon, each stage producing heavier elements, each stage lasting a shorter amount of time than the one before. The star becomes like an onion, with layers of different elements burning in shells around the core, each layer fusing its fuel into something heavier, each layer adding to the growing mass of the core. Hydrogen burning in the outermost shell, helium burning in the next layer in, carbon, oxygen, neon, silicon, each in its own layer, each producing energy, each pushing outward against gravity, each contributing to the complex structure of the star's interior. And at the very centre, the core itself is growing, accumulating the products of all these fusion reactions, becoming richer and richer in iron and nickel and elements near them on the periodic table. And here is the critical point, the point where everything changes. Iron is the end of the line. Iron is the most stable nucleus in terms of binding energy. Fusing iron into heavier elements does not release energy. It requires energy. It is an uphill process, not a downhill one. And so when the core of a massive star becomes rich in iron, when it has converted most of its material into this final, stable form, fusion stops. The energy production stops. The outward pressure that has been holding the star up for millions of years suddenly disappears, and gravity, which has been waiting, which has been patient, which has been held at bay by the pressure of fusion, wins. The core collapses, and it collapses fast. Not over thousands of years, not over minutes, but in less than a second. The core, which might be as large as Earth, compresses to a sphere only a few miles across, and in doing so, it releases an enormous amount of gravitational potential energy. The infalling material rebounds, it bounces, and that bounce combined with a flood of neutrinos, ghostly particles that barely interact with matter but carry away vast amounts of energy, blows the outer layers of the star outward in an explosion we call a supernova. Let me be very clear about the language here, because I want this to remain calm, to remain bedtime safe, to remain something you can listen to as you drift towards sleep. A supernova is not an act of violence, it is not a catastrophe, it is a physical process, a transformation, a rearrangement of matter and energy on an enormous scale. It is intense, yes. It is brief, yes. For a few weeks, a single supernova can outshine an entire galaxy, can release as much energy as the sun will produce over its entire 10 billion year lifetime. But it is not malevolent. It is not angry. It is simply the universe doing what the universe does, following the laws of physics from one state to another. Think of it as a cosmic bloom, a flower opening, but a flower made of light and matter and energy, a flower that opens all at once and then fades, leaving behind seeds scattered across space. Those seeds are the heavy elements that were forged in the star's core and in the explosion itself. Carbon, oxygen, neon, magnesium, silicon, sulfur, iron, and dozens of others, including elements heavier than iron that can only be created in the intense conditions of a supernova. All of these elements are thrown outward, carried by the expanding shockwave, mixed into the interstellar medium, where they will eventually become part of new clouds, new stars, new planets. This is recycling on the grandest scale imaginable. The supernova does not erase the star. It distributes what the star made. It takes the products of millions of years of fusion and scatters them across light years of space, enriching the galaxy, providing the raw material for future generations of stars and worlds. And in that distribution, in that scattering, the star completes its role in the cosmic cycle. It transforms, it changes form, it does not disappear. And what is left behind at the centre, after the explosion has passed, after the outer layers have blown away, that depends on the mass of the core that collapsed. If the core is not too massive, if it is below a certain threshold, roughly a few times the mass of the Sun, the collapse stops when the matter becomes so dense that it is supported by a new kind of pressure, a quantum mechanical effect called neutron degeneracy pressure. The result is a neutron star. A neutron star is one of the strangest objects in the universe. It is the collapsed core of a massive star, compressed to the point where protons and electrons have merged to form neutrons, and those neutrons are packed together as tightly as matter can be packed, without collapsing further into a black hole. A neutron star might be only 10 or 20 miles across, but it contains more mass than the Sun. A sugar cube-sized chunk of neutron star material would weigh as much as all of humanity. The gravity at the surface is so strong that if you could somehow stand there, you would be flattened instantly, compressed into a layer a few atoms thick. But you're not standing on a neutron star. You're lying in your bed, breathing slowly, letting this information wash over you like a gentle wave. A neutron star is not a threat. It is not hunting for you. It is simply an outcome, a state of matter that exists in the universe, an example of what happens when gravity is allowed to compress matter as far as the laws of physics will allow without crossing the final threshold into a black hole. Neutron. Stars are quiet. They spin, often very rapidly, sometimes hundreds of times per second, because as the core collapsed, any rotation it had was conserved and amplified, the way a figure skater spins faster when they pull their arms in. Some neutron stars have intense magnetic fields, and they emit beams of radiation from their magnetic poles, and if those beams happen to sweep across Earth as the star rotates, we see a pulse of light or radio waves with each rotation. We call these pulsars, and they are among the most precise clocks in the universe, ticking with a regularity that rivals or exceeds the best atomic clocks humans have built. But even a pulsar is not actively doing anything. It is not trying to communicate. It is not signalling. It is just spinning and shining and gradually slowing down over millions of years as it loses energy to radiation and the subtle effects of its magnetic field interacting with the surrounding space. Now, if the core that collapses is even more massive, if it exceeds another threshold somewhere around 3 times the mass of the Sun, then not even neutron degeneracy pressure can stop the collapse. Gravity wins completely. The core continues to compress, continues to shrink, continues to fall inward, and there is no force in the universe that can halt the process. The result is a black hole. A black hole is not a hole in the usual sense. It is not empty. It is not a tunnel or a gateway or a portal to another place. It is a region of space-time where gravity has become so strong that the usual rules of distance and time break down in ways that are difficult to visualize, but straightforward to describe mathematically. At the center of a black hole, according to our current understanding, is a singularity, a point where density becomes infinite, where the equations of general relativity break down, where we simply don't know what happens because we don't yet have a theory that successfully merges quantum mechanics and gravity. But you don't need to worry about the singularity because you can never see it, never reach it, never interact with it directly. What defines a black hole, what makes it a black hole, is the event horizon, the boundary around the singularity, the surface of no return. Inside the event horizon, space-time is curved so severely that all paths lead inward. Light itself cannot escape. Anything that crosses the event horizon is gone, at least from the perspective of an outside observer. It is cut off from the rest of the universe by the geometry of space-time itself. But from the outside, a black hole is just a very dense, very compact object with a lot of gravity. It doesn't suck things in any more than a star of the same mass would. It doesn't roam the galaxy devouring everything in its path. It just sits there, quietly warping space around it, affecting the motion of anything that passes nearby, but otherwise doing nothing. Most black holes are isolated, alone, drifting through the galaxy, invisible except for their gravitational effects on nearby objects. We infer the existence of black holes by watching how things move near them. We see stars orbiting invisible companions. We see gas and dust spiraling inward, heating up to millions of degrees from friction and compression, emitting X-rays before crossing the event horizon and disappearing. We see the light from distant galaxies bending and distorting as it passes near massive black holes at the centers of galaxy clusters. We see, in other words, the effects of intense gravity, and we infer the presence of something so dense, so compact, that it can only be a black hole. This is the nature of much of astronomy. We study things at a distance, we collect light and other forms of radiation, we measure motions and temperatures and spectra, and from those measurements, we build models, we make inferences, we draw conclusions about things we can never touch, never visit, never see directly. It is like hearing a distant ocean by watching the waves wash up on a shore. You don't need to see the source to know it's there. You don't need to visit it to understand its effects. Black holes, neutron stars, white dwarfs, these are the remnants, the endpoints, the final configurations that stars settle into after their fusion engines shut down and gravity finishes its work. They are not sad, they are not tragic, they are simply the outcomes of processes that have been playing out in the universe for billions of years, processes that follow from the fundamental laws of physics, processes that are as natural and inevitable as water flowing downhill or heat spreading from hot to cold. And now, as your breathing becomes slower still, as your body relaxes more completely, as your thoughts begin to drift and scatter like the outer layers of a star spreading into space, let me bring the focus back to you. Let me connect this story, this vast tale of stellar life and death and transformation, to the fact of your existence, to the reality of your body lying here in the dark, quiet and still. The atoms that make up your body are not new. They are old, some of them older than the Earth itself, older than the Sun, older than the solar system. They were forged in the cores of earlier stars, stars that lived and changed and released their contents into space billions of years ago. The carbon in your muscles, your skin, your DNA, carbon that is the foundation of all organic chemistry, all life as we know it, was created in the cores of red giants through helium fusion and then released into space when those stars shed their outer layers. The oxygen you breathe, the oxygen that your cells use to extract energy from food, was forged in massive stars and scattered by supernova. The calcium in your bones, the iron in your blood, iron that carries oxygen through your body, that makes your blood red, was created in the final stages of massive stellar evolution and distributed by supernova explosions. Even some of the heavier elements in your body, Elements like iodine in your thyroid, copper in your enzymes, zinc in your proteins were created in the intense conditions of stellar explosions or in the collisions of newt stars. Events so energetic, so extreme, that they produce elements that cannot be made any other way. You are, quite literally, made of older light that learned new shapes. You are the product of stellar alchemy, of fusion reactions that took place in the hearts of stars, of explosions and winds and slow releases that distributed that material across the galaxy. You are the universe's way of organising some of its matter into a form that can think, that can wonder, that can lie in a dark room and contemplate its own origins. This is not meant to make you feel small or insignificant. It is meant to make you feel connected, to help you understand that you are not separate from the cosmos, but part of it, woven into the same fabric, subject to the same laws, made of the same substance. The atoms in your body have been on a journey that spans billions of years and incomprehensible distances. They have been in stars. They have been in nebulae. They have been in the interstellar medium. They have been in the disk of gas and dust that collapsed to form the solar system. They have been in asteroids and comets. They have been in the early Earth, in the oceans, in the atmosphere, in living organisms, in the food you ate, in the water you drank, and now they are in you, arranged in the particular pattern that constitutes your body, your cells, your tissues, your organs, and they will not stay in you forever. When you die, when your body breaks down and returns to the earth, those atoms will be released. They will enter the soil, the water, the air. They will become part of other organisms, other structures, other patterns. They will continue the cycle, the endless transformation, the patient rearrangement that the universe has been engaged in since the beginning. Nothing disappears. Nothing is lost. Everything only changes form. Let that thought settle into you now, not as something to hold tightly, not as something to analyze or remember in detail, but as a kind of background presence, a gentle reassurance. You're made of stellar material. You're connected to the deep history of the universe, and when your life is complete, you will become part of that history in a new way, your atoms returning to the great pool, the great reservoir, the great cycle of matter and energy that has been going on for so long and will continue for so long to come. The universe has been practicing transformation for billions of years. It has been taking matter and energy and rearranging them into new forms, new structures, new possibilities. It has created stars and planets, galaxies and clusters, nebulae and black holes. And through all of this, through all the immense variety of forms and structures, it has never lost a single atom, never destroyed a single bit of matter or energy, only moved it, changed it, reorganized it. And it does all of this without hurry. The universe is patient. It has time. It has all the time that exists because time itself is part of the universe, and the universe is not rushing toward any deadline. Stars burn for millions or billions of years. Nebulae drift and expand for thousands or millions of years. White dwarfs cool for trillions of years. The processes are slow. The timescales are vast. There is no urgency, no anxiety, no sense that things must happen quickly or all will be lost. This is a kind of comfort if you let it be. The universe is not in a hurry, and you don't need to be either. You can lie here, breathing slowly, letting your thoughts drift, letting your body relax, letting sleep come when it comes, knowing that you are part of something much larger and much older than yourself, something that has been unfolding for billions of years and will continue to unfold for billions more. Now bring your attention back to the room, to the space around you, to the feeling of the surface beneath you. You are here. You are present. You are lying in the dark, in the quiet, in the stillness that feels less like emptiness and more like presence. The universe is out there, beyond the walls, beyond the atmosphere, beyond the pull of Earth's gravity, full of stars in every stage of life, full of white dwarfs and neutron stars and black holes, full of nebulae and clouds and the raw material for future generations of stars and planets. But you don't need to go out there. You don't need to travel or explore or reach. You are already connected. You are already part of it. The atoms in your body are proof of that connection. The light that reached your eyes today, the warmth of the sun on your skin, the oxygen in your lungs, all of it ties you to the cosmic story, the long, slow, patient transformation that the universe is engaged in. And that story does not have sad endings. It has completions. It has transitions. It has phases that come to an end and new phases that begin. A star does not die the way a character in a storybook dies, with finality and closure and an end to all possibility. A star completes a phase of its existence and enters a new phase. It stops fusing hydrogen and becomes a red giant. It stops fusing helium and sheds its outer layers. It becomes a white dwarf, a neutron star, a black hole. And in each of these transitions, it releases material, energy, information back into the universe, where it becomes part of new structures, new patterns, new forms. The completion of one thing is the beginning of another. The ending of a star's fusion life is the beginning of a nebula's existence, and the beginning of the enrichment of the interstellar medium, and the beginning of the process that will eventually lead to new stars, new planets, new possibilities. Nothing is wasted, nothing is lost. Everything is used, reused, transformed, incorporated into the ongoing process of cosmic evolution. Let your breathing become even slower now. Let each breath be a little deeper, a little more effortless. You don't need to control it. You don't need to think about it. Your body knows how to breathe. It has been doing it since you were born, and it will continue to do it, automatically, reliably, maintaining the balance, the equilibrium, the steady exchange of gases that keeps you alive. In and out, like the expansion and contraction of a star's outer layers, like the ebb and flow of material between stars and space, like the slow pulse of cosmic time, vast and patient and unhurried. You are safe here. You are still. You are supported by the surface beneath you, by the air around you, by the gravity that holds you gently to the Earth. And the Earth itself is held by the Sun, and the Sun is held in orbit around the centre of the galaxy, and the galaxy is part of a larger structure, a cluster, a supercluster, a web, of matter stretching across the observable universe. Everything is connected, everything is held, everything is part of a larger whole, and in this moment, as you lie here on the edge of sleep, you can feel that connection, not as an intellectual idea, but as a physical reality. You can feel the weight of your body, the pull of gravity, the presence of the Earth beneath you. You can feel the air moving in and out of your lungs, the oxygen being absorbed, the carbon dioxide being released. You can feel the warmth of your skin, the heat generated by countless chemical reactions in your cells, reactions that are ultimately powered by the food you ate, which is ultimately powered by sunlight, which is ultimately powered by fusion in the core of the sun. You are a small part of a vast system, a tiny eddy in the great flow of matter and energy that constitutes the universe. And that is not a diminishment. That is not a reduction. That is simply the truth, and the truth is beautiful and comforting and worthy of quiet contemplation as you drift towards sleep. The stars above, beyond your ceiling, beyond the atmosphere, are not so different from you. They are systems in balance, maintaining themselves through the exchange of energy, resisting the pull of gravity through the pressure generated by their internal processes. And when they can no longer maintain that balance, when their fuel runs low and the pressure drops, they don't collapse into nothingness. They transform, they rearrange, they find a new equilibrium, a new state, a new way of being. A red giant is a star that has stopped fusing hydrogen in its core and has found a new configuration, a new balance, with shell burning and an expanded envelope. A white dwarf is a star that has stopped fusing entirely and has found a new configuration, supported by quantum pressure, slowly radiating away its stored heat. A neutron star is a collapsed core that has found a new configuration, supported by the resistance of neutrons to being compressed further. A black hole is a region where matter has collapsed completely, where gravity has won entirely, and yet even a black hole is not nothing. It has mass, it has gravity, it affects the space around it, it is a presence, a reality, a fact of the universe. None of these outcomes are failures, none of them are tragedies. They are simply the natural endpoints of stellar evolution, the places where stars settle when their fusion engines shut down and gravity is allowed to finish its work. And in settling into these new states, stars contribute to the ongoing enrichment of the universe, the ongoing cycle of transformation that makes possible the existence of planets, of life, of you. You can let go now. You can stop trying to hold on to the ideas, to remember the details, to keep track of the sequence. The information will be there if you need it, but right now, in this moment, you don't need to do anything except breathe and relax and let the words wash over you like a gentle tide, carrying you toward the shore of sleep. Even in the quietest night, even in the darkest room, even when everything seems still and silent, the cosmos is calmly reshaping itself. Stars are fusing elements in their cores. Nebulae are spreading and cooling. White dwarfs are radiating heat. Neutron stars are spinning. Black holes are warping space. Planets are orbiting. Moons are turning. Atoms are moving, colliding, bonding, breaking apart, rearranging themselves into new configurations, new molecules, new structures. And you are part of that process. You're not separate from it. You're not an observer looking at the universe from the outside. You are the universe looking at itself, thinking about itself, wondering about itself. You're a temporary arrangement of atoms that happens to be conscious, that happens to be capable of thought and feeling and awareness. And when this particular arrangement dissolves, when your life comes to its natural end, the atoms will not disappear. They will return to the great cycle. They will become part of other things, other patterns, other forms. They will continue the journey that has been going on for billions of years and will go on for billions more. Nothing disappears. Everything only transforms. Light becomes heat. Heat becomes motion. Atoms become new arrangements. And through all of this, through all the change and transformation and rearrangement, the universe maintains its essential character, neither creating nor destroying, only reshaping, only reorganizing, only finding new ways to express the fundamental laws that govern matter and energy and space-time. Let your eyes remain closed. Let your body remain still. Let your breathing continue, slow and steady in and out, like the pulse of a star maintaining its balance, like the flow of energy from hot to cold, like the drift of matter from one form to another across the vast expanses of cosmic time. You are held, you are safe, you are part of something much larger than yourself, something ancient and ongoing and patient. The stars have been shining for billions of years before you were born, and they will continue to shine for billions of years after you're gone, though not the same stars, not in the same configurations, because the universe is always changing, always transforming, always moving from one state to another, and that change is not something to fear, it is not something to resist, it is simply the nature of things, the way the universe works, the fundamental character of existence itself. Nothing stays the same forever, but nothing is ever truly lost. Everything continues in a new form, a new arrangement, a new pattern. The red giant that sheds its outer layers becomes a white dwarf and a nebula. The massive star that explodes becomes a neutron star, or a black hole, and a cloud of enriched gas. The nebula becomes new stars and planets. The planets become the stage for chemistry, for geology, for possibly even life. And life, if it emerges, becomes a new kind of complexity, a new way for the universe to organize itself, a new pattern of matter and energy that can think and feel and wonder about its own existence. You are that pattern. You are that complexity. You are the universe's way of knowing itself, of experiencing itself, of reflecting on its own nature. And right now, in this moment, as you lie here on the edge of sleep, you are doing exactly what you need to do. You are resting. You are letting go. You are allowing the natural processes of your body to take over, to guide you into sleep, into rest, into the deep, quiet renewal that sleep provides. There is nothing else you need to do. There is nowhere else you need to be. There is no problem you need to solve, no question you need to answer, no task you need to complete. You can simply be here, breathing, resting, drifting, letting the steady transformation of the universe carry you gently into sleep. The stars are distant lights, but they are not separate from you. They are connected to you through the long chain of cosmic history, through the atoms that were forged in their cores and scattered into space and eventually found their way into the cloud that became the solar system, that became the Earth, that became the biosphere, that became the food you ate, that became the cells of your body. You are made of the same substance, you follow the same laws, you are part of the same story, and the story does not have an end, not really. It has transitions, it has completions, it has phases, but the universe itself, the great totality of matter and energy and space-time, continues, it transforms, it rearranges, it finds new configurations, new possibilities, new ways to express the fundamental principles that have been operating since the beginning of time. You can rest in that knowledge. You can let it support you the way the surface beneath you supports your body. The universe is not fragile. It is not in danger. It is not running out or winding down in any immediate or worrying sense. It is simply doing what it has always done, what it will always do, transforming, rearranging, maintaining the great balance between matter and energy, between structure and chaos, between the pull of gravity and the push of pressure. And you, lying here in the dark, breathing slowly, letting your thoughts become softer and less distinct, you are part of that balance. You're part of that transformation. You're part of the universe's long, patient, unhurried process of exploring all the ways that matter and energy can be organized, all the patterns they can form, all the possibilities they contain. Let your breath slow even further now. Let each exhale be a release, a letting go, a gentle surrender to the process of sleep. You don't need to force it. You don't need to try. Sleep will come when it comes, and when it does, it will carry you into a different state, a different kind of consciousness, a rest that allows your body and mind to recover, to repair, to prepare for the next day. And while you sleep, the universe will continue its work. Stars will continue to fuse. Nebulae will continue to drift. White dwarfs will continue to cool. The great cycle will continue, turning, always turning, never stopping, never rushing, simply being what it is. A vast, patient, ongoing transformation that has no destination because it is not going anywhere. It simply is. And in being, it encompasses everything that exists, including you. You are safe. You are held. You are part of something much larger and much older than yourself. Something that knows how to continue, how to persist, how to transform without losing its essential nature. The universe has been doing this for billions of years. It knows what it's doing, even though it doesn't think, doesn't plan, doesn't have intention. It simply follows the laws, the principles, the fundamental patterns that govern how matter and energy behave. And those laws, those principles, those patterns, they are not arbitrary, they are not cruel, they are simply what they are, the way things work, the structure underlying all of reality. And within that structure, there is room for stars and planets, for galaxies and black holes, for nebulae and comets, for atoms and molecules, for chemistry and biology, for life and consciousness, for you. Let yourself drift now. Let your thoughts become less like thoughts, and more like the faint glow of a distant nebula, present but diffuse, visible but not demanding attention. Let your awareness of your body soften, become less distinct, less located, more spread out through the space around you. You're here, but you're also starting to not be here, starting to slip into that intermediate state between waking and sleeping, where thoughts become strange and logic loosens and time becomes uncertain. This is normal. This is natural. This is your brain beginning the process of sleep, beginning to disengage from the sensory world, beginning to turn inward to process the day, to organize memories, to restore and repair the systems that have been working all day to keep you alive and functioning. You can trust this process. You don't need to control it. Your brain knows how to sleep. Your body knows how to rest. They have been doing it every night of your life, and they will continue to do it, automatically, reliably, as long as you live. The universe is calm. The night is quiet. The stars are shining, distant and patient, fusing their elements, maintaining their balances, slowly working their way through their fuel, slowly approaching the transformations that will turn them into red giants, or white dwarfs, or supernovae, or neutron stars, or black holes, depending on their mass and their composition and their history. But those transformations are not happening now. They are far in the future for most stars, and even for those stars that are in the process of transforming right now. The process is slow, measured, unhurried. There is no drama. There is no violence. There is only change, gradual and inevitable and natural, the way all things change when given enough time. And you, lying here, are changing too, in your own small way. You're moving from wakefulness to sleep. You're transitioning from one state to another. And this transition, like all transitions, is not an ending but a passage, a movement from one phase to another, a completion of one cycle and the beginning of another. When you wake up, you will be rested. You will be renewed. You will have completed the cycle of waking and sleeping that all living things engage in, the rhythm of activity and rest that allows life to persist, to continue, to maintain itself across time, and the universe will still be there, still transforming, still rearranging, still following the laws that govern how matter and energy behave. Nothing will have disappeared, nothing will have been lost. Everything will simply have changed position, changed form, changed state in the endless dance of cosmic transformation. Let go now. Let yourself sink fully into sleep, into rest, into the deep, quiet renewal that your body and mind need. The universe is calm. The night is still. The stars are distant lights, softening, widening, changing as they complete their long, slow journeys through the cycles of stellar evolution. And you, made of their substance, connected to their history, part of their story, can rest in the knowledge that nothing disappears, that everything only transforms, that endings are not really endings but completions, transitions, the closing of one chapter and the opening of another. Sleep now. Let the steady transformation of the universe carry you gently into dreams, into rest, into the quiet darkness where your mind can wander freely, without purpose, without direction, simply being, simply resting, simply allowing the natural processes to unfold. The cosmos is reshaping itself even now, calmly, patiently, without hurry, without worry, without any sense of urgency. And you can let that calm carry you. You can let that patience hold you. You can rest in the knowledge that you are part of something vast and ancient and ongoing, something that has been transforming for billions of years and will continue to transform for billions more. Nothing disappears. Everything only changes. And change, when it happens slowly enough, when it happens as part of a larger cycle, when it happens in accordance with the fundamental laws of nature, is not something to fear. It is simply the way things are, the way they have always been, the way they will always be. Rest now. Sleep. Let the quiet lights of distant stars, the ones that don't go out but only soften and widen and change, let them be your guide into the deep, peaceful darkness of sleep. You are safe. You are held. You are part of the universe's long, patient, unhurried transformation, and you can rest. In that knowledge, let it support you, let it carry you into sleep. The story is complete. The cycle continues, and you, lying still, breathing slowly, are exactly where you need to be, doing exactly what you need to do, resting, releasing, letting go, drifting into sleep as naturally and as easily as a star sheds its outer layers into space, completing one phase and beginning another, transforming without disappearing, changing without being lost, continuing the endless dance of matter and energy across the vast expanse of cosmic time. Sleep. The next story is about to begin. Please relax and enjoy. You're lying down now, and the room around you is quiet. The air is still. Your breath moves in and out at its own pace. Nothing forced, nothing urgent. There's a softness to the moment, a kind of settling that happens when the day finally releases its grip. The light is low, or maybe there is no light at all. Either way, the darkness feels gentle, like it's holding space rather than taking it away. And here's something you might not have considered before. The dark isn't empty. Even now, in this quiet room, in this stillness, there is something present that you cannot see or feel in the usual way. It's not a sound. It's not a glow bright enough to notice. But it's here, all the same. A faint warmth, so subtle that your skin would never register it, but real nonetheless. It fills the room. It fills the space beyond the room. It fills everything, quietly, without announcement. You're not being asked to go anywhere tonight. You're not being asked to imagine distant places or strain toward understanding. You're simply being invited to notice what has always been here, humming softly in the background of existence, patient and steady and ancient beyond measure. There is a glow in this room, not from a lamp, not from a screen, not from the moon outside the window. This glow is older than all of those things, older than the window itself, older than the walls, the ground beneath them, the planet beneath the ground. This glow has been travelling for nearly the entire age of the universe, and it arrives here now, in the same moment you take your next breath. It's called the cosmic microwave background, but you don't need to hold on to that name. You can simply think of it as the afterglow, the universe's oldest light, still moving, still present, still filling every direction at once. It isn't a spotlight. It isn't a beam cutting through the dark. It's more like a wallpaper, soft and even, stretched across the entire sky and beyond. You can't point to it because it's everywhere at once, above the roof, behind the walls, moving through the air, passing through your body, through the earth, through everything. And here's the part that matters for tonight. It's harmless, it's steady, it's constant. It doesn't flicker or change or demand anything from you. It's simply there, an ancient presence that doesn't need your attention to continue. It was here before you arrived in this room, and it will be here long after you've drifted into sleep. Let that settle for a moment. The oldest glow in the universe is in this room with you, and it asks nothing of you. To understand where this glow comes from, you have to drift back gently, not with effort, but with the same kind of ease you might feel when remembering a dream. Long ago, so long ago that the numbers lose their meaning, the universe was different. Not just smaller, but fundamentally different in character. It was hot. Not the heat of a summer day or even the heat of a fire, but a kind of heat that filled everything, everywhere, all at once. The entire cosmos was dense and crowded, packed with energy and particles moving in every direction, colliding and scattering and glowing. Imagine a fog so thick you can't see your hand in front of your face. Now imagine that the fog itself is made of light and energy, and it fills every possible space. There were no stars yet, no galaxies, no planets, no quiet rooms like this one. There was only brightness and heat, a universe so full of energy that light couldn't travel freely. Photons, tiny packets of light, would try to move forward, only to be scattered almost immediately by the dense sea of particles around them. It was like trying to walk through a crowd so thick that every step is interrupted, every movement redirected. There was a time when the whole universe was like a warm lamp with no shadows, glowing in every direction, too bright and too crowded for anything to take shape. And you don't need to picture this with perfect clarity. You don't need to see it in your mind like a photograph. You just need to feel the idea of it, a cosmos that was all heat and glow, with no darkness anywhere to rest the eye. But nothing stays the same forever. The universe, for reasons that are woven into its very nature, began to expand. Not into something, because there was no outside to expand into. It simply grew, stretching itself, thinning out, cooling down. This wasn't a sudden event. It happened slowly, steadily, over hundreds of thousands of years, and as it expanded, the dense fog of energy and particles began to thin. Think of mist lifting from a field at night. At first, everything is obscured. Then, gradually, shapes begin to emerge. The air clears. You can see farther. The fog doesn't disappear. It just spreads out, becomes less dense, less intrusive. That's what happened to the universe. As it expanded and cooled, the particles that had been scattering light so aggressively began to settle down. They combined into stable atoms. The fog cleared. And then, for the first time, light could travel. This is the emotional heart of the story. This is the moment when the universe changed from something opaque and chaotic into something transparent and open. The photons that had been trapped, scattered endlessly in the dense early cosmos, were suddenly free. They could move forward without being interrupted. They began a journey that would last almost the entire age of the universe. Picture it like this: a gentle release, a soft exhale after holding your breath for too long. The light that had been churning in place, unable to go anywhere, was suddenly allowed to drift forward, to travel through the expanding space, to move without obstacle. This was the first long-distance light, the first glow that could cross vast stretches of the cosmos without being absorbed or redirected. And those photons are still moving. They've been travelling for billions upon billions of years, and they're still arriving. Right now, in this room. As you lie here, breathing slowly, letting your body soften into the surface beneath you. But here's the part that makes this story feel like a lullaby. The light didn't stay the same as it travelled. Expansion doesn't just move galaxies apart, it stretches the light itself. When those photons first began their journey, they were energetic, intense, carrying the heat of the early universe. But as the universe continued to expand, the wavelengths of that light stretched along with it. The light lengthened, cooled, softened. Imagine a note held on a piano, clear and bright at first. Now imagine that note held for so long that it begins to drop, shifting into a lower tone, then into a hum, then into something so deep and soft that you feel it more than hear it. That's what happened to the universe's first light. It stretched from visible light into infrared, and then into microwaves, a form of light so gentle, so low in energy, that it passes through you without a trace. This is the glow that surrounds you now. It's the same light that was released when the universe first cleared, but it's been stretched by billions of years of expansion. It's thin, it's quiet, it's patient, and it's still arriving, filling every corner of space, including the space where you're resting right now. Let that image settle. The ancient light is still coming. It didn't stop. It didn't fade into nothing. It simply softened, like a voice that's been travelling so far that by the time it reaches you, it's barely a whisper. And within that ancient glow, there are ripples, tiny, subtle variations, so small that for a long time, no one knew they were there. But they matter. They matter more than almost anything else in this story. Imagine a perfectly smooth surface, like a sheet of glass or a still lake. Now imagine that surface has the faintest texture, tiny bumps and dips, so slight that you'd only notice them if you looked very carefully. That's what the cosmic background light is like. It's not perfectly even. There are places where it's slightly warmer, places where it's slightly cooler. These differences are incredibly small, fractions of a fraction of a degree, but they were there from the beginning, imprinted into the light when it first began its journey. And those tiny ripples were the seeds of everything you've ever seen. The regions that were slightly denser, just a little bit more crowded with matter, had slightly stronger gravity. And gravity, patient and persistent, began to pull. Slowly, over millions of years, those denser regions attracted more matter. They became gathering places, and those gathering places eventually became the first stars, the first galaxies, the first clusters of galaxies. Every structure in the universe, every swirl of stars, every planet, every moon, every mountain, every body, every thought, began as a tiny ripple in the ancient glow. The universe was learning its structure, like fabric. Folding into gentle pleats, the cosmos was finding its shape, guided by those delicate variations in the background light. And you don't need to picture this as something dramatic or violent. You can imagine it as something quiet and slow, like clay settling into form, like ice crystals growing on a window overnight. The universe wasn't in a hurry. It didn't need to be. And here's the part that might feel strange and comforting at the same time. The afterglow is still here. The light that began its journey in the early universe is still arriving, from every direction, all the time. It's been travelling for so long that it feels like a permanent part of reality, like background silence. You could close your eyes, maybe you already have, and it would still be there, moving through the room, through your body, through everything. You're resting inside something ancient and constant. The cosmos doesn't rush. It doesn't force. It simply continues, carrying its oldest memory forward, through time, and you are here, within it, breathing softly, letting go. Imagine this. The room is wrapped in a thin, invisible warmth, as if the universe placed a soft blanket over everything and never removed it. It's not heat you'd sweat under. It's not something you'd need to push away. It's more like the idea of warmth, the feeling of being gently held without pressure, without weight. The glow is so faint that it doesn't intrude. It doesn't ask you to notice it. It simply exists, steady and soft, always present, always arriving. You can picture this however feels most comfortable. Maybe the glow is like a mist, so fine that it's almost invisible, filling the air around you. Maybe it's like a hum, so low that it's more of a feeling than a sound. Maybe it's like the light that lingers after sunset, when the sky is no longer bright but not yet fully dark. A kind of in-between glow that makes everything feel suspended and peaceful. However you imagine it, the anchor remains the same, soft, steady, harmless, always present, always arriving. The universe is not asking you to do anything with this information. It's simply offering it, the way the night offers stillness, the way your breath offers rhythm. You might wonder how anyone knows this glow is there. After all, it's invisible to the eye. You can't feel it as warmth on your skin. You can't hear it. So how did humans discover it? The answer is simple, and it fits the mood of this story. They listened. Not with their ears, but with instruments built to be quiet and patient, sensitive enough to notice the faintest signals. Scientists built antennas and detectors that could measure the temperature of the sky, and they found something unexpected. No matter where they pointed their instruments, north, south, east, west, up, down, they detected the same faint glow, the same gentle warmth. It was everywhere, evenly spread, like a whisper underneath all the louder sounds of the universe, and they realized what they were hearing, the afterglow of the early universe, still present, still moving, still filling every direction. They were listening to the oldest light, stretched and softened by billions of years of expansion, now arriving as a quiet microwave hum. This discovery didn't require drama. It didn't require force. It required patience. It required the kind of careful attention that comes from resting into stillness and noticing what's been there all along. Science, in this case, was a kind of listening, a willingness to be quiet enough to hear something faint. And that's what you're doing now, in your own way. You're not listening with instruments. You're not measuring anything. But you're here, present, allowing the idea of this ancient glow to settle into your awareness. You're noticing gently that you're not separate from the universe. You're not standing outside it, looking in. You're inside it. You're part of it. The listener isn't under the sky like a separate observer. You are inside the same ancient light, inside the same long story. Your atoms are part of the same chain that began in that early glow and unfolded into stars, planets, bodies, thoughts. The carbon in your cells was forged in the cores of stars that lived and died long before the Earth existed. The oxygen you're breathing right now was created in stellar furnaces and scattered into space when those stars exploded. The calcium in your bones, the iron in your blood, all of it came from the universe's long process of transformation. You're made of the cosmos, and the cosmos, in this moment, is noticing itself through you. This doesn't have to be a grand realization. It doesn't have to feel dramatic or overwhelming. Tonight it can be gentle. It can be as simple as recognizing that the stillness in this room is connected to the stillness of deep space, that the quiet you feel is part of the same quiet that surrounds distant galaxies, that the ancient glow moving through the room is part of the same glow that has been travelling since the universe first cleared. You're inside the universe's oldest memory, and you don't have to do anything with that knowledge. You can simply let it be. Let the glow do the travelling. You don't need to solve anything tonight. You don't need to picture anything perfectly or hold on to any thought with effort. The ancient light has already been travelling for you, moving through space, arriving quietly, doing its patient work. You can let go of effort. You can let go of the need to understand every detail. You can simply rest here, breathing slowly, feeling the weight of your body supported by the surface beneath you. Breathing becomes the only rhythm now. A slow inhale, drawing air gently into your lungs. A slow exhale, releasing everything you don't need to carry. The breath doesn't have to be perfect. It doesn't have to be controlled. It can simply be what it is, natural, easy, like the rise and fall of a wave, like the slow drift of clouds across a wide sky. And as you breathe, you can imagine that the ancient glow is moving with you, through you, around you. It's been moving for so long that it knows how to be patient. It knows how to arrive without force. It knows how to fill space without crowding it. And you can borrow that patience. You can let your thoughts slow down to match the rhythm of something that's been travelling for nearly forever. Even in stillness, something soft is moving. The glow is arriving. The universe is expanding. Your breath is flowing. And none of it requires your effort. None of it needs you to stay awake or alert or attentive. You can let yourself drift, knowing that the ancient light will keep travelling whether you're aware of it or not. It doesn't need your attention to exist. It simply continues, soft and steady, harmless and constant. You might feel your thoughts beginning to loosen. They might drift like leaves on the surface of a slow-moving river, appearing and disappearing. Without weight or urgency, that's okay. That's exactly what's supposed to happen. You don't need to hold on to anything. You don't need to remember every detail of this story. The story isn't here to be memorized. It's here to guide you into rest, to offer you a soft place to let go. And as your thoughts drift, you might notice the room around you again. The quiet is still here. The stillness is still here. The darkness or the dim light or whatever surrounds you, it's still gentle. still holding space. And beyond the walls, beyond the roof, beyond the atmosphere, the same faint background glow continues, unchanging, surrounding, gentle. The universe is carrying its oldest memory through the night, and you can let your thoughts loosen and drift with it. You can imagine that you're floating in that ancient glow, supported by something vast and soft, something that has no edges, no boundaries. You're not falling, you're not sinking, you're simply resting in the presence of something that has been here longer than anything else, something that will be here long after this moment has passed. And maybe, as you let yourself drift deeper, you begin to lose the sense of where the room ends and the universe begins. Maybe the walls fade a little, maybe the ceiling seems further away, or closer, or somehow both at once. Maybe you feel a kind of openness, as if the space around you is expanding gently, giving you more room to rest, more room to let go. This is what it feels like to be inside something infinite and patient. This is what it feels like to stop trying to hold the world together with your thoughts and simply allow yourself to be held instead. The universe doesn't need you to stay awake. It doesn't need you to keep watch. It's been carrying its own light for billions of years, and it will carry you too if you let it. Your breath is slower now. Each inhale is a little softer, a little quieter. Each exhale releases a little more tension, a little more weight. You might not even notice when the breaths become so gentle that they barely seem to move your body at all. That's okay. Your body knows how to breathe. It's been doing it since the moment you were born, and it will keep doing it, even as you drift into sleep. And as you drift, you can let the story fade. You don't need to remember the details. You don't need to hold on to the words. The only thing you need to carry with you is the feeling, the sense of being surrounded by something ancient and soft, something that doesn't ask anything of you, something that simply is. The oldest glow in the room is still here. It's here as you drift. It's here as you let go. It's here as your thoughts become quieter and quieter until they're barely there at all. And it will still be here when you wake and when you sleep again, and in every moment in between. The universe's oldest memory, travelling through the night, carrying you gently into rest. The room is calm, the air is still, your breath moves in and out at its own pace, and you don't need to guide it anymore. You can simply let it be. Let everything be. Let the ancient glow do its patient work. Let the universe hold you in its soft, invisible warmth. Let the night carry you wherever you need to go. You're safe here. You're surrounded by something vast and gentle. And you can let yourself drift deeper and deeper into the quiet, into the dark, into the oldest glow that has ever existed. Still moving, still arriving, still here. The universe began in brightness, and it has softened into this, a whisper of warmth, a faint hum of light, a presence so subtle that you only notice it when you stop trying to see it. And now, as you rest here, breathing softly, letting go of the day and all its weight, you can feel that presence around you. Not as something separate, not as something distant, but as something you're inside of, something you're part of. The glow is in the room, the glow is in the air, the glow is in you, and it's been here all along, patient and steady, waiting for you to notice or not notice, because it doesn't matter either way. The universe doesn't need your acknowledgement to continue. It simply continues, soft and endless and ancient, carrying its oldest memory forward through time. And you, lying here, breathing slowly, letting your thoughts drift away like smoke, are part of that memory. You are part of the story that began in the early universe and is still unfolding, moment by moment, breath by breath. You are part of the glow, let that be enough. Let the knowing be soft and distant, like something you remember from a dream. Let yourself sink deeper into the surface beneath you, feeling the support, feeling the stillness, feeling the quiet that surrounds you and fills you and holds you without effort. The universe is here, the glow is here, and you are here, inside it all, resting in the presence of something older than stars, older than galaxies, older than time itself. You don't need to understand it. You don't need to see it or feel it in any particular way. You just need to let yourself be held by it. The way the night holds the world, the way silence holds sound, the way the ancient light holds everything in its soft, invisible embrace. Your breath is so slow now, so quiet, that it's barely a movement at all. Just a gentle rise and fall like the surface of a calm sea, like the faint pulse of something distant and steady. And with each breath, you drift a little further, a little deeper, into the place where thoughts dissolve and the mind softens and the body becomes weightless. You're not here anymore, not really. You're somewhere else now, somewhere between waking and sleeping, between presence and absence, between the room and the universe. You're floating in the ancient glow, surrounded by the oldest light, held by something that has no name and no form, but is somehow more real than anything you could touch or see. And it's okay to let go completely. Now, it's okay to stop listening, stop noticing, stop holding on to the thread of this story. The story will continue without you. The light will keep travelling. The universe will keep carrying its memory forward. And you can simply drift deeper and deeper into the soft dark, into the quiet, into the place where sleep lives and dreams begin. The oldest glow in the room is still here, even as you let go. It's here in the silence, in the stillness, in the space between breaths. It's here in the dark, in the calm, in the gentle weight of your body sinking into rest. It's here in the night, in the universe, in the ancient light that has been travelling for longer than you can imagine, and will keep travelling long after you've forgotten this moment. You're inside the glow. You're part of the glow, and the glow is holding you, softly, steadily, as you drift into sleep. Let everything soften now. Let the room fade. Let the world fade. Let even the sense of yourself fade until there's nothing left but the quiet, the dark, the ancient warmth that surrounds you and fills you and carries you gently into the deep. The universe is breathing with you. The oldest light is moving through you, and you are safe, held, cradled in the arms of something so vast and so gentle that it has no edges, no boundaries, no end. Sleep now. Let the glow carry you. Let the night hold you. Let the ancient memory of the universe wrap around you like a soft blanket, and let yourself drift deeper and deeper into the oldest, quietest, softest place in all of existence. The room is still, the air is calm, and the oldest glow in the universe is here, surrounding you, filling you, holding you in its patient, timeless embrace. You can rest now. You can let go. You can drift into the dark knowing that the light is still there, still moving, still arriving, even in the deepest sleep. The universe is here, the glow is here, and you are here, inside it all, safe and held and surrounded by the oldest warmth that has ever existed. Rest now. Sleep now. Let the ancient light carry you home. The glow is soft. The glow is steady. The glow is here, and so are you. The story continues, but you don't need to follow it anymore. You can let it drift away, like a voice calling from a great distance, like the faint hum of something far away and long ago. You can let yourself sink deeper into the quiet, deeper into the dark, deeper into the place where the universe holds you without words, without thoughts, without anything at all but the soft, steady presence of the oldest glow. You're safe, you're held, you're surrounded by something ancient and infinite and impossibly gentle, and you can sleep now, knowing that the light will still be here when you wake, and when you sleep again, and in every moment in between. The oldest glow in the room, the oldest glow in the universe, the oldest glow in you. Rest now, let go, drift. The universe is carrying you home. The glow is here, and it has always been here, and it will always be here. This isn't a promise or a hope, it's simply the way things are. The light that began its journey when the universe first cleared has never stopped moving. It has passed through billions of years of space and time, through regions where galaxies formed and stars ignited, through voids so empty that nothing disturbs the silence for millions of light years, and it arrives here, now, in this room, in this moment, as you breathe softly and let yourself drift deeper into rest. You don't need to think about the journey. You don't need to trace the path of individual photons or imagine the vast distances they've crossed. All of that is happening without your attention, without your effort. The universe is doing its work, and you can simply be here, allowing yourself to be held by something that requires nothing from you. The ancient glow doesn't care if you understand it. It doesn't care if you remember its name or its story. It simply continues, patient and steady, filling every corner of existence with its soft, invisible warmth. And in this moment, as your body settles more deeply into the surface beneath you, As your breath becomes slower and more distant, you can feel that you're not separate from this process. You're not observing the universe from the outside. You're woven into it, part of the same fabric, part of the same long unfolding that began so long ago that the numbers lose all meaning. Your thoughts are drifting now, if they're there at all. They might appear like small shapes moving across a distant landscape, brief, vague, unimportant. You don't need to follow them. You don't need to hold on to them or make sense of them. They can simply pass through, the way clouds pass through the sky, the way the ancient light passes through the room, leaving no trace, asking for nothing. And as those thoughts drift further away, you might notice something else, a kind of spaciousness opening up inside you. It's not an emptiness that feels hollow or lonely. It's more like a clearing, a wide open space where nothing needs to happen, where nothing needs to be held or figured out or remembered. This is the space where rest lives. This is the space where sleep begins to gather, soft and inevitable, like water pooling in a low place, like darkness settling into the corners of a room as the last light fades. You can let yourself sink into that space. You can let yourself become part of it so that there's no longer a clear boundary between you and the quiet around you. The room is quiet. You are quiet. The ancient glow is quiet. And all of it together forms a kind of stillness so complete that it feels like the universe itself has paused just for a moment, just for you to let you rest. But the universe hasn't really paused. It's still expanding, still carrying its oldest light forward through time. Galaxies are still moving apart from one another, drawn by the gentle pull of expansion. Stars are still burning in the far reaches of space, fusing elements in their cores, creating the building blocks of planets and life. Black holes are still bending space around them, and nebulae are still glowing with the light of newborn stars. All of this is happening right now in the same moment that you're lying here, breathing softly, letting go. And yet, it doesn't intrude. The vastness of the cosmos doesn't overwhelm you. The ancient processes that have been unfolding for billions of years don't demand your attention. They simply continue, like a river flowing in the distance, like wind moving through trees on the far side of a valley. You can sense it if you want to. The ongoing work of the universe, the patient transformation of energy into matter and matter into form. But you don't have to. You can simply rest here, held by the same forces that hold galaxies together, supported by the same fabric of space that stretches across the entire cosmos. The oldest glow is still arriving, photon by photon, filling the room from every direction. If you could see in microwaves the way certain instruments can, the room would look bright, not with the harsh brightness of a spotlight, but with a soft, even glow, like the light that fills the sky just before dawn, when everything is quiet and cool and waiting. But you can't see in microwaves, and that's okay. You don't need to. The glow is here whether you perceive it or not, and its presence is enough. Just knowing it's here, or half knowing, or dreaming it's here, is enough to let you sink a little deeper, to let the edges of waking consciousness blur and soften. Imagine that the room is expanding very gently, the way the universe itself expands, not pushing outward against walls, but simply creating more space within itself, more room for you to rest, more room for your thoughts to spread out and dissolve. The boundaries become less clear. The sense of where you end and where the room begins starts to fade. You're still here, still breathing, still present in some way, but the presence is softer now, less defined, more like a feeling than a fact. And in this expanded space, there's a kind of freedom. You don't have to hold yourself together. You don't have to maintain a sense of who you are or where you are or what you're supposed to be doing. All of that can fall away, like leaves dropping from a tree in autumn, like snow melting into the ground in spring. What remains is something simpler. Just the quiet awareness of existing, of being held, of resting in the presence of something ancient and vast and endlessly patient. The universe has been patient with you since before you were born. It waited through billions of years of cosmic evolution for the conditions to be right, for stars to form and die and scatter their elements into space, for those elements to gather into new stars and planets, for one particular planet to develop the chemistry of life, for that life to evolve and diversify, and eventually produce you, here, now, breathing softly in the dark. The universe didn't rush, it didn't force, It simply unfolded step by patient step until this moment could exist. And now that you're here, the universe asks nothing of you. It doesn't need you to be awake or alert or productive. It doesn't need you to accomplish anything or understand anything or even stay conscious. It simply holds you, the way it holds everything, with a kind of care that doesn't require effort or intention. You're being held by gravity, by the structure of space itself, by the ancient light that fills every direction. And you can trust that holding. You can let yourself be supported completely. Your breath is barely noticeable now, just the faintest rise and fall, like the gentle swell of the ocean on a calm day, like the slow pulse of something far away and deeply peaceful. You might not even feel it anymore. You might have drifted beyond the awareness of breathing into a place where the body takes care of itself and the mind has nothing left to do. That's the place where sleep lives. That's the threshold you're crossing now, so slowly and so gently that you might not even realize it's happening. One moment you're here, listening to these words, following the thread of the story. The next moment you're somewhere else, somewhere softer and darker and quieter, where words don't reach and stories don't matter, and the only thing that exists is the deep, restful dark. But before you cross completely, before you let yourself drift all the way into sleep, there's one more thing to notice. The ancient glow, the soft, invisible warmth that fills the room and fills the universe, is moving through you right now, not in a way that you can feel with your skin or detect with your senses, but in a way that's real nonetheless. The photons that were released when the universe first cleared are passing through your body at the speed of light, moving through the spaces between your atoms, through the cells and tissues and bones that make up the physical form you inhabit. You're transparent to the ancient light. It doesn't see you as an obstacle. It doesn't bounce off you or get absorbed by you. It simply passes through the way it passes through everything, continuing its journey that began so long ago and will continue for so long into the future that the end is beyond imagining. And in this moment, as the light moves through you, you are part of its story. You are part of the universe's long memory, part of the journey that began in brightness and has softened into this gentle, invisible glow. You don't need to do anything with that knowledge. You don't need to feel special or chosen or significant. You simply are. You exist, here, now, in this moment, and that's enough. The universe doesn't need you to be anything other than what you are, a collection of atoms briefly organized into a form that can think and feel and rest, surrounded by the oldest light, held by the oldest forces, part of the oldest story that has ever been told. And now, as you drift deeper, as the last threads of waking awareness begin to dissolve, you can let even that sense of yourself fade. You don't need to be anyone right now. You don't need to maintain your identity or your thoughts or your sense of place in the world. You can simply dissolve into the quiet, into the dark, into the ancient glow that surrounds you and fills you and carries you gently into the place where sleep and dreams and deep rest all merge into one. The room is gone now, or nearly gone. You might still sense it dimly, like a memory of a place you once knew, but it's no longer solid or immediate. The walls have faded, the ceiling has faded, even your own body has become vague and distant, like something you're aware of from far away, like something that belongs to someone else. What remains is just the glow, just the soft, steady presence of the universe's oldest light still arriving, still moving, still holding you in its patient embrace. And you can rest in that presence completely, without reservation, without holding anything back. You can let yourself be carried by the light, the way a leaf is carried by a stream, the way a bird is carried by the wind effortlessly, without struggle, without resistance. The universe is carrying you now, not to any particular place, because there's nowhere you need to go, just carrying you deeper into rest, deeper into the quiet, deeper into the soft dark where all effort ends and all holding on releases, and all that remains is the simple fact of existing, held and surrounded and filled by something so ancient and so vast that it has no beginning and no end. Sleep is here now, or very close. You can feel it gathering around you like a soft fog, like a gentle tide rising slowly over sand. It doesn't rush. It doesn't push. It simply arrives, inevitable and patient. And you can let yourself meet it without resistance. You can let the last fragments of waking consciousness slip away, let the last thoughts dissolve, Let the last sense of being anyone or anywhere fade into the dark. And as you do, as you cross that threshold between waking and sleeping, between presence and absence, you might feel something shift, not in the room, not in your body, but in the quality of the moment itself. The universe seems to soften even further, to open up in a way that has no shape or form, but feels like infinite gentleness, infinite space, infinite patience. You are being welcomed into the deepest rest, into the place where the cosmos holds its own stillness, into the ancient quiet that has existed since before the first stars were born. The glow is still here. It will always be here. And you are part of it, now and always. Even as you drift into sleep, even as you let go of everything, even as you sink into the deep dark where dreams live, and the mind rests and the body repairs itself and the universe continues its patient work of expansion and transformation. You don't need to stay awake any longer. You don't need to hold on to this moment or this story or this awareness. Everything is taken care of. Everything is held. The universe is doing its work, and you can simply rest, knowing that you are safe, you are surrounded. You are part of something so much larger than yourself that your individual concerns and worries and thoughts are like tiny ripples on the surface of an infinite ocean. Present, but not important. Noticed, but not held. Let yourself drift now. Let yourself fall gently into the soft dark. Let the ancient glow carry you deeper and deeper, beyond thought, beyond awareness, beyond anything except the pure, simple fact of resting in the presence of something vast and gentle and endlessly patient. The oldest glow in the room is still here, surrounding you, holding you, filling every corner of space with its soft, invisible warmth. And you are here too, or what remains of you, just a quiet presence, a soft awareness, a gentle sense of existing without effort or intention. And even that can fade now. Even that can dissolve into the dark, into the quiet, into the deep rest that the universe offers freely to everything it holds. You can let yourself disappear into sleep, into dreams, into the place where the boundary between you and the cosmos becomes so thin that it vanishes completely. And all that remains is the ancient light, still moving, still arriving, still holding everything in its patient, timeless embrace. Sleep now, rest now, let the glow carry you home. The universe is here, and you are here, and the oldest light is here, and all of it together forms a kind of perfect stillness, a perfect quiet, a perfect rest. Let yourself sink into it completely. Let yourself become part of the glow, part of the dark, part of the ancient memory that the universe has been carrying for billions of years and will carry for billions more. You are safe, you are held, you are home, and the oldest glow in the universe is here, now and always, surrounding you with its soft, steady presence, asking nothing, offering everything, patient and constant and endlessly gentle. Rest, sleep, drift, dissolve. The universe is holding you, and you can let go. The light is here, and you are here, and there is nothing left to do but rest in the presence of something so ancient and so vast that it makes all your worries seem small, all your thoughts seem distant, all your waking concerns fade into the background like stars disappearing at dawn. Let the ancient glow fill you. Let it carry you. Let it hold you in its soft, invisible arms. And sleep now, deeply and completely, knowing that the universe is here, the light is here, and you are part of it all now and always, in this moment and in every moment, in this sleep and in every sleep, in this rest and in every rest that has ever been or ever will be. The oldest glow in the room, the oldest glow in the universe, the oldest glow in existence. It's here, it's holding you, and you can rest completely, knowing that you are safe, you are surrounded, you are part of something infinite and gentle and endlessly patient. Sleep now, and let the universe carry you into the deep, into the quiet, into the soft dark where all things rest and all things are held, and all things are part of the same ancient light. The next story is about to begin. Please relax and enjoy.